Welcome on board of this course. I am really happy to see that you joined this course. MongoDB is an exciting technology, an exciting database solution, and even more than just a database solution, as you will learn throughout this course. And you can use it in basically any project you're building. If that's a website, a mobile app, a desktop app, or if you're working as a data scientist, you're probably working with some kind of data. You need to store data, you need to fetch data, and you need to do all of that fast and efficiently without worrying too much about database configuration, setup, and data structures. And MongoDB is an awesome solution for that. In this course, I'll thoroughly walk you through MongoDB and teach you everything you as a developer need to know. I'll teach you how to use MongoDB, how to structure your data there, how you can depict relations in a MongoDB world, how you can do configurations on your database, and most importantly, how you can perform efficient and powerful CRUD operations with MongoDB in a broad variety of ways. This is a very comprehensive course on MongoDB, and I'm super excited to dive into it with you. Now, who am I? My name is Maximilian Schwarzmuller. I'm a freelance web developer and 5-star rated instructor here on Udemy. I got a lot of courses, and I got courses as well as free YouTube videos on my channel, Atomicity, where I do already use MongoDB. But the complete course on it was missing. And since it's such an awesome technology and such an awesome database, it was about time to dive into it so that you can become a true MongoDB master. Now, this is a hands-on approach course. That means there will be slides, there will be theory, because you always need that, but most importantly, there will be a lot of working with MongoDB, where I work with MongoDB and you can work with MongoDB whilst following along in the videos. So that should be a lot of fun. Now, let's dive into the course and let's start with the most important question: what is MongoDB? So what is MongoDB? MongoDB is, most importantly, a database. It's a database, but the company behind MongoDB, which is focused on that database and a couple of our products, which I'll also talk about in this course. So the company behind that is also called MongoDB. But with MongoDB, I of course mean the database. Now, the name is stemming from the word humongous, because this database is built to store lots and lots of data, and not just from a data size perspective, but also in the sense of you can store lots of data and you can then work with it efficiently, which of course also is super important. So this is MongoDB. It's a database solution. Now, of course, we already got database solutions. We got MySQL, we got Postgres, we got thousands of database solutions already. So how is MongoDB different? Well, MongoDB, of course, also is most importantly a database server that allows you to then run different databases on it. So we might have a shop database running on our MongoDB server, because the MongoDB environment basically gives you a server which you start, on which you can then create multiple databases using MongoDB. So we have a shop database. In the MySQL world, we also have databases, and in such a database, we would have tables. In MongoDB, we have so-called collections. So in our shop, we might have a users and an orders collection. We probably would also have a products collection, but this is just an example, of course. So we have these collections inside our database, and you can have multiple databases and multiple collections per database. Now, inside of a collection, you have so-called documents, which look like this. Now, these documents, if you are having a JavaScript background, might look familiar to you. They look like JavaScript objects. And indeed, this is basically how you store data in MongoDB. You use this document format, this object format, as you know it from JavaScript. And you might even notice here that inside a collection, you are schemaless. This second document does not look like the first one. The H is missing. And this is a flexibility MongoDB gives you. It is really all about flexibility. Where SQL-based databases are very strict about the data you have to store in there, MongoDB is more flexible. You can store totally different data in one and the same collection, and therefore your database can grow with your application and your application needs. Of course, typically you will have some kind of structure in one collection because your app typically requires some type of structure to work with the data. And in this course, we'll actually have a whole module where I talk just about data structures and relations, and where I will make it clear how you can structure it, how you can follow best practices, how you want to structure different related data, and so on. But you are schemaless, and that is one important thing. Now, inside a document, as I mentioned, you use these JavaScript objects to store your data. To be precise, you use a format called JSON. And this is how a document would look like. In JSON, a single document is surrounded by these curly braces, and you will see that once we start working with it. And then we have our keys in there, so that would be a key. And a key consists of a name of that key here, which has to be surrounded in double quotation marks. So name, age, address, and hobbies would be key names here, or also keys. I will also refer to them as just keys. Then we have a colon, and then we have the value of that key. So here we have max, which would be some text, a string, and therefore also has to be enclosed in double quotation marks. But you can also store numbers without double quotation marks then. You could store booleans, true or false. And you can even store nested data, as you can see. The address key, or field, as you could also call it, has an embedded document. So this again has curly braces in there, and then another key value pair. And this is another cool feature of MongoDB and its documents. You can store nested data in there. And why is that helpful? Well, this allows you to create complex relations between data and store them in one and the same document, which makes working with it and fetching it super efficient. Where in SQL, you have to write complex joins to find data in table A and data in table B, here you can fetch it all in one document and you're good to go. So this is highly efficient and allows you to store data in a logical way. Hobbies shows you another example of data you can store in a document. Here we have a list of embedded documents, and you could also have a list of strings or numbers. So storing lists is also possible. And this all together is then one document inside a collection. Now in the title it also says BSON instead of JSON. Well, behind the scenes on the server, MongoDB converts your JSON data, which is this format you see here, to a binary version of it, which can basically be stored and queried more efficiently. You don't need to worry about that. We work with this JSON thing, we work with this object thing throughout the course. So this is the data we store, this is a document, and the whole theme of this video and of MongoDB really is the flexibility and the optimization for usability. And that is really what sets MongoDB apart from other database solutions and which makes it so awesome and so efficient from a performance perspective too. Because you can query data in the format you need it instead of running complex restructurings on the server. Now, you may or may not have a SQL background, but when I started working with MongoDB, there was one thing which I found kind of hard to wrap my head around. MongoDB is a so-called NoSQL solution, because it's basically following an opposite concept or philosophy than all the SQL-based databases do. Instead of normalizing data, which means storing it distributed across multiple tables where every table has a clear schema and then using a lot of relations, instead of doing that, MongoDB goes for storing data together in a document, and it also doesn't enforce a schema on you. So we got no schemas in MongoDB. If we have multiple documents in one and the same collection, they can have different structures. That is one thing I mentioned in the last video. And this is really important. This can, of course, lead to messy data, but it's still your responsibility as a developer to work with clean data and to implement a solution that works. But on the other hand, it gives you a lot of flexibility, and flexibility is always good. You can use MongoDB for apps that might still evolve, where the exact data requirements are just not set yet. You can get started, and you can always add data with more information in a collection, in the same collection, at a later point of time. You also work with less relations. There are some relations, and I have a whole module where I talk about that, but with these embedded documents, which I already showed you, one core thing of MongoDB indeed is that you have less tables, so less collections, which you connect, but instead that you store data together. And this is where the efficiency is derived from. Since data is stored together, when your application is fetching data, it doesn't need to reach out to collection A, merge it with collection B, merge it with collection C. Instead, it goes to collection A. Then MongoDB has a very efficient querying mechanism behind the scenes so that it can go through all the data very fast when looking for a specific document. So this will be super fast. And then it finds that document and it's done. It doesn't need to do any merging most of the time. So this is really where the speed, the performance, and the flexibility comes from, and this hopefully speaks for itself that this can be useful when building applications. And this is also why NoSQL solutions, and amongst them most of all MongoDB, is super popular for read-write heavy applications, applications with a lot of workload, applications that store a lot of data, let's say smart devices, which send some sensor data every second. For such applications, but also for building an online shop or a blog, MongoDB is an amazing solution due to the performance and the flexibility it gives you. So now that I introduced MongoDB, what it is, and how it roughly works, let me take a step back and go back to the MongoDB company. As I mentioned, the company behind the MongoDB database solution is also called MongoDB. And actually, they have a couple of other products too, and I will have a look at a lot of them throughout this course. So how does the MongoDB ecosystem look like? Obviously, we got the MongoDB database, which is their core asset, the core feature, and the core topic of this course, and probably the reason why you took this course. There you have a self-managed and an enterprise solution. We'll work with the community, with the free community version in this course, which has all the features we need. But of course, I will also dive into deploying that and showing you a way of getting your local database, with which we'll play around in this course, into the web and how to use it on a real app. No worries. Then they have some tools that are related to managing that database. That is more of a system admin, database admin task. I'll not cover it in this course because this is a course for you as a developer. And they have a cloud solution. That is something I will cover because this is an amazing solution for you as a developer, because all the managing a system administrator would have to do is done for you there. And you can focus on the data and your logic there. So this is awesome, and we will use that in this course too. But we'll also work locally, no worries. They also have a mobile solution, which basically means you can install MongoDB on a mobile device to store data there directly and even work without an internet connection. They got a graphical user interface, Compass, which allows you to connect to your database and look into it with a nice user interface. We will also use that in the course, but most of the time we will not, because as a developer, you of course write code. You don't click around in graphical user interfaces, and therefore we will, well, write code in this course. And we got also some other tools like BI connectors or MongoDB charts if you're more on the data science area. This is not really something where you will write a lot of code. These are more tools that allow you to connect different analytics tools if you need that. Now, this is the entire database world. And this is, of course, their core feature. Hence, they have a lot of products there, as you can see. Now, they also got a relatively new offering, which is called Stitch. And Stitch is basically their serverless backend solution. So this is a bit decoupled of the database, still strongly connected, but also it offers you more than just data storage. Stitch, for example, gives you a serverless query API. And you will see this towards the end of the course, where I have a whole module about Stitch and where I introduce the core products they have in that Stitch environment. So there you will see that this is essentially a tool set, a tool which you can use to efficiently query your database directly from inside your client-side apps. So from inside your React app or anything like that. But this will become clearer in the Stitch module, of course. You also have serverless functions, which allows you to execute code in the cloud on demand. So now this is totally unrelated to the database. You can execute any JavaScript code in the cloud there. And if you know something like AWS Lambda or Google Cloud Functions, this is your equivalent. We also have database triggers, which is basically a service that allows you to listen to events in a database, like a document was inserted, and then execute a function in response to that. And that function could then maybe send an email to a user informing him about that document being inserted, something like that. And there is a feature called real-time sync, which basically is built to synchronize a database in the cloud with that mobile offline supporting database you might have on mobile devices. This is the current snapshot of their ecosystem. The focus of this course is on the MongoDB database, which we'll use locally and in the cloud with Atlas, and how you can work with that, how you can use CRUD operations, how you can retrieve your data efficiently, and all of that. But I will also dive into Compass, I will also dive into the Stitch world and introduce you to that in this course. So enough of the theory for now. Let's install MongoDB and all the tools we need for spinning up databases, for interacting with databases. And the best place to start with that is mongodb.com. Now, on this page, you got various offerings. You got cloud services and you got software. Now, cloud services are, in the end, managed MongoDB servers running on some cloud machines, so hosted by the MongoDB company. And we'll take a look at some of these parts later in the course. For the moment, let's focus on software, which is software we install locally on our system. Now, in this lecture, I'll start with macOS. In the next lecture, I'll show you how to install and start MongoDB and the MongoDB server on Windows. For Linux, I unfortunately don't have a Linux machine, so therefore there I have to point you at the official docs, and therefore you should actually stick around for a couple of extra seconds here, even if you are not using Mac, because I want to dive into those docs together with you first, before we then do continue with the macOS setup in this lecture here. But first of all, let's take a closer look at the software we can install. Most importantly, we got a community server and an enterprise server. Now, the community server is a free version of MongoDB of all you need for working with MongoDB, and that's the version we're going to use in this course. The enterprise server adds more additional enterprise level features, but this does not affect how MongoDB works or which commands you can execute. Instead, here we're talking about additional configuration or security features that might matter to you if you are a big enterprise. But for developing with MongoDB, the community server is all we need. And when it comes to deploying MongoDB, we'll take a look at these cloud offerings again later. Now, we also got more tools. Most importantly, Compass is also noteworthy. It's a graphical user interface that allows you to interact with your database and to view the data in your database. It's a little bit like MySQL Workbench for MySQL, if you've worked with that, but we'll ignore it for now. Instead, we'll install the community server, and for this we can click on it, and we should be taken to a page that looks something like that. Here you can select a version, and I'll use the latest stable one, and then your operating system. Actually, your operating system should already be pre-selected, but you can select from a wide range of operating systems here, including Windows and a bunch of Linux distributions, to make sure you're downloading MongoDB for the correct system. And then you can click this download link here to start the download and download MongoDB or these core tools that you need onto your system. Now we'll take a look at what we downloaded there in a second, but for the moment let's go to the docs here, the documentation. And here we want to go to the server documentation, which actually is a great resource to look up MongoDB features in general. And we're going to go through all these key features throughout this course. For the moment, let's dive into the installation documentation. And here we want to view the docs for installing the Community Edition. And now you can choose the guides for your operating system. And it's a great idea to go through these written guides in addition to this video, especially if you should get stuck or if you are on Linux. Now, if we install it on macOS, we got different ways of installing MongoDB. We could also install it with Homebrew, which is a command line tool you can run on your system. But we did actually download this tarball, so we're going to go through these installation steps here. And now in there, we first of all have to download this tarball, this zipped folder in the end, which we did a couple of seconds ago. Then we have to unzip it, which you can do as instructed here, but even easier than that, you can also just locate that downloaded TGC file, which is in the end just a zipped file, and double click on it in Finder. Here I moved it into some software folder, which I created somewhere in my user folder on macOS, but you can move and extract it anywhere you want. Then I'll delete the zip file, and then here I got a folder with a couple of files in it, especially with a bin folder inside of it, where we then got a variety of executable files in the end. And for us, the most important files will be the MongoD and the Mongo file. MongoD will be an executable file that actually allows us to start the MongoDB database server, which is the server that hosts the databases and which needs to be up and running for us to interact with them and with the data in them. And the Mongo executable actually will be a shell which we can use to talk to that server. So that will be the tool we use for running queries against the database server. Now, as I mentioned before, there also is a graphical user interface you could use, MongoDB Compass, but actually for this course, we're going to stay in the shell because it is about learning these commands and query commands, and while executing them through the shell is the most straightforward way of doing so. A graphical user interface can be a nice tool to help, but it will not be our main way of interacting with MongoDB. So that's why these will be the two important things for us in this course section here. But how do we now execute these files? You could double click on them, but that's not really how we want to do that. Instead, we want to invoke them through the terminal here on macOS. And to do this efficiently, we want to make them available as global commands on our system. And the official documentation tells us how we can do that. Effectively, we got these two approaches here, which we can use. We can copy the files into this user local bin folder here, or we create so-called symbolic links. Now, this might sound a bit more advanced, and these commands might look a bit more advanced, but in the end, what we're doing with that is we're turning these executable files into commands we can run from inside the terminal on our system. Now, to make that all work on macOS, it's easiest if you right-click onto that bin folder, and you then open a new terminal at that folder. Alternatively, you open your terminal just like that, and you then cd, you navigate into that path where these files are located, so into that bin folder here ultimately, but it's easiest if you just do right click here and open the terminal already navigated into that path by clicking this option. And then what you want to do is you want to run this command here from the official docs. So copy that command, paste it in there, but don't execute it yet. Instead, since we're already in that bin folder, we want to shrink this first part here to just copy /star, which copies the content of the current folder into this folder, which we want to keep. Then hit enter, and you might be prompted for your password here. And once you entered your password correctly, which I didn't manage to do on the first two tries, as you can see, this should be done. Now, to verify that this now all worked, simply type Mongo into your terminal, and this might now give you a warning like this, so that it's not allowed to start. If that happens, go to your system preferences, and there to security and privacy, and then there click on allow anyway. Do the same for all the other MongoDB commands you might execute throughout this course whenever you get this warning you just saw. Once you did that, if you try running Mongo again, this time we get a different warning. We can click open there, and now it executes. It still crashes because actually it fails to connect to a MongoDB server, but it at least did recognize this command now, and that's the important thing here. Now, what's missing at this point, though, is the database server itself. We need to start that before we can actually successfully run Mongo, the Mongo shell, and connect to it and work with it. Now, the database server would be started by running the MongoD command, but before we run this, we have to prepare our system a little bit. To be precise, we have to prepare paths, folders on our system where MongoDB will be able to store the actual database data and some log files. Because when working with a database like MongoDB, but the same is true for all databases, of course, eventually the data will be written to your hard drive, and you need to tell MongoDB where the data should be written to. Therefore, what you want to do is you want to create some path on your system where that data should be stored. And for this here, I got a development folder, which is directly in my user folder, where I will create a MongoDB folder, and in there I'll add a data folder and I'll add a logs folder. Now you can add such a structure anywhere on your system, just make sure that it's somewhere in your user folder in the end so that you have full read and write access to it. So don't create it in some reserved system path or anything like that. Instead, your user folder is a good starting point, and then some subfolder there is a good starting point. In my case, this development folder, where I then have the MongoDB folder, where I have these folders I just created. So you should create a structure that looks something like this, folder-wise. Now, once you have these empty data and logs folders, you can actually now start MongoD. Now, first of all, we can run MongoD just like this because it will fail anyways, because macOS will block it. So to work around that, again, we go to the system preferences and allow this anyways. And now we could run it successfully, but before we now run it again, we want to configure it a little bit. So we'll type MongoD and then a blank. And now we want to make MongoDB aware of the data and logs paths we just created. And for this, you add a so-called flag, a so-called option to this command, to configure this command. You do this by typing -- and then dbpath is the option name we want to add here. And with that, we can tell MongoDB where the data should be stored. So that's a special option MongoDB will be watching for. Then you add a blank and then the path where the data should be stored. And to get that path, you can go to that data path you created and right-click on it and choose Get Info here on macOS. And then you can copy this path here in the where part and paste it in here. And now just make sure that it ends with /data or whichever name you chose for your data folder. So that is the first important part. With that, we'll tell MongoDB where to store the data, and you want to add this option whenever you restart your MongoDB server. For example, if you shut down your operating system and you restarted it, and you now want to restart your MongoDB server to work with it again, you have to restart it like this again. But we're still not done. Add another blank. And here, for me, it's doing it in a new line because I ran out of space here, but it's technically still the same command in the same line. It just added this line break for readability reasons. Don't hit enter because that would confirm the command and you don't want to do that yet. Instead, just add a blank and then also add another option with -- and that's the log path option. And here we now want to get the path to our logs folder, which of course is the same path, just ending with /logs in my case, to point at this logs folder. Now for the logs, you then also actually have to point at a concrete file that should be created, so add another / and then mongo.log, like that. The name is up to you, but mongo.log is a common name for that log file. For the data path, you did not specify such a file. Now you can hit enter and you might see another warning where you have to confirm that you want to open this command, this tool. But with that, eventually, it should now start this MongoDB server successfully. And you can tell that it's successful by the fact that it does not crash and that you now started such an ongoing process. You're not back to the regular input mode anymore. Instead, this is a running process which you can always quit with Ctrl-C. So by pressing Ctrl-C. But if you do quit, you won't be able to interact with the database anymore. You have to restart it then to do that again. So as long as you are working with that MongoDB database, you want to keep that process up and running. So you don't want to close that terminal window and you don't want to hit Ctrl-C here. Instead, now we can open a new terminal window, for example, by pressing Command-N here on macOS. So I still have the other process running here, and now I have my new window here. And in here, we can now try to connect to this running server. And we do this by running this Mongo command, which I showed you before, which under the hood uses this Mongo shell. If you hit enter like this, it should automatically connect to your server. It gives a bunch of log information output here, but eventually it will connect. And now that you are connected, you can interact with that server. For example, in here, you can run show DBs to see all the databases that are running on your database server. And you will have some default databases out of the box here. Now that's the point where we'll stop here. We'll pick up on this in the next lectures. By the way, there I'm also using the light theme of the terminal, but other than that it's the same. But now with that, we have that running MongoDB server on macOS. Again, if you're facing any problems here, definitely have a look at these official docs for macOS to go through the installation step by step again with help of that written guide and eventually have that running server and connected shell on your system as well. Now let's continue with Windows. In the previous lecture, we installed MongoDB on macOS and we had a look at the documentation and so on. In this lecture, we're going to install it on Windows. Now again, we're going to dive into the cloud offerings later. For the software offerings, we again want to install the community server, and now we want to install the community server on Windows. It should automatically select the correct operating system here on the right. If not, select Windows manually. And then you can simply download the MSI package, which is an installer which is more convenient to use to install MongoDB than using the zip file. So let's download this installer. And this can take a short while until it's done, since the package is rather big. But I'll be back once the download finished, and then we're going to walk through this installer together. Okay, so the installation finished for me. Now I'll start this installer and we'll walk through that together. Of course, we have to accept the license agreement, and then I'll choose the custom installation mode here. Now here we want to make sure that all these items are selected, client and server. The server will be the thing serving our databases and storing our data. The client will be a tool we use on our local machine to connect to that server, to run commands against that server and so on. And will not really use a big graphical user interface for working with our database. Instead, NoSQL databases in general are not really about configuring the database or any tables in there, because as you learned, there is no fixed predefined structure you have to set up. Instead, you really dive right into the commands that you want to execute for inserting data or fetching data. So therefore, we should make sure that's installed. And with that, we can click Next here. Now here's an important screen. Here, by default, this checkbox is checked that you want to install MongoDB as a service. MongoDB is a process that will be installed that you would use for spinning up your database server. And you can do that manually. And if you uncheck this, you have to do it manually. But with Windows, the convenient thing is that we can indeed keep this checked. And then the MongoDB database server will be started in the background for us as a so-called service. We can still stop and start that manually then, but we don't have to actively execute some command to bring that up. We don't have to keep it running in the foreground. Instead, it will run in the background. And therefore, I will keep this checked here, and I will keep these default settings. But now here's an important part as well, the data and the log directory. You can keep these default paths, but I want to explain what they do. Like all databases, MongoDB, of course, ultimately stores the data somewhere on your system. It manages the data storage for you, but ultimately data will end up in files on your system. And it will use this path here, the data directory path, for storing the concrete data in files. It will also log some messages and information and will store that in this path. That's why these two paths are needed and what they do. And with that, we can leave all the settings, but I wanted to explain why we have those settings and click Next. And just as a side note, if you watched the macOS setup as well, there we did not set it up as a service. Instead, there we had some executable files which we had to execute manually to start the database server. This also works, but on Windows, this here can be more convenient. So let's click Next here. Now, we then also get a chance of installing MongoDB Compass. On macOS, we didn't get that. We could still install it as an extra tool there. And you can keep this checked here and click Next. Alternatively, you can also always install it standalone by going to the MongoDB website and then to Software, and then going to Compass there. And there, if you click on Try It Now, you can also download Compass there. And that's this graphical user interface, which you can also use for talking to your database. We will have a look at Compass throughout this course, so therefore you can install it already, or you don't install it yet and instead you install it later. Hence, I'll click Next here and then Install. Now, once the installation is done, you can click Finish. And now, as a first step, you can open up your Windows Start menu and search for Services there. And open this Services tool. Here you got all the background services that are running on your system. And if you scroll down to M there, you should find MongoDB Server there as well. And it's running by default. Now, this is this database server which is running in the background as discussed a couple of seconds ago. You can always right-click on it here to stop it. And then this will shut down this service and therefore also the database server. And once it's stopped, you won't be able to interact with it. So you won't be able to send commands to it. Therefore, you want to start it again so that you are able to interact with it again. And that's, of course, then a very convenient way of starting and stopping that service. Alternatively, you can open up your command prompt as administrator. And in there, you can run net stop MongoDB to also stop this service. And once it's stopped, you can run net start MongoDB to start it again. So that's an alternative to using this services tool. It's up to you what you want to use. So now we got that server running. But in order to use that server, we now need to start that client, that shell as it's called, which allows us to send commands to the server, queries for inserting or fetching data. And for this, you should open up your Windows Explorer and then go to the path where MongoDB was installed, by default in C Program Files MongoDB. And here I got my server installed. But if you dive into the bin folder there, you'll also find the Mongo exe file. And that is actually an executable that you can run to start your client, your interactive shell that allows you to talk to that server. So if you double click on that, this shell opens up, and now here you are connected to your server. In here, in this shell, you can now run commands to insert data or fetch data, and of course that's exactly the part we're going to dive in this course. So that's what we're going to explore in the future here. For the moment, you can just run show DBs to basically list your databases on this server. So that's a built-in command that will be understood by the server, and you should see some default databases here. And that's it for now. The moment we're not going to do anything else, you can always close this shell and restart it, and you can always stop and restart the server, but as long as you want to work with it, it should of course be up and running. And with that, let's now continue and dive deeper into MongoDB and in how we can work with it. Now, before we now get started with diving into the MongoDB syntax and how we can write queries and run queries against our MongoDB database, there's one additional tool you might want to install, and that's the MongoDB shell. Now, actually, we already did install a shell together with the MongoDB server in the last lecture, and we already did start the shell there. That was that thing, that tool, which we executed in the command line or by double-clicking on it on Windows to then connect to our running MongoDB server. So that tool which we'll use for inputting commands, for sending commands to the server. But depending on the point of time you're watching this course, that shell might be the old shell, which is perfectly fine to use. There's nothing wrong with it, but there is a newer shell available, and you either already have that or you need to install it separately. And you can tell whether you already have it by the look of it and whether installing it separately changes anything for you. Now, I did record this course with the old shell, but you can follow along just fine with the new one because the commands I teach are exactly the same. The shell just looks differently, and the new shell simply has some extra convenience features. It has nicer formatting and so on to present the output in a nicer, more pleasant and easier to understand way. But the commands I execute are the same, so nothing changes about that. You learn all the things you need to learn about MongoDB in the correct and up-to-date way with that course, even though I'm using the older shell. Now, to get that newer shell, you can search for MongoDB shell, and you might find this link to the legacy Mongo shell, which is the older one, which you already might have installed automatically together with the MongoDB server. And you should also find this MongoDB shell download link. Alternatively, you can get there on mongodb.com by clicking on Software, Developer Tools, and then there choosing the MongoDB shell. And then here you can click on Download Now to be taken to that same page. Now here again, you can choose your operating system. There are different versions available for all the operating systems, and you can then simply download that shell. On Windows instead, you would have this installer, which you download. And once downloaded, we simply execute it and then walk through that installer. We can keep that default path which it chooses here and then choose Next and start this installation. So it's really straightforward here. And then we're done on Windows. Now back on macOS, here we have to extract that zip file and we'll get a new folder which contains such a bin folder. And in there, you have two different files, and for us, the Mongo shell file is the most important one. But you can grab, and you should grab both files and copy them, and then move them to the directory where you installed your other MongoDB tools. On macOS, that should be your USR folder, and you need to make sure that you can view hidden folders and files to view that. You can do that by hitting Command Shift and dot. And then in that USR folder, go to local bin, and that's where we copied the other Mongo commands before when we installed MongoDB on macOS. So now move these two new executables into that folder. You might need to enter your password to do that. On Windows, you can now open your Windows menu, the Start menu, and there search for Mongo sh, so Mongosh, and execute this command, this tool, which is the Mongo shell we just installed. And this will open up the Mongo shell and connect to your running MongoDB server. So of course, therefore, you need to have such a running MongoDB server, this running service here in case of Windows, so that this connection succeeds. On macOS, we would typically open our terminal and simply execute mongo as a command there, and then connect to our running MongoDB server. And for this, of course, we need to have our server up and running there as well. That is a must-have. Now you can ignore any warnings or any messages you might see here. We don't need to worry about them right now. Instead, we can now use this shell to interact with the database. And then this shell is connected on both Windows and macOS. And this shell, in the end, supports the same commands you could also use in the old shell. So you could use either of the two shells, but it is more future-proof to follow along with this newer shell. And maybe you already had this shell as a default shell right from the start when you first installed MongoDB in the last lectures anyways. Now, just as before, you can run show DBs in here to see a list of your databases. And there we got some dummy starting databases, but I'm now going to continue with this new shell here. So now that everything is set up and you should have a working MongoDB server and the shell connected to it, let me clear this screen by running CLS, and this only clears the screen, doesn't do anything else. And now let's work with the database. Let's get started working. First of all, you can type show DBs to see existing databases. And you do start off with 3 default databases that store some metadata. We don't need to worry about these. Now, first of all, let's connect to a database with the use command. And you can connect to a brand new database by simply typing its name. Even if this doesn't exist yet, it will be created on the fly once you start inserting data. Now in there, you can create a new collection also on the fly because no collection exists right now. And you do this by typing db. This refers to the database you're currently connected to, so shop in my case. And then the name of the collection where you want to insert data. Let's say products. And this also doesn't need to exist yet. And then you can insert one new product with the insert_one command. And you pass this JSON object to it. So these double curly braces surround the data you now want to insert into this collection. And there you can add your keys, your key value fields, like name, max. Now the good thing is, here this would work, but you can omit the quotation marks around the key name here in the shell. Not around the value, because this should be some text, and text is marked by quotation marks, but around the key name you can omit it. This is simply a little feature. It will be stored with the quotation marks behind the scenes. Now we can add a second value by adding a comma, and then the age, 29. And now we will insert a document with the name and the age. However, for a product this doesn't make too much sense, so let's maybe name it a book, and then give it a price of $12.99. So if you now hit enter, you should get this command, which basically confirms that the data was inserted into the database and that MongoDB automatically generated a unique ID for it, which it returns you here. Now let's have a look at our data then, right? This can be done by simply running db products. So again, the currently connected database, and then the collection we stored the data in, and then by typing find. This gives us, if you add no other arguments, which we'll do in the course, but not right now, if you add no other arguments, this will give you all the data in that collection. Find. So this gives us the one entry we added. And here you see the quotation marks around the key names too. Now, there also is another version of this. You can add .pretty at the end to simply output it in a prettier way. It's still the same data, just easier to read. Now, try it on your own. Pause the video, try it on your own, and add another product on your own. Also, try adding name and price, and also one extra field, like the description with some dummy text. Very successful? Well, you would repeat db products insert_one. And by the way, if you repeat a command which you executed before, you can also just press the up key on your keyboard to cycle through your past commands. This allows you to quickly go back to a past command, simply edit it a bit, and re-execute it. This will not change the past data. It will be treated as a new command, but it's easier for you. You don't have to write everything again. So here we could add a t-shirt with some price. And as I said, now let's also add a new key, description, where I say this is a high quality t-shirt or whatever you want. If you now hit enter, this will be inserted as well. And now let me clear the screen again with the cls command. And let me execute find pretty again. And now we see 2 documents in that collection. And you also already see that schemaless thing. Our documents don't have exactly the same structure. Now let's take it one step further and let's insert another document. By the way, you can press Alt and then left arrow to jump through these words quicker. And let's name this computer. Ramp up the price a little bit. And then simply type a high quality computer because I'm really creative when it comes to text. And there, let's add some details. And this now will be an embedded document with another pair of curly braces inside of that other document. And here we could have something like CPU. And that is, let's say, the Intel i7, this one. No, I'm not getting paid. I don't know if that even exists, but I think it does. And memory, let's say there we have 32 gigabytes, like this. And now if I insert this and I find them again, now we see all 3, and you also see that embedded document. So this is just playing around with the shell here. Of course, we can also delete and update documents, and we can filter when we're retrieving them. We don't have to always retrieve all of them, but that's just our first real quick start. This is how we will work with MongoDB for a big chunk of this course. And now let me show you how this relates to the real world, where you would, of course, write an application with PHP, with Node, with C++, and would interact with the database from there. So how does that shell stuff you're learning in this course relate to that? So for this course, we will primarily work in the shell to see all the commands and the different ways of using these commands. Because the shell is a great neutral ground for working with MongoDB. Because I don't know if you're building a PHP, a Node, a C++, a Python, or whatever application. And I want to teach you something which you can apply to all use cases. And that is the case with the shell. But of course, in the end, you will build an application with a programming language where this app should then issue these commands against the MongoDB server. And for that, you can click on Docs on the official page. And then on the doc page, click on MongoDB drivers, because these drivers are packages you install for the different programming languages your app might be written in. As you see, you got drivers for all kinds of languages. And these drivers are then your bridges between your programming language and the MongoDB server. And as it turns out, in these drivers, you use the same commands as I use in the shell, just adjusted to the syntax of the language you're working with, of course. So for example, if we have a look at the Node.js driver and the Python driver, let's see how we would work with those. On the Node.js driver documentation, if we click on latest documentation, we can quickly have a look at the quick start guide to see how our code would look like. If we use that, you see how to start your MongoDB database and so on. And what you will see there is that here, you also in the end just reach out to a database. Then instead of typing the collection name, you have a collection method to get access. But you would look into the official docs, of course, when using the driver. So these are tiny differences which you quickly find out there. But then on the collection, you again run insertMany. We haven't seen that yet. We'll see it in the course. This exists in the shell in exactly the same way. And you insert data in exactly the same way. So the core features are exactly equal. Let's also have a look at Python to prove that. Here I'm on the Python driver page. Now let me quickly dive into the tutorial so that we see some code for that. So here you see for Python, you would install a package called pymongo, which is the official driver for Python. You then connect and so on. And again, you in the end just get access to a database, then to a collection, here again by just using that collection name, and then you simply insert one, now using Python syntax, where you happen to write methods like this with an underscore and this snake case. But then you insert one post, which is just such an object, a Python map in the end. So you see, the syntax of the languages obviously differs because, well, they're different languages, but the general way of working with your data does not change at all. You work in exactly the same way as in the shell. And actually, this is something we'll build later in the course. This is a complete node application using MongoDB, and here you also see some code in action where I insert a new product, and this is something we'll build in the course so that I can teach you how to move from the shell to the drivers. But I hope this makes clear why we work with the shell. It's the neutral ground on which we all can agree so that you can take that knowledge on how to insert, how to configure your inserts, how to query data, how to filter data, how to sort data, so that you can use that knowledge with any driver you want and you are really flexible regarding what you build. So we're almost done, no worries. It's soon time to get our hands dirty. Now let me quickly give you an overview over how exactly you will work with MongoDB and what MongoDB exactly does behind the scenes. So we can generally differentiate between the application, so let's say your node application you're creating, and the data layer. Now in your application, you will have some front end that can be a single page application, that can be a mobile app, that can be the views your Laravel or your node app renders. You'll then have a backend, your server, where you have your server-side logic, and then you have your data layer. So you have the database, the data storage, the files on a file system which hold your data in the end. You have the MongoDB server, and you have on the backend server, where you will write your code, you have these drivers for the different languages. Now the drivers will interact with the MongoDB server. The MongoDB server is what we start with the MongoD command, by the way. Now the MongoDB server will actually not directly write the data into files, but talk to a so-called storage engine, which you could replace with your favorite storage engine, but the default one, called writeTiger, is actually an awesome storage engine which allows you to efficiently work with your data, store it efficiently, and so on. So the MongoDB server basically gets the query from your driver or from your shell, and then just knows I want to insert something and basically forwards that information, after doing some other things, to the storage engine. And the storage engine then stores it in files in the end. And instead of the drivers, you can of course also use the Mongo shell. There you can also write all the queries, and as you will also see in this course, you would also use the Mongo shell as a general playground and also for administrating your server, because that is not something your app will do. If you have to configure something, you would do this as an administrator from your company network through that shell, which is your direct access to the MongoDB server. Now, if we have a closer look at the data layer with the server, the storage engine, and the file system, then we actually have to differentiate between writing and reading from files, which is a bit slower, and writing and reading from memory, which is faster. The storage engine actually does both. It loads a chunk of data into memory and manages that such that the data you often use is in memory if possible. It also writes data in memory at first, so that this is really fast, but then of course it also goes ahead and stores data in the database files. And I will dive a little deeper into that later in the course, but in general you need to be aware that you always talk to the MongoDB server, and behind that server, the server talks to the storage engine, which manages your data and stores it in files in the end, but also in memory in between, so that you can work with the data in a very fast way. So this is how the MongoDB server works behind the scenes, you could say. So with all that talking and theory, we all want to get started. So what's in this course? In this course, we're almost done with the introduction, and we'll then move on to the basics of MongoDB, basic operations, and most importantly, the basic CRUD operations. CRUD stands for create, read, update, and delete, which are the core operations basically any application will have to do. If you're a newcomer to MongoDB, you should absolutely start there. Well, you start here, but then this is the first real content module with which you should start. After that, we'll have a look at data schemas and relations. How do you model your data? How do you find the right balance between having that flexible document schema and still using a schema in your app? How do you relate different documents? We'll have a look at that in this module. Thereafter, I'll dive a bit deeper into working with the shell, some different things you can configure there, and how you can, for example, run that MongoD server as a service on Mac and Linux. And we'll then have a look at the graphical user interface, Compass. We'll not really work with that throughout the course, but I still want you to know it and to understand that you can use that to look into your data. Now, after that, we're back to the shell, and we'll dive deeper into create operations. That is where you can start if you have some basic understanding. So if you're not a total newcomer, but you know basically what MongoDB does, you could skip the other modules if you want and dive into that. And we'll not just have a deep dive on the C of the CRUD, we'll also have a deep dive at reading, so filtering and querying data, at updating, and at deleting data. So a lot of deep dives there to show you all configuration options, all filters, and all the different ways of getting that data you need. Now thereafter, we'll have a look at indexes, a feature that allows you to speed up your queries. I'll talk about the advantages and disadvantages and how to use them. If you're an advanced user and you know all that CRUD stuff already, this might be the entry point you want to use, so you could skip forward to that if you're pretty confident that the rest will be boring to you. Now, after indexes, we'll work with geospatial data, because MongoDB is actually really great at storing locations and at querying that, so that you can do things like, I am here, which is the closest restaurant. That is really easy to do with MongoDB, as you will learn in this module. Now thereafter, we'll have a look at the aggregation framework, which is a more powerful way of retrieving data from your database, and you will learn how you can use that and how you can build complex aggregation pipelines with the help of MongoDB. It's then time to work into a special kind of data, into numeric data. I will teach you how to work with different kinds of numbers and what's special about that in MongoDB. Well, and with that out of the way and with these core features covered, I'll dive into a crucial feature, security and authentication. How do you secure your Mongo database? What's to that? And how can users authenticate against it? And with users, I mean database users. So for example, your application or you as a real person using the shell. Thereafter, we'll have a look at performance, fault tolerance, and deployments. So how can you improve the performance? What are important factors? And how do you, in the end, get your local MongoDB environment into the web, into the cloud, so that you can really use it from anywhere and not just from your local machine, which is great for practicing and for working or for developing, but not really for running this in production, obviously. Thereafter, we'll have a look at a cool feature called transactions, which was added with MongoDB 4.0. And we will learn how to move from the shell, so from the knowledge you gained with all these shell operations, to the drivers. And we will build an entire application there, a Node React application. And you don't need to know either to get a lot out of that module, to learn how you can use the driver, the Node driver in this case, and use the knowledge you gained in the course to quickly create an amazing application. Thereafter, I will conclude this course by diving into MongoDB Stitch, which is this other offering MongoDB has with the serverless functions, the triggers, and so on. You will learn how you can use that to build, together with the MongoDB database, a complete application where you focus entirely on your business logic and data, and you don't have to worry about creating REST APIs, configuring servers, or anything like that. So this is what's inside the course. I hope you'll like it, and I'm super excited to dive into it with you. So now we're ready to dive in, and now I just want you to get the most out of this course. To get the most out of the course, watch the videos. This is obvious, but watch the videos and watch them at your speed. You can slow the videos down in the Udemy video player, or you can speed me up and really adjust this to your requirements. If I'm talking too fast, slow me down. Am I going too slow? Speed me up. Maybe skip lectures if you already know what I'm teaching in there. It's an on-demand course, so take advantage of that. Additionally, pause and code along, or type the commands along with me. Play around with MongoDB. Since it's running locally, you can't mess it up. You can always delete that database folder you created and start from scratch. But play around with MongoDB and follow along, because being active always gives you more than just passively watching the videos. In addition, make sure you do the assignments. There are a couple of assignments in this course which are there for you to practice. In the assignments, I always show my solution for you to compare, and being forced to solve a problem on your own first, of course, gives you an opportunity to really see if you really understood a certain concept. Now, additionally, I will point at the official docs very often, because the docs are very good and detailed, and if you need some niche case, or you just want to read something, or you just want to look something up which I explained somewhere in the course, but you don't know where that was, dive into the official docs and also use Google. That's a great additional resource to this course, because with that you'll learn to solve your problems on your own, which is always the best way of learning. You have to learn how to solve problems on your own. Take the course, get the basic knowledge, get the advanced knowledge too, but then also dive into problems you're facing on your own and solve them. Now, if something is unclear at any point, or there is a problem you can't solve, also use the Q&A section of this course. I'll do my best to reply there quickly, but also please help other students there. Don't just ask, also answer. Because by answering, you'll become a real pro, because answering is so much harder than asking. And if you answer something which is not entirely correct, that's no problem. You'll be corrected and you'll learn again. So really use this as an opportunity to also challenge yourself and grow. And with that, we got everything we need. We got the basic theory. We got everything installed. Let's dive into MongoDB and learn how to use it to its fullest potential. So let's dive into the core basics you need to know when working with MongoDB, with the data or the documents you store in there. And let's also dive, and that's really important, into all the CRUD basics. CRUD stands for create, read, update, and delete. And these are the typical operations you do with your documents. You create documents, you want to, well, find, retrieve, or read them. You want to be able to update and change your documents. And obviously, in a lot of cases, you also want to delete some data. So we'll dive into all these core basics in this module. To be precise, we'll have a look about the core basics or the core concepts about collections and documents and how to work with these. We'll have a look at the basic data types you work with in MongoDB and how to, well, store different data in your database. And we'll have a look at these CRUD operations I was referring to. I will show you which kind of queries you can run to insert data, to find data, to update or to delete data. And therefore, by the end of this module, you'll have a very solid understanding of the core concepts behind MongoDB and the core concepts you need to work with data in MongoDB. So let's get started. Even though I already showed it in the first course module, it's really important that you understand how databases, collections, and documents are related. In a MongoDB world, you have one or more databases on your database server. And each database can hold one or more collections. A collection would be a table in a SQL database. Now, in that collection, you have these documents, multiple documents per collection. And the documents are really the data pieces you're storing in your database. Now, important, when working with MongoDB, you will see in this module already that the databases, the collections, and the documents are all automatically created for you. They are created implicitly when you start working with them, when you start storing data. That is really convenient. Later in the course, we'll also learn a way of explicitly creating new collections, which allows you to configure them a bit further. But this is a cool feature which makes getting started super simple. Now, this is the core concept you always should keep in mind, and the relation between databases, collections, and documents you always should keep in mind. And now with that out of the way, let's actually bring up that Mongo server again, connect to it through our shell, and again see how we can store data in there and which kind of data that is. I'm back in the terminal, and I now again want to start my MongoDB server. Here on Mac, I'll do this with sudo mongod. And make sure you watch the installation videos in the first course module to get this up and running on Windows or macOS or Linux. So with that command, I'm prompted to enter my password. And with this entered, it will start up my MongoDB server using the Wired Tiger storage engine. Now, this is the server up and running, and you need to keep this process running. So don't close this window, don't quit this process yet. As you can see, it's now waiting for new connections on port 27017. By the way, if you wanted to use a different port or you're facing issues with this one, you can use a different port. And now I did quit the server by hitting Ctrl and C. You can use a different port by specifying -- port when starting up the server, and then you can, for example, choose 27018 as a port. And now you see it would be listening on that. So that's just a tiny piece of information which can be useful in case you're using that default port for something else. So with that up and running, let's keep that up and running and open a new additional window in the terminal. And in there, you can now run Mongo without a D at the end to use the Mongo shell and automatically connect to the up and running server. Now here, however, I get a connect failed. And that happened because by default, it tries to reach the server on port 27017, which is obviously not the port I'm running on. So I can connect by using mongo -- port and then using that port where my server is running. And now you see this did connect successfully. With that, we did connect again. Now you can run CLS in here and hit enter to clear the window. I'm still in the shell here, and if I scroll up, I see all the old output. CLS just clears the window. And now we can start running commands again and work with our database. Now, before we actually run any commands, you might be wondering why I'm using the shell. Because when you're building a real application where you use MongoDB, you will of course not use the shell for that. You will use one of the MongoDB drivers depending on the programming language you're using. And on the official docs, a link to this page can be found in the last lecture of this module, by the way, you find an extensive list of all the drivers MongoDB offers. And as you can see, there are drivers for C++, C#, Java, Node.js, PHP, Python. So all the important server-side or desktop-side programming languages. Now, depending on what you're building for, you would of course choose your driver here, follow the installation docs, and then embed it into your application code. But in this course, as mentioned in the first module already, we of course want to show you an approach that works for every language. And therefore, we'll use the shell here. The shell allows us to write queries which are very similar to the queries in the different drivers. The shell is actually based on JavaScript, so it's extremely similar to Node.js. But if you check out the docs for the other drivers, or even better, in the official docs here, if you go to Getting Started, and you find a link to this in the last lecture too, you can also see that there you find a document about the CRUD operations. And you don't need to worry too much about that right now. We'll learn all about these operations in this module. But if you check out any article there, you can actually switch between the different languages. And the interesting thing is, the default always is the shell. These are the commands we'll write. But if you then switch to Python, for example, you see this is pretty similar. We had insert1 in the shell, written like this. Now in Python, it follows the Python naming standards, but it's still insert1, and it's configured and used in the same way. And this is true for all the programming languages. It of course uses the syntax of that language and the best practices you should use for writing code in that language, but the way you use it, the way you pass data in and you can configure it, always is the same. And this is why we use the shell here. Now, with that out of the way, let's start using that shell, which is connected to our local Mongo server. And let's finally add some data and learn more about the data types we can use and how we can interact with data in general. In the shell, you can run show DBs to see which databases you have on this MongoDB server. And as you can see, as I'm just starting out, I got no databases in there. You might even just see admin and config here if this is brand new, but that will be fine too. You don't need to create any of these default databases. The default databases here simply exist to store configuration for this database server, or for example, the admin database will allow you to create users and roles and how people can use and interact with the database. All topics we'll cover later in the course. So we got no database in here. We can switch to a database with the use command though. And you can even switch to databases which don't exist yet. So for example here, I want to start with some flight data. So I'll name it flights. And you can choose any name you want. If you hit enter, you see that we switch to the DB flights. But if I type show DBs, we still don't see that, even though I did switch to it. The reason for this is that this database does not get created before we start entering data in there. But if we do start entering data, it will be created automatically and implicitly, so we don't have to create the database in advance. Now, as you learned on that slide, we store data in collections. So we don't just need access to the database, but also to a collection. Now, we got our flights database, and in there, let's say we want to store some flight data. You can reference the database you're currently in, so in our case, the flights database here, with db. And then you chain commands by typing a dot and then the command. And one command, in quotation marks, is that we type the name of a collection we want to interact with. Let's say we have a flight data collection named like this, and this name is also up to you. Now, this is a collection which also doesn't exist yet, but just like a database, it will be created on demand once we start inserting data. Now, to insert data, we type another dot, and now we can type some query commands. Commands that allow us to get data out of the collection. Would be hard right now because there is no data in it, or commands that allow us to add data. And there we got the insert_one command, for example. As the name suggests, this inserts one document into this collection. Now, important, make sure you got the casing and the name in general correct. You don't have a typo in there. It's one word with a capital O. And now between these parentheses at the end here, we pass the data we want to store. Now, a document is always defined with curly braces. If you're coming from a JavaScript world, you will know this syntax. There you also create objects with curly braces. To be very precise, we're not creating a JavaScript object here, but a JSON document. And JSON documents are also delimited or surrounded by curly braces. Now, in that document, we now have key value pairs. Now, let's inspect how that looks like and how that works before we finally add our data. So here is some data I prepared. Now, you find that data attached to this video, by the way. It is a JSON file, and this JSON file actually holds an array, hence the squared brackets here, of 2 JSON documents. So this is one single JSON document, and this is another JSON document. And we enter one such document with insert_one. We don't insert both. We insert one such document with insert_one, and this would be one piece of information about a flight. Now here I got these key value pairs, and that is how a JSON document is basically made up of. You have names, which you enclose between double quotation marks, and these double quotation marks are important and have to be used. And then you got the values for these names or keys. And here the values can be different kinds of data. Here we got a string, so some text basically, which is surrounded by quotation marks. Here we got a number though, and there we don't have quotation marks. So the values don't have to use quotation marks, only the names here. The values can be strings and then they have quotation marks, but they can also be numbers or like this, a so-called Boolean, so true or false. This also has no quotation marks. There also are some other types of data which we'll see throughout the course. These are 3 very important types of data which you'll use a lot though. So this is one JSON document we could enter. So let's grab this document. Again, you find this file attached, and just that one document, including the curly braces, but not the entire array. Grab that document, and then back in your terminal here, you can copy that document between those braces. Important, before you copy it in, delete the closing parentheses, then add it, and then close it. Now if you hit enter, you should see this message here, which basically tells you that this was accepted and was inserted successfully, and that it also assigned an automatically created ID. Now, that's a feature provided by MongoDB. Every document you enter gets a unique ID. And actually, you need to have a unique ID on every element, but as you saw here, you don't need to specify it on your own. MongoDB gives you one. It's of type object ID, so this is another type supported by MongoDB, which we can use. And we can see it if we now simply have a look at our flight data. Let me clear the console. And again, if I now access flight data, so this collection, now instead of inserting, we can use find like this. And if we use it like this, it will simply return all the documents in this collection. You can also add another dot and then pretty as a function, and this will just make sure that the output we get back is formatted in a pretty way. That's the only thing it does. Find without pretty will also work. It'll look like this, but, and you can press arrow up to repeat your last command, if you add pretty, it looks like this, which is easier to read. And there we see all the data we entered plus this extra underscore ID, which was added automatically by MongoDB. And this object ID object is simply a special type of data provided by MongoDB, which is a unique ID that also allows you to sort your documents, because it will also have some timestamp data in there, you could say. So this ID also can be used for sorting, because it's guaranteed that if you would add another document right now, this would be treated as a more recent document than this document we see here due to that ID. But that's some behind the scenes stuff. The important part is we got our data in there. You still see we have the same data types we added, like the number still is a number. There are no quotation marks around it. And this is now valid JSON data inserted into our database, or into our collection in that database, to be precise. Now that we added some data into our database in the last lecture, let's come back to that JSON thing. Because actually, MongoDB does not use JSON but BSON, which stands for binary JSON, for storing data in your database. Now, you don't really need to care too much about that, because all you will write and see will be JSON code, like we did it. So this is JSON code, this is what we used in the last lecture, this is also what we see when we retrieve data from MongoDB, but behind the scenes, MongoDB actually uses BSON data. This conversion is done by the drivers. So this basically takes your JSON code and stores it in binary data. And this is simply done because, for one, it is more efficient to store than JSON data. So it's faster and more efficient from a space, from a size perspective. And additionally, it supports additional types. Because, for example, that object ID thing we saw in the last lecture is not valid normal JSON. If I were to go into my editor, which is Visual Studio Code, which you don't need, but this is simply an editor you can use for coding, and I would manually add an ID field here and set this equal to type object ID with some text in there, you see that my editor doesn't like this because it's not valid JSON. Now, it is not valid JSON, but MongoDB can actually understand and take this and store it in its binary data. And there are some other types too, like for example, you got different types of numbers with decimals and very big numbers, and these are stored in different ways behind the scenes. You don't need to care too much about that, but this is something MongoDB offers you. This special data type, other special data types, and very efficient storage in general. We will always work with our data like this though, so in JSON format. And there's one other important thing you need to understand about this data. If I add another piece of information into flight data with insert1, so if I add another document, and this time I'll type it manually, when adding data like this, you can actually omit the quotation marks here as long as there is no white space in the name. So we could also have departure airport like this, and this would still be accepted. So I don't need to wrap the name into quotation marks here. You can still do it to be very clear that this is JSON, but well, we know it's JSON and you can use it like this as a shortcut. The value, if it's a string, still needs to be enclosed in double quotation marks though. So if we had Berlin Tegel as an airport here, and then let's say we have the arrival airport, which is Heathrow, then we could write it like this. We can now also theoretically save it like this, even though the aircraft distance and the information whether this is an intercontinental flight is missing, because you can have mixed documents in the same collection. If you add the data like this, you still see this is accepted. And if I now access all my flight data and find it and pretty print it, you see both documents exist in there, even though they have different schemas. Now we'll dive a bit deeper into schema design and how we should structure our data in a separate module, but I also want you to take away and keep in mind that in MongoDB, two documents in the same collection don't have to have the same schema. Often you will have at least some intersections or completely equal schemas, but it's not a must. One other thing you have to know is that this ID, which is auto-generated, you don't have to use the auto-generated ID, you just have to ensure that you have a unique ID. But if you can ensure this, you can also assign IDs on your own. So if I add the same entry again with departure airport and arrival airport, I can add _ID in there as an extra field, and it has to be _ID, so not just ID, also not ID with a capital character, _ID like this, and then you can use any ID you want, a number or another string, like Tixel LHR1. This can be done, and you see this was also accepted and inserted with this ID. So if I again print all the results here, you see we got our two old results and this new one does now not have an object ID, which was generated for us by MongoDB, but our own ID. If I try to enter the same entry again with the same ID though, and that's the only thing which is the problem here, not the other data may be equal, as you can see here, but if I use the same ID again, we get an error. And in the end, this error is simply telling us that we get a duplicate key error in this collection and that the duplicate key is the ID, which is not allowed. So this is the error we're seeing here, and this is something you should also pay close attention to. With those basics about the data, the documents, and how we work with data out of the way, let's shift our focus towards the CRUD operations and how we work with the different CRUD operations we may use in MongoDB. Now, first of all, what is CRUD all about? Why does this matter? You can use MongoDB for a broad variety of things. You might be building an application, or you have some data which is shipped to you as one file and you just want to run some analytics on it, or you're an administrator of a database, of a Mongo database. In all these cases, you will have to interact with the database. Now, in the application case, you might have an app, a mobile app or a website, where a user interacts with your code in the end, and that code can be written in Node.js, PHP, can be a desktop app written in C++, really no limits there, and you will have your MongoDB driver included in your application then. In the other cases, like for analytics, you might be using the business intelligence connector MongoDB offers, or you directly use the shell or some other import mechanism provided by your favorite BI tool. Or as an administrator, you'll work with the shell, like we're doing it right now. In all these cases, you want to interact with your MongoDB server. And for an application like a website, you typically want to be able to create elements. You want to be able to read, update, and delete them. Let's say you're building a blog. You want to be able to create new posts, to deliver those posts to your users. You want to be able to update these posts, so to change them, or maybe even delete them. With analytics, you also at least want to be able to read the data. You might never change it, but you want to read it. And as an admin, you might want to do all these things, to fix some data or to play around with it as we are doing it. So these are these core CRUD operations. And in the end, these operations are the only thing you do with your data. This is what you have your data for, to create it, manage it, read it, all these things. And you do these things with the MongoDB server, and they're, of course, in the end, on a collection and the documents in that collection. Now, for these CRUD operations, we have a couple of important queries you should keep in mind, and you'll also find in the official docs, of course, in case you want to check out all the details or dive a bit deeper. There's insert1, which we already saw. Insert1 allows us to insert some data into a collection, and all these methods I'm showing you are directly executed on a collection, as we did it in the last lectures. And we can also pass some options along with insert1. We'll not worry about that right now. We'll dive into that later, though. Besides inserting one document, we can also insert many documents, by the way. So if you have a use case where you need to insert more than one document at a time, you can do that too. This is important for creating data. Now, for reading data, we got find, and find also allows us to pass in some arguments, Right now we're calling it without anything, just find empty parentheses. Now you can pass in a filter, and filters are very powerful. They allow you to narrow down the data you're retrieving, something you of course often want to do in a database. And you can also pass some options to find. And again, we'll take a close look at all these options and filters throughout the course too. You also got findOne. The difference here is that find finds all matching documents. findOne simply gives you the first matching document it finds. updateOne is then useful for changing one piece of data. And just as we can also insert many documents at once, we also have updateMany. Now, the update functions take 3 arguments because we can pass a filter to narrow down which document or documents to change, then the data describing the change, so what should be changed, and again, some options we can use to configure that process. We also got replaceOne in case we just want to replace a document entirely with a new one. There also is delete. We can delete one or delete many documents in a collection, and there we also pass in a filter to find out which document or documents to delete. Now, let's see all these things at an example. Again, having a look at our flight data here, which could look like this, basically the data we already worked with. And there, let's say this is the data we're using on our application. Our application might be a website where people working at an airport or at an airline can schedule a new flight. Therefore, they would create a new entry in our flight data collection. They can change information about this flight, so they can update information. For example, if the aircraft changed. They can cancel the flight, let's say, so they can delete it. And they can also display flight information on their own website in the mobile apps for their passengers. And therefore, they need to be able, or you need to be able, to read the data from that collection. This is our little example here, using the data we already set up. So let's get started and play around with these CRUD operations and our data. Back in the shell, and still connected to that same MongoDB instance we used earlier, let's again check out our flight data collection with find. And as you saw, use find pretty to get a pretty output. You see we got 3 documents in there. We got the document with our own custom ID. We got the other document with incomplete information but the automatically generated ID, and our original document. We already saw insertOne. Now, let me actually start with clearing this database now, before we then insert data again, but this time with insertMany. Now, to clear the database, we have to use a delete command. And we can simply use our flight data collection because all these commands are always executed on a collection where you want to add or delete documents. And there we got delete one or delete many. Now here I want to clear all the data, and for this actually the easiest way would be to simply get rid of the entire collection. But since that would be boring, let's go with delete one to simply see how that works. Delete one takes a filter to find out which document to delete. And now you could filter for all kinds of things. A filter is defined as a document, so with curly braces, and then in its simplest form, you now simply define which key and which value you want to delete, or the document with that key and value you want to delete. So for example, here we could say departure airport, if that is equal to TXL, so to Berlin Tegel, then I want to delete that document. And what this would do is it would go ahead, find the first document in our database where the departure airport is TXL and delete it. So if I hit enter here, you see this was accepted, it was successful, and we see it deleted one document. So if we now again use our flight data and find all documents and pretty print them, we only see 2 documents now, the one with our custom ID and the first document we ever entered. This means that this middle document was now deleted, because it was the first document with a departure airport of TXL which it found. Obviously, we don't have to use the departure airport. We could have looked for an ID too. So I could also use db flight data delete 1. And I could have also looked for underscore ID and then maybe my custom ID, this one here, TXL LHR 1. If I do this, it would delete this document. But let me also show you how to delete many documents. Now, the thing is, we got nothing in common. If I just execute delete many like this, it fails though, so I need to pass in a criteria. Now, we got nothing in common for our elements here. So let's first of all update them real quick to add a new field to both documents so that they have something in common, so that we can delete them in bulk, so that I can also show you this. So for this, let's go back to the collection and now use update1. Update1 updates, as the name suggests, one element. And for update1, we first of all define a filter where we say which document should be updated. And now let's say we want to start with this first element here. So I want to update the document where, in my case here, maybe distance is 12,000. This should select this first document. The second argument then is how I want to change it. And now the question is, what do you pass there? Now let's say we want to add a new field, and therefore we pass in document here, marker, which holds some text, delete. By the way, as you see here, you can use single quotation marks for the value too, but you can also use double quotation marks. Now, this might add a new field, marker, with the value delete to that first element. But if I hit enter, I actually get an error. And the error is that the update operation document must contain an atomic operator or atomic operators. Now, this is a very weird error, and there's not really much you can do with it if you're just starting with MongoDB. The thing is, it simply is an incorrect type of data for updating. You don't pass in a document describing your change like this, because MongoDB doesn't know how to interpret this. Instead, what you do pass here is a document with curly braces with a special keyword, $set. And this is something you can remember. Whenever you see something with $, in MongoDB, it's a reserved operator or word. $set is simply identified by MongoDB when used in an update1 operation to describe the changes you want to make. The value of $set then is a document with curly braces, and we need to close another pair of curly braces for our surrounding curly braces, now marked in purple. And now what this does is it tells MongoDB, hey, for this document you're finding, please set this value. And if this value did exist, it would change it to delete. And if it does not exist, as in our case, it will add it. So if I now hit enter, this succeeded. You see it found one document that matched our filter, and it modified one document then. And now if I again access my flight data, find it, and pretty print it like this, we see we now added the marker here. Now let's say I want to add that marker to all my documents. Now what you can do then is you can use updateMany. So on flight data, you can use updateMany. And now you need to pass something as a filter, but you can simply pass empty curly braces. And we could have done that on deleteMany too, by the way. This will select all documents. And now here, I again use set and then describe what to change. And now let's say I'll set the marker to delete here. So not delete, but to delete. If you hit enter, you see it matched two documents and it modified two documents. And now, if you again access your flight data, you find it and you pretty print it, you see that both now have the marker to delete. Please also note that for the first document, this was delete before and it was changed to delete. And now with that, we can use that marker to delete all. Now, as I mentioned, what we could do here is we could also use deleteMany and pass an empty pair of curly braces too. This should delete all elements. But of course, I also wanted to show you how to use update. So here, I will now use my new condition and check for all elements where the marker is to delete. And if we now hit enter, you see this was accepted and two elements were deleted. And now if I access flight data and I use find and pretty print this, well, we get back nothing because there's nothing in there anymore. So this is how we can insert elements, how we can delete and update them, and how we find them. But it's not all I wanted to show you. Let's continue in the next lecture. We saw how we can insert, update, and delete things in the last lecture. And therefore, our flight data now is empty, as we can confirm if we run find. Nothing is returned. Now, time to add something again. And there was this file you found attached earlier. You can find it attached again to this lecture. It holds an array of JSON documents. And now I want to use the entire array. So make sure to copy the entire file content. And then back in the shell, let's again access our flight data and use insertMany now. InsertMany now allows you, well, as the name suggests, to insert many elements. And this is actually not done by adding many elements separated by commas, but instead by passing an array. So exactly the kind of data we got. Let's delete the closing parentheses and paste that in, and then add the closing parentheses after the closing square brackets. And with that, if you now hit enter, you see this was accepted and it inserted 2 IDs. And there you also see this order it automatically keeps, which I mentioned. It's almost the same ID, but the second ID has a C at the end, and therefore it will be ordered after the first element, which makes sense because it was the second element inserted, so MongoDB keeps the order here. And now if we again access our flight data and find it all and pretty print it, here is our flight data with the automatically added IDs. So this is now insertMany, and now you saw both insert1 and insertMany. You also saw update1 and updateMany, and delete1 and deleteMany. There is another thing I want to show you though, and that is related to finding data. We got our flights in the database again, and now let me dive a bit deeper into how we can find data. Thus far, we always used this way of finding data. Find with no arguments. Now, just as you can filter for specific records or documents when deleting or updating, you can also do so when finding. So I can access my flight data here. Let me quickly clear this to make it a bit easier to read. And instead of passing nothing, you can pass a document to it, which will be interpreted as a filter for your collection. And you can filter for anything that makes sense. You could filter for a name equal to max. But of course, this returns nothing because in our collection, we got these 2 flights and there is no name field in there. But what we can do, of course, is we can use flight data and find all flights that are, let's say, intercontinental. So we use that key here. We do so by adding a document, then the name, and this can be wrapped by quotation marks, but it doesn't have to. And then let's say I want to find all flights where this is true. This would be a valid filter. If I now pretty print this, which always is optional, just to make it easier to read, if I hit enter, now I get 1 flight, and this is this 1 flight, which is an intercontinental flight. Of course, this is a very useful feature because in pretty much every application you're creating, you are not always interested in all your data, but in a subset of the data, which you need for that specific web page you're showing to the user or that specific part of your mobile app. You're also not limited to simple queries like this. We could also find all flights with a distance greater than 10,000 kilometers. And for this, we just need to modify the syntax a bit more. It's easy to look for equal values. Distance 12,000 like this, that would be simple, and it gives us back this 1 flight, here just not pretty printed. But if we want to have a greater than check, we can do that too. And there we just need to pass another document or object. I'll use these words interchangeably. We need to pass another object as a value for distance. And here we again use one of these special operators provided by MongoDB, $GT, which stands for greater than. And no worries, you don't need to learn them by heart right now. GT does exist, $GT, and that means greater than. And then you enter the value which you want to have as a greater than value. So here we could enter 10,000. And let's also pretty print this to make it a bit easier to read. And we get this 1 flight which has a distance greater than 10,000. The other flight had a distance of 950. And therefore, if I modify this to look for all flights with a distance greater than 900, we actually get back both flights. So this is, of course, another very useful feature. Now let me close this lecture or end this lecture by showing you findOne with this example. So I'm looking for flights with a distance greater than 900 kilometers. If I switch it from find to findOne, and I remove pretty here, because pretty is not supported on findOne, I get back only one flight, the first flight that matched my criteria. And that makes sense because findOne only gives me back one element. So if I want to find all, I should use find. If I'm only interested in the first matching element, findOne is the solution. The important is, it will still respect that filter, but then not look for all matching elements, but only the first matching element. Now with the basic CRUD operations covered, let's dive a bit deeper. And let's dive a bit deeper into update. First of all, let's have a quick look at all our data in the collection again. We got these two flights. And now let's say I want to change the first flight. I want to change it by adding an extra field, which simply holds the information whether the flight is delayed or not. Now we can do that by accessing flight data here, and then using updateOne. And I can filter by ID. We can copy that object ID, and it's important that you copy the whole object. We could filter for underscore ID with this object ID. Now this will select this first flight, and now you learned we can pass a document with $set where we can tell what to change. For example, can set delayed to true. If I now hit enter, this was accepted. And if I output all the flights again, we see delayed was added. So this is something we can do and something we already saw. Now there also is another command we could use. And that is not updateOne, but just update. So let me quickly remove the one here, and now just use update. If I do that, you see it generally worked, but nothing was modified. And the reason for that simply is that we already had a value of true here. So if I change delay to false, you see it did modify one element. And if I now output all the data, we see delayed is false. Now update works a bit like updateMany. updateMany was used to update all matching elements, and update would also update all matching elements. So what's the difference between update and updateMany then? The difference can be seen if I actually remove $set here. So if my second argument is now just delayed false in a document. Remember, with updateOne, this gave us an error. And the same, by the way, is true if you would use updateMany here. You also get an error here. Now with update, so just update without many or one, this actually works. You see it was accepted and one document is changed. Now how would you imagine that our flight looks like right now? Well, let's access the flight data and find it all and output it. And what we see is we got two documents, but the first one is very small because it now only has delayed false and the ID. The ID still is the old ID, by the way. This was not changed. It still is the ID. It did not change that, but it overrode all the other key value pairs. And that is the thing about update. Update does accept this syntax with just an object, and it will then take this object and basically replace the existing object with this new object, with this new document. It will only keep the ID. It will only patch the existing object instead of replace it, like updateOne and many do it, if you use the $set way. If you use it like this, you overwrite it. Maybe this is what you want, but it is something to be aware of. And in general, I recommend using updateOne and many to avoid this issue. If you want to replace something, you should use a different method. On flight data, you should then use replaceOne. And there you again place your filter. So looking for ID equal to our object ID. And then you add the element you want to replace it with as a second value. So here I'll take my flight data from the attached JSON document, which was attached to earlier lectures, copy that, delete the closing parentheses, add my document and now close it. And if I now hit enter, you see one element was modified. And if we now output all the elements again, you see the ID still is the same as before. It's the ID we looked for in the filter, but the rest was replaced. And this is simply a more explicit and therefore safer way of replacing the data if you really want to replace it. Otherwise, if you just want to change it, partially change it maybe, use updateOne or updateMany. Be aware of the behavior of update. We worked with our flight data quite a bit. Now let me add another kind of data. I'll clear the console with the CLS command for that. And now I'll add a passengers collection to my flights database. And I want to insert many passengers in there. Now you find a file attached to this video, the passengers JSON file, with an array of passenger data, just some dummy names and ages. Copy that and add it here, and add a closing parentheses at the end and hit enter. And this should insert many elements with the insertMany command with all these automatically generated IDs. Now we can have a look at that data by accessing passengers, and you can always just type and then use tab autocompletion here, by the way. So simply hit tab in the shell and it should autocomplete. And you can find them and pretty print the results. There are our passengers. Now on first sight this might look good, but actually if you have a look at the last entry, Albert Stone, and then you have a look at the data you found attached, you will see that Albert is not the last entry. Gordon Black actually is. Now the order here is the same order as it was added to the database. So where is Gordon? Well, you also see the type IT for more. If we type IT, then we see Gordon Black. Now this IT command is a feature shown in the shell. I will show you another way of getting the data if you were using a MongoDB driver in an application in a second. But the fact that we had to use that is not shell specific. Instead, find, so passengers, find, or the find command in general, no matter on which collection you use it, gives you back a cursor and not all the data. Previously, it looked like it always gives us back all the data, but actually it gives us a so-called cursor object. Now what is that? Find does not give us an array of all the documents in a collection. And that makes a lot of sense because that collection could be very big. And if find would immediately send us back all documents, and you think about a collection with, let's say, 20 million documents, then this would take super long, but most importantly, it would send a lot of data over the wire. So instead of that, it gives us back a cursor object, which is an object with a lot of metadata behind it that allows us to cycle through the results. And that is what that IT command did. It basically used that cursor to fetch the next bunch of data. So find here really just gives us back that cursor. And we can actually see that by using some other methods here. For example, there is toArray. If you execute this, now you see Gordon Black as the last element, and now there is no type IT to see more, because toArray will actually go ahead and exhaust the cursor, so go through the entire list and fetch all the documents and not stop after the first 20, which, by the way, is simply a feature by the MongoDB shell. It gives you the first 20 documents automatically, but then stops. toArray simply gets them all and gives you an array. Now that might be fine here, but of course that is also not optimal if you got a lot of elements. In your application code, you would most likely use something like passengers, find, and then there is a for each method. And for each here simply allows you to write some code to do something on every element that is in your database, on every document you got in there. Now, the exact syntax you can use is something you can find in the driver docs for your driver. So if you're using PHP, check out the PHP MongoDB driver docs and you will see how to use that for each function. In JavaScript, and the shell is based on JavaScript, you could pass a JavaScript function to it using an arrow function here, where you will get an argument passed into the function automatically, and that will be your document. You can name this argument however you want. So in our case, it will be our passenger data. And then you can use it in here. And here in the shell, there is a print JSON command, which we can use to pass or to, pass our JSON data, which we want to output, like passenger data. And now we also get all the documents, because now what we're doing is on the cursor, which find does return, we execute the built-in for each method to execute this method here, this anonymous method, on every element. And the cursor will simply go through our entire collection, fetch all documents one at a time, execute that function on it, pass the document into the function, and then here we just happen to print it out like this. In your application, with your favorite language, you can of course do to the data whatever you want to do. Render it onto an HTML page, send it with an HTTP request, whatever you need to do. And that is just what I want you to take away from this lecture. Find does not by default give you all the documents, even though it looked like it did, because the shell actually gives you the first 20 documents by default. Instead, find gives you a cursor, and then it's up to you to use that cursor with toArray to force it to get all documents and put them into an array, or better, for large sets of documents, with for each. And there are more methods available, which you find in your driver docs. Technically, you need to know that with for each, it will really just fetch the next document for every loop cycle. So this is very efficient here because it does not fetch all the data in advance, load it into memory, and then force you to go through it with for each. Instead, it really just fetches the data on demand, therefore, of course, not overusing your bandwidth and not loading too much into memory. So this is the important thing to take away. Find gives you a cursor and not the element itself. This also is the reason why on findOne we could not use pretty. You remember, if I use passengers, findOne, this works. findOne pretty fails, because pretty is a method that simply exists on the cursor here. So this is why findOne does not support it, because findOne does not give us a cursor, because it only gives us one document anyways. Find gives us multiple documents, therefore we don't get the data immediately, we get the cursor instead. The shell happens to take that cursor and give us the first 20 documents by default, but we can also control it with for each or toArray, and here pretty exists because it is simply a method that exists on the cursor to pretty print the output. This is what you need to take away here. For the other methods like insert, update, and delete, cursors do not exist because these methods don't fetch data. They manipulate it instead. We already covered a lot about how to retrieve data, how to store data, update, and delete it. And we're nearing the end of this module. But before we conclude the module, there are two other important things you gotta know. And the first one is projection. Now, what is projection? Imagine you have this kind of data in your database. Some information about a person, in this case me, with name, age, job, and that ID. Now imagine in your application you don't need all that data. Maybe you just need the name and age for a given page on your website. Of course, you could fetch all the data and filter it in your application. In any programming language, you can of course manipulate the data you're getting back. But you would still transfer it over the wire. So you would kind of impact your bandwidth. You would fetch unnecessary data, and you want to prevent this. So it would be better to filter this out on the MongoDB server. And this is exactly what projection can help you with. Projection is super easy to use. Let me show it to you. We got our passengers, and on the passengers, let's do a quick find again. Here are our passengers. And now let's say I'm only interested in the names of the passengers. Now you can do projection by using find. Now you need to pass a first argument because I actually want to pass a second argument. And that first argument now is an empty document because I want to find all passengers and I don't want to pass a filter. And the second argument now allows us to project. And here, the projection is set up by passing another document, so another pair of curly braces. And here you simply specify which key value pairs you want to get. For that, you simply name the field you want to get. So let's say in our passengers, we have a name and we want to get that name. So we type name here, and then as a value, simply a 1. This means included in the data you're returning to me. If we now output that, we get all our fields with just the name and, well, still the ID. So the age is missing, and the age is of course not missing in the database, but only in the data we retrieved from it. So in the data we're showing here. So this is projection doing its job. But what about the ID? The ID is a special field in your data. By default, it's always included. So the default in general is everything is included. But even if you use projection, as we do it with the second argument, the ID is always included too. If you use projection like this, normally only what you add here, so name in this case, is included. But the ID is also always included. You have to explicitly exclude it if you don't want to add it. Now you exclude something by simply specifying its name and then using 0 instead of 1. We could do the same for age, but this is not required because the default for everything but the ID is that it's not included if you don't add it in your projection configuration. But for the ID, we have to be very clear about it. And now with that, if I hit enter, we get only the objects with the names. So this is projection doing its job. And the important thing to understand here is that this filtering or this data transformation is happening on the MongoDB server. So this happens before the data is shipped to you. And this is of course what you want, because then you don't get unnecessary data, you don't impact your bandwidth, and therefore you can only work with what you need in this case. We're almost done with this module. Now let me show you two other important pieces of data you can put into your documents. You can use embedded documents, and this is actually a core feature of MongoDB and a core feature I'll come back to in my data schema and relations module in this course. Let's imagine this box is one document. Embedded documents then simply means that you can have a field in your document, like name, but then this could be another document. So the value of the field could be another document. And you can have multiple such documents. And these documents can have other sub-documents, which can have other sub-documents. So you can nest your documents all in one overarching document in one collection. So here, we can have up to 100 levels of nesting in MongoDB. This is a hard limit, but you can have a lot of nesting. And to be honest, you rarely need more than 3 or 4 levels. And you also got another hard limit. The overall document size has to be below 16 megabytes. That might sound small, but since you only store text in there, you don't store files in MongoDB, for example, you would use your file storage for that. Since it's only text, 16 megabytes is actually quite a lot. Still, these are areas to keep in mind. So these are embedded documents. Another kind of data you can store are arrays. And this is not strictly linked to embedded documents, though it can also be documents. You can have arrays, in this case, of embedded documents, but arrays can hold any data. This simply means that you have lists of data in a document. Now, this is, of course, very theoretical here, so let me show you an example in the next lecture. Let's go back to our flight data. Let's quickly find all the flights here. This is our flight data. And now let's say we want to store the status for a flight. For this, I'll use my flight data and I'll update many elements. I'll pass an empty document as a filter to target them all. And then here we have $set and then how we want to change them. And now let's say we want to add a status field, but that status is not something like on time, which you could use. But let's say this is another document. So here another pair of curly braces. So this is now a value we set for status, which we add to our flight data. And now here you can enter anything which you can have in a document, multiple key value pairs, even other nested documents if you want. So here We could have a description field, which is on time, and maybe last updated, which is 1 hour ago. If we now hit enter here, it updated both documents because we had no filter. And if I now output my flight data in a pretty way, we see these nested documents here. And this is what's called embedded document. I use nested and embedded interchangeably here. So this is an embedded document. It's another JSON document within a wrapping JSON document. We got 2 documents in the collection, and each of these documents has a child document. And as I said, inside of the status, you could have another nested document. So if I would repeat my command here and add another value with maybe details, that could be another nested document, so another pair of curly braces. Maybe this has a responsible field, and there I put my name in there. If I now hit enter and I output all the flights again, now we see another nested document in there. So a nested document or an embedded document in an embedded document in a collection document. So these are embedded documents. And now we also can have arrays of data. Let's have a look at that in the next lecture. So we saw embedded documents. Let's now have a look at arrays of data. And for that, let's go back to our passengers. So remember, we got our passengers collection. If we find all entries there, this is how a passenger looks like. Now let's say we also record the hobbies of our passengers. For this, I'll edit Albert Twostone here with updateOne. So by selecting the passenger with the name Albert Twostone, like this. And I'll update it by setting a new field there, hobbies, which is an array marked with squared brackets. So this is important. Now it's an array. And here we can have any kinds of data in there. We could have multiple documents in here. That would be fine. But we can also have multiple numbers or simply strings like sports and cooking. These are just strings, not documents. So any kind of data you can have in a document can also be in an array in a document. If I hit enter and I output my passengers, you see Albert now has hobbies. He's the only passenger with that because we filtered for him. And hobbies is now a list of data. It's not a nested or embedded document. It's a list of strings in this case. And as I said, this could be numbers. This could also be other documents. So you can also have documents in an array, and you can have arrays in documents. This is possible. You can even have arrays in nested documents. This is all possible. So in the last lectures, we learned about embedded or nested documents and arrays. And this gives you a lot of flexibility to structure your data in the way you need it to be structured. Also something I'll dive into deeper in my data schema and modeling and relations module in this course. One thing I want to do before I close or finish this module is I want to show you how you could access such structured data. And let's start with the hobbies here. You can, of course, output that by, let's say, finding Albert with find, and then I'll look for name Albert Twostone, like this. Now, if I pretty print that, here's Albert. We can now access .hobbies here because find will give us that person and hobbies should give us access to the array here then. Though, one important thing, we should use findOne here so that MongoDB knows we'll only have one element so that we can directly access the fields of that element after fetching it, so after the closing parentheses. With this, we indeed get the hobbies output here, sports and cooking. And we can even search for that. If we want to find all passengers with a hobby of sports, what we can do is we can access hobbies here, which is an array, and look for sports and output that in a pretty way. And here we find Albert too, the entire document, not just the sports entry, because we're looking for the entire passenger documents where hobbies is equal to sports, and MongoDB is clever enough to see that hobbies actually is an array, so it will simply look if that array has one element named sports, and then it gives us the entire document as a result. So this is how we can also query such arrays. Now, how can we query objects? Remember, we had nested objects, nested documents in our flight data. So here, if I find all, we had the status. Now, if we want to find all results with a status description of on time, we can use our flight data and find. And now in the filter, we want to look for the status, but the status, well, we're interested in one of the fields of that nested document. For this, we can use status dot and then the nested field. So you use dot notation to drill into your embedded document. So dot description. Important when using that. So when having a dot in here, when using such a path to a nested field, you need to wrap the entire term with double quotation marks though. Otherwise it will fail. And now we can check where is this equal to on time. If I now print this, I get both my flights because both have status description of on time. We get no error. Instead, this query works. So we can drill into embedded documents with that dot notation. And obviously we can go one level further as far as we need to. We can also drill into details. So if we're looking for our details here, and we want to find all flights where details responsible is Max Schwarzmuller, we can do that too. Now I'm drilling into details responsible, and I'm looking for Max Schwarzmuller here. And I again find both flights because both have Max Schwarzmuller as a responsible person. So this dot notation is also something you'll see a lot in this course, as this is an important syntax that allows you to look into embedded documents in your filters. And this is it for now. We'll dive much deeper into all of that and how to write efficient queries and how to access your data and work with it. We'll dive into all of that throughout the course. These are the core things you gotta know about how MongoDB works, how you can work with it, how you can store, update, delete, and read data, and how you can also structure your data. Now, as I mentioned, we'll have a whole module where I dive into how to optimally or cleverly structure your data and how to work with related data, but this is now a good start. Let's practice this before we learn about a different way of looking into your data. That's it for this module. We had a detailed look at databases, collections, and documents and what all these things are. That a database holds multiple collections, and each collection can then hold multiple documents. This is how MongoDB structures its data. Databases and collections are created lazily. That means only when a document is inserted, only when you need a specific database or collection. A document can't directly be inserted into a database, it's always part of a collection. So keep that layered architecture in mind. Documents have a certain structure. Each document needs a unique ID, which has to be called _ID. You can set this on your own or take the one MongoDB creates for you. And you can have embedded documents as well as arrays, as well as texts, numbers, all the other data types you already saw, and we'll dive in later in this course. An important part or aspect of working with a database is that you can perform CRUD operations. That stands for create, read, update, and delete. MongoDB offers multiple CRUD operations for a single document and bulk actions. You can insert one element or one document or many documents. And you can find many documents or find one document. Some methods require arguments. Insert one, for example, needs to know what you want to insert. Other methods like find can use arguments, as you will see and as you already saw in this module, but don't need one. Find, by the way, also returns a cursor, not a list of documents. That cursor is useful for manually going through the documents because otherwise all the documents, which could be thousands or millions, would have to be transferred over the wire in one go, which would not be that great for your bandwidth and your connection. You can use filters on find and also on update and delete to narrow down which documents you want to find, or you want to update, or you want to delete. Last but not least, talking about retrieving data, you should be aware that you can use filters and operators. Filters and operators basically allow you to narrow down the set of data you found, like the greater than operator, and you can identify all these special operators provided by MongoDB by the fact that they start with a $sign. And this allows you to simply limit the amount of data you're fetching. And you can use projection to then take the data you fetched and tell MongoDB which fields you actually want to get and which you don't want to get. So filters allow you to restrict the amount of documents. Projections then allow you to restrict the amount of fields per document, so to say. These are the basics. Let's now move on. Now with the core basics set, now that you know how you can basically insert data, read data, and so on, and that you also saw how you can explore your data, let's take a step back and start at the basis or the start of any project. And there you'll have to decide how you model your data. How do you plan to store your data in the database? Which relations exist between your data? And how should these relations be reflected in your database? These are all important questions, and these questions will impact how you use MongoDB and how you structure your data there. Therefore, in this module, we'll have a look at document schemas and understand what's up with these and how you can create document schemas or define document schemas. And we'll also have a look at the important data types MongoDB offers to you, because data types like text, numbers, but also some advanced types like dates and so on, are of course crucial to enable you to store exactly the data your application or your use case needs. We'll not stop at these data types in the general document schema though. We'll also have a look at relations between documents or your data. Because in most applications, you got different entities. Things like, let's say, when you're building a blog, you have posts, you have users, you have comments, and all these entities are related. And these relations need to be reflected in your database too. And you will see how that works in MongoDB in this module too. And last but not least, having an idea of how your data should look like is nice, but you also want to validate incoming data. So all your inserts and updates, you want to validate whether the data getting written there fulfills your requirements. So for example, if that age of a user really is a number. And you will learn how you can perform schema validation in this module too, therefore. Let's start with document schemas. And there's one important question. Wasn't MongoDB all about being schema-less and enforcing no schemas? It is. MongoDB does not enforce any schemas. Your documents can look the way you want, and you can have totally different documents in one and the same collection. Let me show you an example for that. Here I'm again connected to my local and now cleaned up MongoDB server. I simply deleted the data we wrote in the last lectures. So I got a clean database here, a clean server. And I will simply switch to a new database, which, as you learned, will be created on the fly, on demand. So I will switch to a new database and I will simply name it shop. Because imagine we're building the backend for our online shop and we're now modeling the database for it. Now in that database, I'll probably have a products collection where I store my product data. And there I will insert one product, a new document therefore, with, let's say, a name, and I'll simply name it a book, and a price. And the price might be double, so a number with decimal places. If I now hit enter, this gets acknowledged, this gets inserted, and it gets this automatically created unique _ID field, which every document requires. And now we obviously have it in there. Now let's add another product. And what we can do in MongoDB is that this product looks totally different. So there I might have a title, which is t-shirt, and I might have a seller, which is a nested document, let's say, an embedded document, with a name of Max and the age of 29. Now, this is a totally different document. It still could describe a product, though the price is missing, but maybe it's free, we don't know. And if I now look into my products here, by simply finding all products and pretty printing them, we see we got these two products in one and the same collection, and this is fine. MongoDB will not complain about that. You can absolutely do that. You can mix totally different schemas, and the schema simply means the structure of one document. So how does it look like? Which fields does it have? Which types of values do these fields have? That is what is a schema. So we got totally different structures or schemas, as you could call it, in one and the same collection. And that is fine. As I mentioned, MongoDB enforces no schemas. You can mix them. But in reality, you will probably have some kind of schema. Because if you are building the backend for your online shop, it's in your interest that all your products have a price, for example. That they all have a name which is stored in a field named name. Because if you then write some application code, let's say in PHP or in node.js, and you retrieve your data from your database, you obviously want to cycle through that data and output it into a view which you render to the user. And to cycle through your data and access your data, you need to know in which field which data is stored. So you will most likely have some kind of schema because you as a developer want it, because your application needs it. So whilst you're not forced to have a schema, you will probably end up with some kind of structure. And that is the important thing to understand. You got total freedom, total flexibility, and if you need it, use it. But in reality, you probably will have to think about how your data looks like, because your data will need some kind of structure so that you can work with it efficiently. Let's have a look at that schema thing, and let's think about the options we have. So obviously, we can have a totally chaotic approach, as I showed you in that last little example, with totally different documents in one and the same collection. Or we follow a SQL world-like approach, where we make sure that all elements, all entries have exactly the same schema, and there is no extra entry on any document. So we got the whole bandwidth, and we also got some shades in between. So in the chaos world, we basically got what we just saw in the little example. We got maybe a products collection with totally different products in there. So that is possible in MongoDB, but it's probably not what you need or what you'll use in reality. Maybe you're somewhere in between. You got some kind of schema. For example, here all my products have a title and a price, but you got some extra information on some of your documents. So there is maybe some extra data on some documents, but the general schema is the same. And there probably are some core fields which exist on every document. Well, or you got the other extreme, where all documents have exactly the same structure, like here. Now, anything is possible here. You can go with any of the three solutions or any step in between, depending on how you need it in your application. But in reality, I guess either the approach on the right or most often the one in the middle is what you will see in reality. Because there you use the best of both worlds. You have some structure because your use case, your application probably needs it, but you also take advantage of the flexibility MongoDB gives you so that you can store extra information. That, by the way, is also possible in the SQL world. There maybe you would have a null value for some fields. Well, in the middle world, you simply omit a field if you have no data, and you assign a value to the field if you do. So that is really a mixture. In the end, go with whatever works for you. The case in the middle and the case on the right are the more realistic ones, or the ones you see more often in reality, I guess, though. Back in my collection, let me quickly clear my products here with delete many. And there I'll simply pass an empty pair of curly braces to delete all my entries so that now it's empty. And now in there, let me again insert some products, insert one. And I want to show the two approaches which are the most realistic ones. Let's go with the middle approach first, which might be the one you see most often. There you have a name like a book, you got a price like $12.99, and that's maybe it for the first product. And then you enter another product, and that product also will have a name and a price, because these are probably some core fields which every product needs in your application. Because on the page you render to your users on a website, let's say, you probably want to show at least a name and a price. So for our other product, t-shirt, simply the value changes, but the fields are the same, and the names of these fields also are. Whoops, I hit enter accidentally. Of course, I should enter a price here, like $20.99. So now if I look into my products here and I print that, we see both elements are in there. Now, this is the case on the right, the SQL world. We got exactly the same structure, just the values differ. Now, you might have another product, let's say a computer, and of course that also has another price, like this. But this might now also have an extra field, details maybe. Let's say in your shop not every element has details, because maybe a book for some reason doesn't require details. Obviously, you could argue a book and a t-shirt also have detailed data, but this is just an example. Let's say our computer has some details, because there we basically have the CPU, and that is a text where we have Intel i7, some build number. Like this. If I add this, and now I find all my documents, we are in the middle world. We got a core structure which every document fulfills, like a name and a price exists on every document. A little side note here is that the price actually does not always have the same kind of data. It looks like it always has a number, and that is true, but we switch between a double number, so a number with decimal places, and an integer, a number without decimal places, but that's a side note. I'll come back to data types. So generally we have the same though, name and price, but then we got some extra information on one product. And that might be something that works for your application too, because there you could of course have some code which always displays the name and the price, but only displays the details if available. And therefore we can reflect this in our data, and we now are in that middle column of the last slide. So this is one of the more realistic cases you'll have in MongoDB, and this is a totally fine way of using it. Well, all the use cases were fine, but this is one you'll encounter in practice too. Or, of course, you have exactly the same fields for all your products. Just to showcase this real quick, I'll again go into my products database and delete all my products in there with deleteMany. And let's say we want to have that same structure we had before, but now we want to have that in a way where all documents have exactly the same fields. And that is possible. If I repeat my insert commands here for the book, we would simply set details equal to null. Null is a value which you can assign to indicate that, well, there is no value, but there is the field available then. So if we do that, and we do the same for the t-shirt here, so we also have the details set to null there, and I then also enter my computer. If I now find all products and print them, we see the difference to before is that we still have no details data for the first two products, only for the third one. But now we still have that field in there. That is the more SQL-ish approach, I'd say, because the structure is now exactly equal in all documents, except for that number thing which I mentioned. The price is a different type of number, but otherwise it's exactly the same structure. And this might also be an approach you use because you like the clarity of having exactly the same fields everywhere, and you simply indicate that no value is available by setting the value to null. Now here you can take either approach. It's probably a bit more MongoDB-ish to simply get rid of details if it holds no value, but ultimately this is also up to you, and you could take this route too. There is no single best practice here. You can go with whichever approach works better for you, or whichever approach you personally prefer. So now that it's clear that we are free to define a schema for our documents and to structure them in exactly the way we want them to be structured for our use case or application, Let's have a look at the different data types we can use in MongoDB. So basically, the types of data we can save in our fields in our documents. There we, for example, have text. We already saw text data types in this course. Text always uses these quotation marks around the value. And important here, I'm talking about the values, so the part on the right side of the colon in your JSON documents. So you can save text like names. You also got no hard limitation here. The only limitation you have regarding the maximum amount of characters in your text are the 16 megabytes overall size for the whole document. If your text is greater than that, well, then your document becomes too big and your text is too long. We also have booleans. Booleans are simple values. True or false. Is something the case or not? Is a user an administrator or not? You could save that as a true or false value, and that value is called a boolean. Another core data type are numbers, of course. And actually, we got a couple of different numbers in MongoDB. We got integers, for example, and you see int32 here because MongoDB knows different kinds of integers. Int32 integers are integers that are 32 bits long, and therefore if you try to store values that are longer than that, they will overflow that range and you will end up with a different number. For longer numbers, MongoDB has a solution though, a long number, an int64 integer, which you can also assign to store values. In the shell, by the way, if you just enter a normal value, it is treated as a float value. That is because the normal shell, as we use it in the course, is based on JavaScript, and JavaScript doesn't differentiate between integers and floating point values, so values with a decimal place. Therefore, everything will be stored as a 64-bit float value in the shell. That is the default value, and we'll play around with that a bit and see more of that in the numbers module of this course. But be aware that MongoDB is able to store smaller integers and bigger integers. The solution you choose here, of course, kind of defines how much space will be allocated and therefore how much space will be eaten up. And you also can store decimal numbers, so numbers with decimal places. I already said that the default in the shell is to store a floating point value. You also got a special type, number decimal, and that is provided by MongoDB to store high precision floating point values. Because normal floating point values, also called doubles, are basically rounded, so they're not super precise after their decimal place. For a lot of use cases, it's enough though, like for prices in a shop, you got enough precision for that. But if you're doing scientific calculations or anything like that, you might need a very high precision, and there is a special type that offers this very high decimal place precision, where you got 34 decimal places, so after the comma, which are not rounded but guaranteed to be correct and precise. It's simply a computing limitation that we got no 100% precision all the time, but that rounding occurs. Now, besides these basic values, even though some number of values here already are a bit more advanced, we also got the object ID value. The object ID object is a special object automatically generated by MongoDB to give you a unique ID, which is not just a unique random string, but also a string that contains a temporal component, so that if you create two elements after each other, two documents after each other, you are guaranteed to have the right order due to that ID, because the older element will have an ID that comes prior to the other one. So there is this sorting built into the object ID because it respects a timestamp. Speaking of timestamps, you can also save a date in your database. There is a special ISO date type which you can use. You can construct the date and save that to your database. And that is then a date which you can work with to do date calculations and so on. And there also is a timestamp type. The timestamp is mostly used internally. You can create it automatically. Mostly you let MongoDB create that for you. And that is guaranteed to be unique too. So even if you create two documents at the same time, they will not have exactly the same timestamp, because it will basically take into account the current time and then also add an ordinal value so that two documents at the same time still don't get the same timestamp but respect the order in which the insert command was issued, for example. So you got that timestamp too. And you could say that object ID kind of is based on that timestamp and then just uses some algorithm to spit out a seemingly random string. Last but not least, you saw that you can embed other documents. That's of course important too. You can embed documents, and these documents can then in turn embed other documents or hold any fields with any of the values you see here. And you can also have arrays as values. And the arrays are simply lists of values. You can have a list of strings, a list of booleans, a list of numbers, or a list of other embedded documents, or even a list of lists, a list of arrays. That is possible too. So these are the data types, and throughout the course you will see them again, so we'll work with them. And for example, there will be a whole module where I will work with numbers to give you a feeling for why we have these different types of numbers. In the next lectures, I just want to play around with these types a bit and give you a feeling for how we create the more advanced types like dates here, and how we can save them and work with them. Okay, so let's now play around with these data types a bit. I'm on my MongoDB server again, and I dropped all existing databases. You can, by the way, always do that by switching to the database, like test if I had that database here, and then executing drop database, db.drop database. And this will get rid of the database if you have it. But let me now clear the screen, and let's now use a new database, companies, or company data maybe. And in there, let's say I have a companies collection. And in that companies collection, I now want to insert one new company. And my idea here is that for this company, I want to showcase some of these data types. So that company will probably have a name, and that name will be some text. Now, as you learned, the text is enclosed in quotation marks, and you can, by the way, use double or single quotation marks here. This does not matter. That is the case in the shell here, because the shell is based on JavaScript. For the programming language you're using with the MongoDB driver, that might differ, of course. So here, let's give this any name, like Fresh Apples Inc. It's a company I just came up with. And now with that company name added here, what else could we add? Well, let's say this company is a startup, and therefore we add a isStartup key here. And this simply is, well, true. So here I'm using a boolean because the case or the question whether this is a startup or not can be answered with yes or no. And translated to a boolean, that would be true or false. Here it's yes, so it's true. Now, besides that being a startup, let's also log its number of employees. And I'll add 33 here. So this is a number, and this is actually an integer, you would think at least. Now, the shell which I'm using here is based on JavaScript, and JavaScript doesn't differentiate between integers and floating point numbers. This would be a floating point number, by the way. So this will actually be stored as a double or float in MongoDB, not as this number decimal special high precision thing I mentioned on the slide, but a normal floating point number with some imprecision on the decimal places. Now, that might be fine. And for now, let's simply store it like that. Let's also add a funding here, and let's store a very large number there. And I'll actually store a number which is easy to remember by just sliding over my numbers twice. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, and then again. Let's also add an embedded document here, details maybe. And there we could simply have any additional data we want, like CEO, Mark, Super, obviously a good name for the CEO. And let's also add a list. Tags maybe. That is an array. You always add an array by using square brackets. And there, in turn, we can add any value we want. So this can hold multiple string values like super, perfect, whatever you want. It could also hold numbers, and all the values in the array are just separated by commas. Or it could, of course, also hold other nested documents. So this could hold other documents with tags which are, well, basically documents with a title that then holds the value. So whatever your application needs is possible. You're really flexible here. So here I go for the embedded document in an array style. Now, besides these values, we also learned about dates and timestamps. So if we also add the founding date here, we can construct a new date in the shell by calling new date. And if we add it like this, it will take the current date. And I will indeed do that here. We can also add a timestamp, like inserted at, to give that a clear timestamp when this data was inserted by calling new timestamp. Now, these are functions, new date and new timestamp, that are provided by the shell. There are equivalents in the drivers for the different programming languages though, and you'll find the exact methods you need to call in the driver docs. Here, for example, I'm on the page of the MongoDB Node.js driver, and there I can click on the reference of the latest release, and of course such release references are available for all drivers. And in the documentation for the driver, you find detailed instructions on installation and how to use it, and you should also find an API documentation, which is simply a list of all the features that are included. And in there, for example, you also find long and int32 that will be useful methods or objects when working with these values. And you also will find something that helps you with a timestamp, for example. So down there, if you click on timestamp, you open the timestamp doc and you'll learn how you can create a timestamp in that Node.js driver. So there by calling new timestamp after importing the timestamp from this MongoDB driver. And more information on that and how to use that driver and so on can, as I mentioned before, be found in the general driver docs, like the tutorials here, the quick start, or the general reference here. So that is how you can use these types you'll learn about here in the shell in your driver too. So the shell here is based on JavaScript, therefore here we actually do use new timestamp to create a timestamp. And with that, for now, I added all the data I want to add. If I now hit enter, this gets inserted. And now let's have a look at it by finding one company, so the one we just added. And here we see that company was added. We see the data we added. We see, for example, for the date, we got this ISO date object with the current date I'm recording this at as a value entered here. You see it uses the year, month, day format, then a T to separate the time from the date, and then we got the time in a 24-hour format stored here. The set at the end marks the time zone for which this time is logged. You also see that timestamp object, and as I mentioned, this is actually a timestamp based on the current time in milliseconds, and also it has an ordinal component, so that if I were to insert two elements simultaneously with insertMany, they would have different timestamps. Now, one super interesting thing can be seen if we have a look at funding. There you see that the number that is stored is actually not the number that I added. If I scroll up a bit, you see that for funding, I did add 1, 2, 3, 4, 5, 6, 7, 8, 9, 0 twice essentially. So I rolled over the keyboard twice. But the number that was stored is 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 1, 2, 3, 4, 5, 6, 7, and then it's essentially nullified or cut off, you could say. The reason for that is that I tried to store a number that was too big, because the normal number JavaScript accepts is essentially a 64-bit floating point value, and that could not be stored here. And that is a restriction you can face when working with numbers. If you need to store super big numbers, you'll have to store them separately, maybe as a string. Now, speaking of numbers, you saw some general values here on the company. Now let me get a little bit more abstract so that I can show you what's up with these numbers. And I have a whole module where I also talk about numbers and how to work with number data. But for now, let me quickly add some dummy data. I'll use a new collection for this, numbers, and this will be one of the rare cases where I'll just use an abstract example. I'll insert one document here, A1. Now, if I insert it like this, obviously if I access numbers and I find one element, we see it here. Now, one interesting thing can be seen if I now use dbstats. Stats is a utility method provided by the shell which outputs some, stats about this database. Here we see how many collections we got in there, how many objects, and we also see the average object size. Now, I got two collections in there. So let me quickly get rid of the companies collection by calling drop on the collection. Like drop database gets rid of a database, drop on a collection gets rid of that database. If I now repeat stats, we see there's only one collection there, and we get a data size, an average data size of 33. Now remember that value of 33 here. Now I will use my numbers collection and delete all elements, so the one element I got in there. If I now execute dbstats, we obviously see data size 0 because there's nothing in there. Now let me repeat that insert1 command here, but I'll not insert a number like this, which remember is stored as a 64-bit floating point number by default, but I'll use a special method provided by the shell, and you find equivalents in your driver docs when working with a driver, which will create an int32 value instead of that default 64-bit floating point number. And if I store the same number, 1, now with this helper function, and I repeat my stats output, you see that it shrank a bit. And this is one of the reasons why you could consider using these special values provided by MongoDB, because you're able to manage your data size a bit more efficiently. Now, it's also worth pointing out that this was only stored as this 64-bit floating point number because the shell is based on JavaScript, and JavaScript doesn't differentiate between integers and floats. Other languages do. So for other languages, this might not be the case if you accessed your database through their driver and added a number there. For the shell, it is, however. And this is good because here I can show you the difference between the default number, the float, and this integer. You can also check the type of a value as it is stored in MongoDB by using the type of command which is provided in the shell. There I can access numbers, find one to get that one element I have, and then access the A key with .a. And we see the type here is number. Now, I don't want to go too in-depth into that whole number thing, also because it has a lot to do with computing in general and not so much with MongoDB. But I found this important to highlight, that you have these different formats. Often it might not matter, and the default which is stored might work for you. Like for all the numbers we used thus far for ages or prices, we can just enter the number and it will get stored in the database. The sizing difference might not really matter for us. The extra precision we could get on the decimal places will also not matter for only 2 or 3 decimal places. So there we will be fine with the defaults. I want you to be aware of the general set of data types you have, and that there are specialized data types for specialized kind of operations you might plan. You should also not miss the BSON types document, to which you find a link in the last lecture of this module, where you can learn more about the general data types MongoDB knows and how it can store data in its database, and where you can then also learn more about some of the special data types like object ID or timestamps, and which in general is a great backup if you want to dive deeper into a specific data type or learn more about a specific data type. Now that we understand that we can use schemas and that we probably will use them because our application typically works with certain types of data, certain schemas, and that we had a look at the data types you can use, the different integers, text, and so on, now that we had a look at all of that, let's see how we can think about modeling our schemas. And I want to give you some guidelines or hints that you can keep in mind when you think about how should I structure my data. We'll not look at relations yet. I'll come to that next though. But thus far, let's see what we got. One important question is, which data does my app need or generate? And the term app definitely should be understood in a very broad sense here. This can be a mobile app, this can be a website, it could be a smart device generating data, like a tracker, a fitness tracker sending GPS coordinates. So this is a very broad definition of app. The idea is my business model, you could say. Which data does it need and or generate? And it can be anything: user information, product information, orders, coordinates, anything like that. And this will define the fields you'll generally need. And of course, also already a bit how they relate. A user might order products. So this gives you the general frame for your data structure. You then also have to think about, where do I need my data? So for example, if you're building a website, do I need it on the welcome page, on the products list page, on the orders page? And which kind of data do I need on all these pages? Because the idea with MongoDB is that you store your data in the format you need it in your application. And if you need the same data in different formats, you want to find a good structure that covers all these use cases, or if absolutely necessary, you could even split it into multiple collections. So this defines your required collections. For example, that you have an orders collection for the orders page, that you have a products collection for the products page, and it also defines which fields you have in the documents of a collection and how you might group these fields together, so how you might relate these fields. More about relations in a second. You also should ask yourself, which kind of data or information do I want to display? So on these different pages, which kind of data do I want to show on there? And that again defines which queries you will need then. So do I display a list of products or a single product? Is it a find or findOne query? How should I configure this query? Am I looking for a product with a specific ID, or am I looking for all products? And Manual will take a detailed look at how you can configure your find queries to narrow down the set of found products, of course. These queries also, or the kind of queries you plan, also have an impact on your collections and your document structure. Because as I already said, MongoDB really embraces that idea of planning your data structure based on the way you'll retrieve your data, so that you don't have to do complex joins, but that you can retrieve your data in the format, or almost in the format, you need it in your application. You also need to ask yourself, how often do I fetch my data? On every page reload, or every second, or not that often? Because that also tells you if you should optimize for easy fetching, because you're fetching a lot, but maybe you're not writing data that much. So you might be fine with having some duplicate data if that speeds up the fetching process, because you don't have to join data manually. Or do you often write and change your data? If you have an application where your data gets changed a lot, or parts of your data get changed a lot, you want to ensure that these parts of the data that do get changed a lot, let's say we have a lot of orders, but the product metadata doesn't change that often, you want to make sure that your orders are not unnecessarily duplicated across collections, but that you have one collection with your orders where you can write new orders too. Product metadata, on the other hand, might be distributed across different collections because, well, you don't change it that often. So if you change it, you have to touch multiple collections, but that's no problem. The main focus is that you can fetch that data from the different parts of your application in the format you need it. So these are some things for you to keep in mind or to think about. And if that is a lot right now, that is totally normal. No worries, we'll see all that throughout the course, and we'll have many examples so that you can get a feeling for, well, how you might approach that and how we would structure data in a certain scenario. And one important thing that is related to these questions is, of course, the question about how you model relations between different entities in your data. And that is what I'll take a look at next. So we had a look at the general data structure, but always only for one collection and the documents in that one collection. Typically, you have multiple collections though. You might have users and products and orders. So if you have multiple collections that still are related, of course, or where the documents in these relations are related, you obviously have to think about, how do you store related data? Do you use embedded documents? Because that, of course, is one way of reflecting a relation. If a user has an address and that address consists of a street and a city, then you might have a nested address document in the user document. Or do you work with references? Here are two examples. As I just said, we might have a nested document, an embedded document. Here are my customers. And by the way, of course, in JSON, the field names like username, age, and so on would be enclosed in double quotation marks. I'm just leaving that out here to save some space. So this is not a real JSON code, but it is the structure of the data. And here, my customer has an address, and that address could totally be stored in a new collection. But we can also embed it into our user or into our customer here because it's strongly related to that customer and we might want to fetch both at the same time, or at least have an easy way of fetching both if we need to. The alternative is that you use references. Let's say we still have customers and each customer has a list of his favorite books. And we could absolutely go with nested or embedded data. So here we have an array with embedded documents. And each document is shortened here, but each document could be a book with a title, a price, an offer, and so on. Now, the problem here is that we will have a lot of duplicate data because different customers can have the same favorite books. And if we then change something about that favorite book, we'll have to change it on all customers. So instead here we might go for references. We might have a customers collection and a books collection. And in the customer, we still have that array of favorite books, but there we only store the IDs of the favorite books. That means that when we fetch the customers and we also want to fetch the favorite books for the customer, we have to run 2 queries. That is correct. But on the other hand, if we change a book, we don't have to change it on 10 different customers, but only in the books collection. And the ID will never change, so we never have to change or touch the favorite books array in the customers document. So we have that relation through a reference. Now, you got these 2 different approaches. And now the obvious question is, when should you use which? Time to have a look at some examples. Here's example number 1. We had a kind of related example earlier in this course already. Let's say we're creating our database, our application for a hospital. And there we got patients and their disease summary. So every patient has one disease summary, which belongs to that patient only. And there is only one summary per patient. So we're not talking about the history we had earlier in this course. It's just a summary. Something like is ill, had previous diseases, and a list of previous diseases, things like that. So one summary per patient, and of course this is a one-to-one relation, because the summary of patient A can never belong to patient B, and the other way around. How could we model that? Back in a brand new, cleaned up database server, I'll switch to my hospital database, which will be created on the fly, and there I want to create my patients collection, or to be precise, I want to insert a patient. So let's insert one patient. Now let's say a patient simply has a name, Max, a age, and then we have that disease summary. Now let's go for the reference approach first. Disease summary could be summary max 1, any identifier you want. So here I'll go for that ID approach. We can insert that, and obviously if I now inspect my patients with findOne pretty, we see that one patient in there without pretty though. That is not existing there. So we see the one patient in there. Now let's also create another collection, disease summaries, and then there I'll also insert one summary. There I'll explicitly define the ID and use my own ID, summary max1. I could have also gone with the automatically generated object ID, but then I should have generated the summaries collection and that entry first, so that I could take that object ID and use it as an ID on the patient. I did it the other way around, so I'm using my own ID here. And there I'll simply add my diseases array, which simply lists all diseases I ever had. And let's say that's a cold, and that's a broken leg, which I never had, but anyways. So now I added this too, and now of course I can access my disease summaries collection here, find the one element that is in there, and this is the element that just inserted with my own ID. And that ID of course matches the ID I stored as a reference on my patient. Now let's say in our application, the website we're building, the mobile app, whatever it is, we now have a request where we need that patient and also the disease history, or the disease summary, I should say. So we might have an incoming request, which in the end, by the MongoDB driver, is translated to a find request. So we first of all find our patients. And in reality, we'll probably do that by looking for, let's say, all patients with a name of max, or here, as a shortcut, since I only have one, I'll just use findOne. The thing is, in the end, we have some query that returns max here. So that is my returned patient data. The problem is I'm also interested in the disease summary. So I also want to get that. Now what I can of course do is, in my application, I can access disease summary and therefore get my key here. And in the application we're writing, in PHP, .NET, Java, Node.js, whatever it is, we can of course fetch some data from a server and then store that data in a variable. So let's say here in the shell, we can do this with the var keyword. We have our DS ID for disease summary ID, and that simply is the result of patients findOne, and then they're accessing the disease summary. So now if we output DS ID, that is the ID stored in this patient. And now we can simply reach out to disease summary, so that our collection, and there we want to find the first disease summary where _ID is equal to DS ID. So I can use that variable here. And I simply stored it in a variable so that I don't have to paste or add this long term here as a value for ID. If I do that, I indeed find my disease summary. The bad thing here is that this took 2 steps, and also from a performance perspective, this will actually be super fast. But if you have a very big database, a very big collection of patients, and a big collection of disease summaries, this might not be the optimal way of doing that. Splitting that across 2 collections feels a bit unnecessary here. The better approach in such a case, where we have a strong one-to-one relation, would be to use an embedded document. So let me actually reach out to my patients and delete all patients in there. And now let's insert that patient again. So that insert1 command from earlier, where I inserted max. Now I will not insert a disease summary, which is a reference, but instead I'll insert a nested and embedded document here. And now that embedded document would have my diseases key, my diseases field, with the cold and the broken leg, like this. And now the huge advantage, of course, is that in the application we're writing with whichever language we use, I can simply write my query to find my patient by ID, by name, or in this case, as a shortcut, simply with findOne, and I will get all the data I need, the patient data and the disease summary data. So this is an example for when you would use an embedded document. You have a strong one-to-one relationship. Now, in the last lecture, we saw a one-to-one relationship where we want to have a embedded document. Now, for many, probably most one-to-one relationships, you'll probably go with the embedded document. But you're not forced to. You could also have one-to-one relationships where you still opt to use different collections. And here is a possible example. Let's say we got a couple of persons and a couple of cars. And I'm not talking about car models here, so not BMW, Mercedes, Ford. But let's say we have a person and the car this person owns. And therefore, this is a one-to-one relation, because this car cannot be owned by a different person. And that person could, of course, theoretically own multiple cars, but let's say each person can only own one car. So we have a one-to-one relation then, 1 car per person and 1 person per car. Now, we could, of course, still model this with an embedded document. In a brand new MongoDB server, let's add a new collection. We use car data, whatever you want to call it. So that's the database. And now let's add a new collection there. And we could go for persons and insert 1 person here. And that 1 person will have a name, Max, let's say, and we'll have a car. And that car is a nested or embedded document where I then have the model, BMW, and let's say a price, 40,000. Now, of course, I can fetch my persons and get back the car with it. And that might be fine for a lot of applications. But let's say we're not creating some web app where we need to render both on the same screen, but maybe we have more of an analytics use case. So we have a use case where we are very interested in analyzing person data, like average salary or age. All data I don't have in my dummy data here, but we can of course add more data depending on the app. So we're interested in analyzing our persons, and we might be interested in analyzing our cars, but not so much in the relation. That might occasionally be interesting too, but maybe we also want to do a lot of averaging, a lot of analytics on the persons or the cars. So here we have an application-driven reason for splitting this up. There is no hard reason. It's perfectly fine theoretically to merge that into one collection as we are currently doing it, but due to our application needs, this might not be optimal. Because if we're only interested in the cars, there's no need to fetch all the persons just to get to their cars. That would actually mean we have to do a lot of transformation work to extract the car data, and we send a lot of unnecessary data over the wire. And the other way around too, if we're only interested in the person data, I don't care about the cars, so we again would have to do a lot of unnecessary transformation work. So such an application-driven requirement or need could be a reason for splitting this up. For other applications, merging it might be perfectly fine. So here, we could go for an approach where I delete all persons just to clean it up. And then I again insert a person again, insert one. But this time, let's say that is our person with the name and the age and the salary. Like this. And now we have a possibility of fetching all the persons. Typically, we would of course have more than one and do any analytics on that. And if we're interested in the cars, we have these in a separate collection. So there we can insert our car data, like model, BMW, price 40,000, and then here also maybe the owner. And that could be a reference to some ID we define. Or here probably we would go for the ID which we have, the automatically generated object ID. So let's store that. So now we still have the possibility to relate the car to an owner. That is possible. And in the person, we could now also store the ID of the car if we wanted to, depending on whether we often will have fetched persons and now also want to get the car, or the other way around. We got some link. That is the key takeaway. So we can merge the data if we want to, but if we commonly don't do that, we don't have to use an embedded document. We can go for different collections here. So that would be one possible use case where you use different collections, even though you could perfectly embed it. We had a look at one-to-one relations. Let's now have a look at one-to-many relations. Let's say, like in the Q&A section of Udemy, we have question threads, and each question thread then has a couple of answers. So an answer only belongs to one thread, but a thread can have multiple answers. That's a typical one-to-many relationship. How would you model that in MongoDB? For that, I'll create a support database, and in there, I might have my question threads collection, and there I insert one new question thread in the end. There we might have like a creator, Max, so the person who opened this thread. Then we got the question. How does that all work? By the way, not how you should pose a question. Bit more details, please, but that is the question. And then we got the answers. And now the question is, how do we model the answers? We could go for a separate collection with the answers and only store the IDs to the answers here. So there we could have Q1, A1 as an ID, and maybe we also have Q1 for question 1, of course, A2 as an ID. So now if I access my question threads and I find that one question I have in there, we see we're now taking that reference approach again. We have an array of IDs. And that would mean we would now also create an answers collection and there insert many answers, because now I want to have 2 at least, because I have 2 references here. So to complete the demo, let's insert 2 answers. I assign my own ID because I'm using my own ID. Again, we could have created it in a different order and then used the object ID in the answers array here. But here I'm doing it like this. And then we get an answer with the text. It works like that. And I will insert a second document. Important for insertMany, we wrap the documents we insert in square brackets, so we insert an array. So the second document in that array then also has an ID. That ID is Q1A2 to fit that reference we stored. And there the text is thanks. And obviously an answer would probably also have like an ID of the person who created it or the embedded person data, but let's not worry about that right now. If I hit enter, the two elements were added. And now again, we can, of course, look into our answers and see the two answers there. And we can then manually match that as we did it earlier. We could retrieve the question threads, and on the question threads, we could now simply store the different IDs and the answers in variables and then make requests to the answers collection and look for these IDs. And we don't have to make two requests. Later, manual will show you how you could also search for all elements that fit an array of IDs you're looking for. So you don't always have to look for one ID. You can say, hey, give me all documents that are this ID, or this ID. So it's still one extra request though. Here, again, embedding might be the better solution. So in question threads, I'll first of all delete all existing documents to start from scratch. And now again, I will add my question thread with insert1 here. Now again, probably I'll have a creator. I have the question text. How does that work? And then I have my answers. And the answers now are not references, but a list of documents. And there I could have my first answer with the text like that. And then I have a second answer, so a second document in the list of documents with a text of thanks. And now with that, if I save that and we open our question threads and look into the first question with findOne, well, then we see now we have that embedded approach. Now a list of embedded documents, because it's a one-to-many relationship, so we have many documents, but still it's embedded documents which we're using here. And for a scenario like this, and a similar scenario, for example, would be posts and comments related to posts, makes sense to be modeled like this. Because often you need to fetch the questions along with the answers. So from an application requirement perspective, you want to fetch the merged data. And we also don't have thousands of answers on one thread typically. So we also don't have the danger of bloating our document and maybe reaching that 16 megabyte limit we have for a document. So that is not a problem here, and therefore this might be a perfect use case for embedding documents in a one-to-many relationship. Now that we had a look at a one-to-many relationship where embedding made sense, let's have a look at a relationship, a one-to-many relationship, where splitting it in collections might make sense. Here, I got a couple of cities like New York, Berlin, and so on. And I got the citizens. Let's say we have a database, a collection, which holds all the major cities of the world, and then a list of every person living in that city, like the registry of the state where all people are registered, let's say. So we got something like this. The problem we'll face here, theoretically, that would make sense to be a one-to-many relationship where you embed your documents. But from an application perspective, you might often be interested in fetching all the cities with their metadata, but you don't want to fetch all the citizens along with the cities. Because in New York, where we have like millions of people, that would be a lot of overhead data which we don't need, which takes very long to fetch, and which is a lot of data to transfer over the wire. And additionally, for big cities with millions of citizens, you might indeed hit this 16 megabyte limit for the overall document. And keep in mind, that limit counts towards the document and all nested documents. So it's not 16 megabyte per nested element, it's 16 megabyte for the overall document. So you might face this limit too, or might hit this limit too. So for technical and application reasons, here splitting it up might make sense. So here, you might have your city data database, and in there, you have your cities collection where you insert a city, like the name, New York City, coordinates, which is a nested document with a latitude, and this is arbitrary. This is not the real latitude and longitude, something like this. And you store no data about the citizens in there. So you also have no citizens array in here with all the IDs of the citizens, because that would be a super long array too if you have millions of citizens. So you just have the metadata. And there I got a excess square bracket. So you just have that stored, and therefore if you find that one city, it looks like this. And you might also store the citizens, but you will do this, citizens, in a separate collection. And then there you might have your different citizens with the name, Max Schwarzmüller, and the city ID maybe. And that ID could be New York City to match it by the name, or you simply use that object ID, of course. You want to use something which is unique. So let's go for the object ID. So that would be one citizen, and then we have another citizen where you also have a name, Manuel Lawrence. And we're not really living in New York, but just as an example here, you store that like this. Now insertMany needs square brackets around all the objects you're inserting, so don't forget to add these. Hit enter, and I got a typo. I was missing the closing parentheses after object ID. And now I inserted my citizens, and if I inspect my citizens, if I find them all, and I print this, here are my citizens. And now I can always retrieve just the citizens and match them to their city with the city ID if I need to, or fetch just the cities. And I'll not hit the document limitation of 16 megabytes for the city because I don't embed all my citizens. And I also don't unnecessarily fetch all the citizens along with the city if I'm only interested in the city metadata. Now that we had a look at one-to-one and one-to-many relationships, the obvious missing thing is one-to-many. So let's say we have customers who can buy products. So we're looking at orders. A customer might buy multiple products, and a product might be bought by different customers. So one customer, many products, one product, many customers. So this is a typical many-to-many relationship. How could we model that? To say it right away, often you'll model many-to-many relationships with references. So let me again create a new database or join a new database, my shop database, and there I might have products. So I'll insert a product here. That product will have a title, let's say, a book, and the price $12.99. I also will have customers. So I'll also insert a new customer into my customers collection. Name, Max, age 29. And now with that, we could create an orders collection. Orders to insert one order. And there we could now have a product ID and simply take that ID of the product we added. And we could have a customer ID and take that customer here. And now we have that too. Now this would be the SQL world approach, where we have 3 tables in SQL, and we have that join table in the middle, which matches products and customers. Now we can do a bit better, in quotation marks, in MongoDB. We can make it work with 2 tables only. So I can actually drop my orders collection. So DB orders can be dropped. So if you now find that, you find nothing because I dropped it and all the data in it. And with that dropped, I still have my products, by the way. So we still have the products and we still have the customers. So with these 2 tables, I can now add orders without adding a 3rd table. And for that, I'll go to my customers, let's say, because typically I want to add that relation on the customer, because you could say, yes, the product got bought, but actually customer is the active person. And it's more realistic that you're fetching the orders for a given customer than that you want to display orders for a given product. But that would be possible too, and you can use that approach on both tables here. So I'll show it on the customer, and I'll simply update my customer here. Obviously, you could also insert a new customer with existing orders. So I'll update the customer with $set, and then add orders here as an array. And now every order could simply be an object where I have my product ID, and that still is the ID I have up there. So I use this ID down there, and then maybe something like the quantity. We could have also added that quantity to that third in-between table earlier, by the way. So now if I do that and I find one customer, you see now we have the orders, and that might look like an embedded document because it is, but actually we're still using a reference approach here because we did not embed the product data. We just added some metadata for the order, but I'm just referencing the product data. So we're using a reference-driven approach here, and we could add the same orders array to the products if we want to match it the other way around too. So both is possible, or either of the one like we have it here. So now we have a many-to-many relationship with references with two tables, which would be the MongoDB way of displaying or creating such a many-to-many relationship with references. You could also argue that you don't necessarily need to use references here. Often you will, and if that's your use case, it's fine. But let's have a look at the embedded alternative. And for that, I'll update my orders array here, and that will replace it. It will not add this element. We'll see how we can add elements to arrays later. For now, we'll replace that orders array with a new one, with a new array of documents of orders. Here, I now have a title of my product, because say I fetched that in my application when the order was placed, with the price, $12.99. So I'm manually copying this, so to say, and a quantity, 2. Now if I look into my customers collection, we do have an embedded document. This is now not a reference-driven approach, but I embedded the product data along with the metadata for the order. Now, what could be a disadvantage of this approach? A disadvantage is the data duplication. We got the title and price of that product in orders here. And keep in mind that this user might order this product multiple times and other users could do. So you will probably duplicate this data a lot. And if you ever change that data, you not only need to change it in the products collection where you store it, and that is the product data which is displayed in your shop for users to buy it, but you would also have to change it in all the orders. Well, or do you? And that is the reason why such an embedded approach might be fine here. Once the order was placed, even if the price changed for the product, we will not change it for the existing orders, right? The people don't have to pay more after they bought it. So the price here is locked in anyways. The title might change a bit, but do we really care about this in our orders? We might not care. It's not going to change from a book to a t-shirt because it's still the same product in the end. It still has its own unique ID, and we would probably also store the ID along with the product here, by the way. So probably we don't care about a title change too, because if it's a nice book now instead of a book, it doesn't really matter for us. So if we have an application where we kind of take a snapshot of the data anyways, we might not worry too much about duplicating that data because we might not need to change it in all the places where we did duplicate it if the original data changes. And that, of course, highly depends on your application. For a shop and the products and the orders, this might make sense. In other use cases, you might absolutely need the latest data everywhere, and we'll have a look at such a use case next. But I want you to not automatically say, many-to-many, I will use a reference. Instead, think about how do you fetch your data? How often do you change it? And if you change it, do you need to change it everywhere? Or might duplicates be fine? So in the last lecture, we had a look at a many-to-many relationship where changing data might not be that bad for our duplicates, and therefore embedding the documents might be fine. Now let's have a look at a many-to-many relationship where splitting it up and using references might be better. Here we got a couple of books and a couple of authors. And one book can be written by multiple authors, and one author will probably write more than one book. So it's a typical many-to-many relationship. Now let's see how we could model that and how we could store that in our database. Let's create our book registry database here. And in there, I'll have my books collection. And I'll insert a new book with a name, my favorite book, and with some authors. And here, let's first of all go for the embedded approach. So I'll have an author, Max Schwartz, age 29, and I'll have another author. Name is Manuel Lore, age 30. If I hit enter, we can of course find all our books here, print them, and see we got embedded author documents. Now we'll also have our authors collection typically, because when we're managing books and authors, well, we'll need both kinds of data. And authors might then be a collection where we insert many authors with square brackets, as you learned, then multiple documents separated by commas. And there we might have name Max Schwartz. Maybe that also is our unique identifier we can use. Otherwise, we should also store an ID here in the authors of the book. But here we got that. We also got the age. And there, let's say we also have the address as an extra field with a street and so on. And we got the second author, which is Manuel Lore, age 30. And there we also got an address with a street like this. I can look into my authors, of course, with find and pretty print that, and I see my author data. Now that would be a typical use case. We got our books with embedded author data, and that could be all or some of the data we have in the authors collection, and we get just the authors collection. The problem is, if one author changes, maybe I got older, maybe I moved, then I need to update that everywhere where I used it. And that's not just the authors collection, but that would be all my books. And that is especially important, let's say, if I changed my name because I'm married. Then I can't say, yeah, I don't care, it's an old snapshot like we did for the orders. For the books and for the authors, I want to have the most recent data, of course. And if I'm displaying the age in the book, I might say that is a snapshot data, that is okay. For the name, it's probably not. And in my registry, in the database, even the age is not okay. That should be all up to date for future books, for future prints, let's say. So here, if we then change the name of the author, we have to change it here with the update method in the authors collection. And we also have to change it in the books collection by finding all books where this author is an author. And that is a lot of work and a lot of write and update requests. This is bad from a performance perspective because we have to, well, write a lot to the database. It also is error prone because we might be overlooking some document we should update. And therefore, this is probably not the best approach for this scenario. Because in our application, if the data does change, it should change everywhere. Now, even with that, it might be okay if changes are very unlikely to happen. But some data, like the age, will change at least once a year. Other data might change more frequently. And the more frequent we can expect such changes, the more often we'll have to touch dozens or hundreds of documents, so the worse the matter gets. So low frequency might still let us get away with this approach and might make it a good approach. With higher frequency, it almost most certainly is not a good way of relating this. So instead of using embedded documents here, we should go for the reference approach. So we should take the references of our authors and then go to our books collection, update the book, in our case here, the one book we got, and update it by setting the authors to an array of our object IDs. So of the object ID of Max and the object ID of Manuel. And now if we output our books here with findOne, now we only got the references in there, and this is better, because now if we do fetch all the books, yeah, we will have to merge it manually with the author data, but therefore the author data is guaranteed to be up to date, and if we change the author data, we don't have to do that in hundreds or thousands of documents. So these are your relation options. And I hope that the examples kind of gave you a feeling for how to think about relations and when to use which approach. It always depends on your application needs, how often you change the data, if snapshot data does suffice, and how large your data is, how much data you have. In general, with embedded documents, the idea is to group data together logically, and often that makes sense and gives you an easier time when fetching the data. And that is great for data that belongs together for one-to-many or one-to-one relations, and that is not really overlapping with other data, so you got no many-to-many relation, and where you're also not in danger to hit any limit imposed by MongoDB, and where you also don't need to split your data for application needs, like we had in the person and car example here. You should avoid super deep nesting because you can only nest for 100 levels, as you learned. And again, keep that 16 megabyte limit per document in mind. And that also contains the embedded documents. So it's not 16 megabytes per embedded document, but for the overall document. That is a lot, but for New York City with all its citizens, you would probably breach it. The alternative then is the reference approach. There you split your data across collections, and that is great for related data that is shared, so many-to-many relationships in the end, or it's great for data where you would have a lot of duplicates, which you'll update a lot, and therefore you have the danger of needing to update a lot of documents all the time, which is bad. And it's also a great solution if you need to overcome any nesting or size limits. Then you can simply split it across collections, because that, of course, basically allows you to remove some levels of nesting. These are your options. There is no general formula, but if you keep these general things in mind, how do I use my data? How often do I use it? How often do I change it? And how is it related? One-to-one, one-to-many, many-to-many. If you go through all these points, you should be able to really create relations that work for you. Now that we talked so much about relations, let me show you one useful operation MongoDB offers for merging related documents that you split up by using the reference approach, so where you got no embedded documents. And that is the lookup operator. Now, the lookup operator is used like this. This uses the aggregate method, which we haven't learned about. We got a whole module about the aggregation framework, and I don't want to talk too much about it, but lookup is essentially a helpful tool that allows you to fetch two related documents merged together in one document in one step instead of having to do two steps. And this mitigates some of the disadvantages of splitting your documents across collections, because now you can at least merge them in one go. Let me show you how it works. Here we got our book offer example still. And now let's say I want to fetch all my books with the offer data included. To do that, I can use my books collection, and use the aggregate method. Again, this uses the so-called aggregation framework, and we'll have a look at this later in the course in detail. There you pass an array, because you can define multiple steps on how to aggregate your data. For now, there's only one step I'm interested. A step is simply a document you pass to the array, and that is the lookup step, $lookup. That step is configured by passing a document as a value, and here you need to define 4 things. I simply brought this into a new page to make it easier to read. So 4 things need to be defined here. The first one is the from thing. And the question here is, from which other collection do you want to relate documents? So here we're running aggregate on the books collection. So we want to pull in other documents from the offers collection. So that is the name of the collection where your related documents live in. You then define the local field. So in the collection you're running this on, so the books collection, where can the references to the other collection be found in? And for books, we stored that in the offers field. Offers simply is an array of object IDs. Now we need to tell MongoDB, okay, I know where your keys are stored. which field are you relating to in your target collection? So in the offer collection here, the offers collection. And you define that with the foreign field key. And there we know it's an underscore ID. Please note that all these values are enclosed in double quotation marks. Offers, and here my underscore ID field. So I know that in offers, in books, I have object IDs stored where the matching equivalents can be found in underscore ID in the offers collection. Last but not least, you give this an alias under which this will be merged. And I'll name this creators. The name is up to you here. If you hit enter, let's print this, we get back this result. What we see here is we got our book. Actually, all the books we have in there, only one in our case, with the name, with the offers and the object IDs, but then a new key was added, creators. And that actually holds the offer data which lived in a different collection and which was merged into our result by the aggregate and lookup function. So this is very useful for merging data in one step, and it allows you to get the best of both worlds, having it split up and still fetch it in one go. Now, this still is not an excuse for always using references, because obviously this costs more performance than having an embedded document. So if you can and if your application needs it, go for embedded documents. If you have to use references or if you want to use references, well then this lookup step in the aggregate method can at least help you get the data you need. Now, it was just a first look at aggregate. As I mentioned, we'll have a whole module where we see what else aggregate can do for us. Be aware of lookup for merging your relations though. Okay, so we learned a lot about schemas and relations. Let's practice that a bit. And here's a simple example project which I want you to think about how you would structure the data for it. And then of course we'll also do it together. So we have our user in our application, and that can be a server-side rendered website, a single-page application, a mobile app, anything like that. We got our app server, and in that app server, or to that app server, we send a couple of different requests, because let's say we're building a blog, as the title says, so users are able to create posts, edit posts, delete posts, fetch all posts so that we can display a list of posts on a page, fetch a single post so we can read that post, and also comment posts, so we can write comments. And we can also fetch these comments, of course, to display them. Now, we got our application server with our code being written in Node.js and .NET, PHP. We won't write the code here. This is not a web development course. We won't write any code here. We'll just structure the data for that and see how such a dummy request, how such a write or such an edit could look like. Our code in a real app would, of course, use the Mongo driver. We will use the shell here. And in the end, it'll send the data, the request, to the server. So our goal here now in this exercise is to simply define a schema, identify the core entities we have in this world, and how the schemas for these entities could look like, how they are related, and how we would model these relations. And then we'll just play around with some queries so that we can see how our application, how the MongoDB driver would interact with our database. So let's have a look. I'm drawing on my iPad here, and as I mentioned, definitely go ahead, do this on your own. Definitely lay out the core data entities you have and how they might look like in your application and how they could be related. There is no single correct solution here, but I'll go, well, with my approach now. So which kinds of data do we have? Well, in our single block, we have at least a user. We have our posts, so we have a single post, and we'll also have a comment because users can comment posts. So these three data entities here should exist. Now, which kind of data does a user consist of, does a post consist of, and does a comment consist of? They will all have that underscore ID, of course, because that is a hard requirement by MongoDB. Then a user might have a name, might have an age, and might have an email, let's say. A post might have a title, might have a text, and whatever else you want, maybe some tags. And obviously, you might come up with totally different fields here. Now, that is how that could look like. A comment will simply have some text, let's say. How are these entities now related? Well, a user can create a post and, of course, edit and delete it then. A user can also comment a post. So a post can have multiple comments where each comment also knows which user created the comment. These are the general relations we have in there. How could we now model that? Well, we got the whole variety of things. We could embed everything. We could go with one collection only. Let's say the post collection is our only collection we want to go with. And in posts, we then have our user, and that is an embedded document which holds the user data as defined here. And in post, we also have our comments, which is basically an array of nested documents. Sorry for my super ugly drawings, but here we would have that comment data in an array. So this would be the only collection we then have. Posts with embedded users in a single post, or the embedded user, and embedded comments. Now, is that a good approach? Well, parts of it are good. I'm fine with embedding my comments here, because the comments are a one-to-many relationship. A post can have many comments, but a comment always belongs to one post. A post also typically doesn't have millions of comments, so we probably don't hit any MongoDB limit, and we often want to fetch a post along with its comments. So nesting the comments here might be fine. You can always go for a different solution, but I'm fine with nesting comments. What about nesting the user? I don't think that is a good idea. Nesting the user doesn't sound too good to me, because if we nest a user here, then we have a problem, because one user can create many posts. So if the user data then changes, let's say if the email changes, we have to edit that user in all the posts. So we got a lot of duplicate data. And whilst that might not change on a daily basis, it certainly is not like a user never changes any data. So it's not such a low frequency that I would be fine with doing all these duplicate changes when they occur. So I'm a fan of actually creating two collections here. The users collection and the posts collection. We'll not have a comment collection. We'll have comment data in this structure in our array here, but we'll not have a separate collection for comments. Instead, we'll have posts and users, and we'll use these collections with some embedded documents for comments, and also for tags, by the way. Tags also in the end is just an array of strings, so we could also say that this is a relation to different tags. So we have two major collections, posts and users. This is my solution, and I hope my explanations here are clear why I would not use a comments collection, even though you can of course do that, and why I would not use nested users. Now, let's go back to the shell and play around a bit with that and see how we could implement that there. So let's go from drawing to database action. I'll go to my block database, and there I said I want to use two collections. Let's start with the users collection. There, let's say I insert many users. We got multiple offers on our block. Now, insertMany takes an array of documents where each document is one element we insert into this collection. A user here can have a name, Max Schwarzmuller, can have an age, 29, and let's say an email address, max@test.com, which is not my real address. I also have a second offer, Manuel Lawrence, age 30, and also email here, manu@test.com. If I hit enter, these two elements get inserted, and obviously we can now pretty print them. This is the data in our users collection. Now let's go to our posts collection. So posts, There, I want to insert one post, let's say. Obviously, we could insert multiple posts. Now, one post can have a title, my first post. A post can also have some text, which holds the actual content. This is my first post. I hope you'll like it. And this could be very long text. As you learned, the text type is able to store very long text. We might also have some tags here, and that could be an array of strings, like new, tag, whatever your tags are. And now we come to the relations. Now, my relation here is that this post is written by a user. Let's name it creator. And this could be a list if you have multiple offers in your application. Let's say in this application, and that is totally up to you, of course, we only have one offer per post. So my creator or offer, however you want to name it, here should be one of my users. And let's say this was written by manual. So I'll copy that object ID. We could match it by any key, of course, but we should ensure it's unique, and the object ID is ensured to be unique. And I'll therefore set this as a value for creator. Now we also might have comments here. And let's say we got a couple of comments there. And each comment then is another document. So here I got a list of documents where I have some text. I like this post. And as another key here, I don't just have the text, but also the author of this comment. And that again would be the ID of a user. So let's grab Max here maybe. Grab that object ID here and insert this as the author. So here again, I'm also using not an embedded user for the same reason why I'm not using it on a post. I'm not using it on a comment either. Instead here I also use a reference. Let's hit enter. This worked. And let's have a look at our post. This is how it looks like. And this post has the fields I sketched out. And most importantly, we have a reference relation to the person who created the post. But we got an embedded document, or even multiple documents, for the comments, where each comment in turn also has a reference relation to the author. This is how our blog could look like in code, so in the database, and I also explained why I would structure it like this. And this example, together with the previous lectures, hopefully gets you into the right mental model on how to think about this, and hopefully helps you with your next projects to structure your data and your relations in a way that makes sense for your application, to your size of data, the amounts of data, the frequency with which you change it, and your overall structure or relation that is imposed onto you by your application. We talked a lot about schemas, structures, relations. Now let's talk about schema validation. And with that, I'll come back to the data type thing and also to our schema structure in general. You learned that MongoDB is very flexible. You can have totally different schemas or documents in one and the same collection. And that flexibility is a huge plus. But sometimes you want to lock down your flexibility, you want to get rid of it. Sometimes you need a strict schema because you know your application is going to fetch posts and it is going to access the title on each post, and it does expect that each title is a string. And for cases like this, schema validation can help you. Now, what is schema validation? Let's say we have an insert operation going on our collection, on our posts collection maybe. And the same would be true for update or insertMany operations, by the way. So we're trying to add or edit some data in a collection. If we add a validation schema, and I will show you how you add one in the next lecture. If we added one, then the schema will validate, or the MongoDB will validate the incoming data based on the schema we defined. And it either accepts it and then allows the write to the database, or it rejects the incoming data. Hence, your database is not touched and is not changed, and the user gets an error. To be precise, you can define schema validation in the way I'll show it in the next lecture, and you can also define which kinds of operations you want to validate and what you want to do if validation fails. We have 2 settings you can add. You can define which documents should get validated and what happens if it fails. You can either set the validation level to strict, which means all inserts and updates are checked, or to moderate, which means all inserts are checked, but updates are only checked for documents which were valid before. So if you had some invalid data in there because it existed before you set up a schema, then you could still change these documents even if they don't fit your schema. For validation action, you can decide whether you want to throw an error and not go on with the insert or update, so it will not change your database data, or if you only want to log a warning and proceed. So then you would still write the data, you would still change the data, but log a warning that it did not fulfill your criteria. And what you want to choose here really depends on your application. If you're okay with incorrect data ending up in your database, you just want to be aware of it, or if you totally need to block it. Let's have a look at that in code next. So we want to add validation, and actually I want to use my posts example here. Now, how can you add validation in MongoDB? A very easy way of adding it is when you add a collection for the first time. So when you create a collection. And you learned that the collection is created automatically when you start inserting data into it. So here, let's say I want to drop my posts collection. So now if I try to find one post, that will not work. Now let's create the collection differently. Not implicitly once we add something, but explicitly. For that, we got the create collection command. We didn't use it thus far because often that lazy creation, where it only gets created if it's needed, is okay. But if you want to configure your collection a special way, well, then you can use that create collection command. There, you first of all, as a first argument to the create collection method, define the name of the collection. In our case, that would be posts. So previously, you just accessed it and started working with it. Now you create it, and therefore you have to define the name here. The second argument is a document where you can configure that collection. And one important piece of configuration here is the validator. The validator key takes another sub-document where you can now define a schema against which incoming data with inserts or updates has to validate. You do this by adding a JSON schema key, $JSON schema key here, JSON schema, and then again another nested document. And this now holds the schema. So here we're just saying, hey, our validator is the JSON schema. Historically, there were other validators, but it is strongly recommended to go with JSON schema now. And then you define the schema here in this nested document. Now there, you can define a schema for every document which is added to the collection. For example, we can set the BSON type here to object. So everything that gets added to the collection should be a valid document or object. More interestingly, we can set a required key here, which is an array. And here we can define names of fields in the document, which will be part of that post collection, that are absolutely required. And if we try to add data that does not have these fields, we'll get an error or warning, depending on our settings. So here, we simply pass the names of the fields. Like in our case, for the post here, we could say a title is required and a text is required. Maybe tags are not required. The creator is required though, so creator, and the comments, let's say, are also required. So now these 4 fields are required on every document that gets added to the posts collection. Now we can even dive a bit deeper and start working on our properties. Now, since this gets a bit hard to read, let me actually take that entire command here and move into a text editor where this is easier to read. I created a validation.js file. It should be a JS file if you're using a tool like Visual Studio Code to get nice syntax completion. The name does not matter at all. And I'll paste in my command and use the auto formatting capabilities of that IDE, which you can find by inspecting the key bindings there under Preferences, Keyboard Shortcuts, and then Format Documents. What you want to look for, this shortcut here, I use that to format this in a nicer way. So this is what we wrote thus far, a validator with a schema for the overall document. And now we can add a properties key, which is another nested document, where we can define for every property of every document that gets added to the posts collection, how it should look like. For example, the title field. Keep in mind, title is required here. By the way, that is incorrect. Every element here should be a separate string, not one big string. So like this, it should look like this, 4 strings. So title is required, and now we can define it in even more detail. We can not just say it's required, which is already done here. We can say the BSON type here should be string. And that comes back to the data types you learned before, and also consult that lecture I added earlier where you see a list of all the data types, because you'll need to type as it's noted in the MongoDB documentation here. So only strings are accepted as titles. You can also add a description here, so must be a string and is required could be added here. And we can do that for all our properties now. So for the text too, what would that be? Well, it would also be a string. And we can also pass a description here, which is just the same description as up there. The creator, on the other hand, that would be a BSON type of object ID. Here the MongoDB equivalent is object ID written like this as a string. So here we can also add this must be an object ID and is required. We also have our comments here, and the comment has a BSON type of array, because in our post we got multiple comments. So we can also add a description, must be an array. And of course, our comment, since we have multiple items in there, you can add an items key here, which describes how the items should look like in that array. There you can set the BSON type to object, because every item will have to be a document. It's not allowed to be a string, it will have to be a document. Well, and in our comments, as we added them before, we had a text and an author. So we'll again add a properties key here, and now basically say, well, every item in the array has a text field, which in turn is of type or BSON type text, where we can have a description must be a string and is required. And for it to be required on the items in the array, we should add the required key and say that text is required and that author is required. And then down there in the properties setup, we can also add, or we should add the author and say, well, the author, here the BSON type is object ID, and we also have a description must be an object ID and is required. Now you can find this document attached to this video in case this was too fast. In the end, I'm defining a simple schema on how you can validate incoming data for our posts collection. And I'm doing this when we create the collection. So we can copy that entire command now and move back to the shell. And of course, at the end of this module, you'll find a link to the detailed official docs with all validation options. So I can enter this command here, and I got an error here. Object ID is not understood, and indeed that is correct. It should be object ID with a capital I. In the file which you download, this will already be fixed. I fix it here manually, and I also had a problem here. The BSON type of text is not text, but string. I did that correctly up here. Simply reuse text here. That should be string. Again, in the document you download, this will be fixed. With that added, let's now add it here. We get OK. And now, if I look at the posts, there's nothing in there, of course, still. But now let's insert a document. And for that, I'll repeat my previous insertion with title, my first post, text, and so on. If I hit enter, this succeeds. So now if I find one post, this is the post I added. Now let me try inserting something where my author is not an object ID, let's say, but a random number, because maybe I have authors stored which I want to match by that number which fits another field. Now I get an error. I get an error in the end which says document failed validation. And that is a pretty clear error, right? We failed validation. And if I now look into my posts with find to see all posts in there, we actually see indeed the post was not added there because we just get an error telling us that we failed. So validation works and it didn't add our incorrect post. Now let's play around with the additional settings we can set, which I already showed on my slides. For these settings to activate, I would need to create my collection again and set up the validation again. The problem is, I of course already have my validation turned on here. So what can I do? As a database administrator, and this is how you would add such settings like validation, you can use db run command in the shell here. To run, well, an administrative command, you pass a document with information about the command. And here, the command is that we set a call mod, that stands for collection modifier. And we define the collection which we do want to modify, posts in my case. And then we can again pass a validator. So now we can pass exactly what we passed to create collection. So we pass validator and then the entire schema below that. So make sure to grab that portion of the file, go back to the shell. Now important, remove the closing parentheses, add a comma, and paste in what you just copied. And then add another closing curly brace and closing parentheses. But we're not done here. If I hit enter like this, of course, it works, but now I just set the same validation again. What I instead want to do is, I want to change my validation settings. So I'll add a new file, which you'll also find attached to this video then in the finished form, where I copy my create collection code into. Now here we will have run command as you just saw. Then we pass our opening curly brace, call mod, then holds the name of the collection we want to edit. And then I need to remove that curly brace here, can reformat. This is now the command. And now here I got my validator, but now I also want to switch an additional setting. Now let's search for the closing parentheses of validator because we need to set our validator configuration as a sibling to that validator key here. So for my IDE, it conveniently highlights this. After this, we can add validation level to control whether all inserts and updates are checked or only updates to elements which were valid before. But I want to set a validation action here. The default is error, which blocks the action and throws an error. I'll set it to warn. Let's copy that entire code. Again, you find it attached to this lecture. And execute it here. Should be successful. And now if I again try to insert one post with my offer being, well, or having a value of 12, which is not an object ID, this actually succeeds. And the only thing it did is it will have written a warning into our log file. And the log file is stored on our system. We'll have a look at this in a later lecture when we talk about configuring our server and so on. So this is the difference. Now, what you want to use here depends on your application and your requirements there. It's good to know that you can configure these things, and putting validation in place can make a lot of sense depending on how your application works, how important it is for you to have one consistent scheme of data. And you also now saw that you can define that validation schema when you create the collection or also thereafter with the help of run command. That's it for this module. And I want to conclude it with a wrap-up. And the first important thing in this wrap-up is that I reiterate how you should think about data modeling and structuring. Consider the format in which you'll fetch your data. How does your application or your data scientists, how do they need the data? You want to store your data in a way that it's easy to fetch, especially if you're building an app or if you're having a use case where you fetch a lot. Because that's the next important question. How often do you fetch data and how often do you change it? Do you need to optimize for writes or for reads? Often it's for reads, but it could be different for you. If you write your data a lot, you should definitely avoid duplicates Make sure you got no duplicates. If you read a lot, maybe some duplicates are okay if these duplicates don't change that often. Basically what I covered when walking through the different relation setup options. Also keep in mind, how much data will you save and how big is it? Do you store all citizens of New York City? Maybe embedding the data is not your best choice then. How is your data related in general? One-to-one, one-to-many, many-to-many? This often gives an indication for whether you want to go with embedded documents or references. And in general, will duplicates hurt you? Do you update your data a lot, in which you have to update a lot of duplicates? Do you maybe have snapshot data like with orders and products, where you don't care about updates to the most recent data, to your products data? And finally, will you hit any data or storage limits? Like, do you need to embed 100 levels deep, which is the limit MongoDB imposes? It's not very likely, but that is something you should at least be aware of and which you should keep in mind. With that, here's the general summary. In this module, we had a detailed look at how you model schemas. That this can make sense even though MongoDB does not enforce a schema onto you, because your application typically needs data in a specific structure. Important factors are the factors I just mentioned: frequency, relations, size, and so on. You also learned about data types there, by the way. Text, integers, long integers, decimals, and I will also come back to the numbers later in this course. We also had a detailed look at relations in this module. You basically have two options: embedding or references. And you want to use embedded documents if you got a one-to-one or one-to-many relationship, and if it makes sense for your app and the way you interact with your data, with all the points I highlighted throughout this module and a few seconds ago. References make sense for many-to-many relationships, or if you want to fetch data separated, or if you got very large amounts of nested data, like New York City with all its citizens. Exceptions are always possible, and there is no hard rule, like many-to-many should always use references, as you saw with the example of products and orders. But keeping an eye on your app requirements and how your app works and interacts with your data gives you a good clue and indication of how you want to structure your data typically. Last but not least in this module, we had a look at schema validation, which allows you to enforce a certain set of rules on incoming data, so that no invalid data ends up in your database. You learned how you can define such rules and how that works with JSON schema, and you also learned that you can configure how your rules are applied, if actions get blocked or if they just get a warning logged to the log files. This is it for this module. And with that, you hopefully got a good understanding of how you have to think about structuring data and how you can then implement your structure, relate your documents, and validate incoming data. Welcome to this module. In the previous modules, we already worked a bit with the MongoD instance, so with this Mongo server we started, and with the Mongo shell started with this Mongo command. In the first course module, you learned how you install these things and how you generally use them. In this module, I want to dive a little bit deeper and show you some things you can configure, and most importantly, where you can find more options and how to think about these options. So, to be precise, you will learn that you can start your MongoDB server in two different ways, as a process and as a service, and I will show you how that works in this module, of course. You'll also learn a bit about configuring your MongoDB server, or the way it runs, to be precise, and you will also learn how to fix issues or find some help, find out what you can actually configure, what you can do. With that, let's get started. Now, a good way to get started, if you want to learn more about any of the features MongoDB provides, is to dive into the official docs. Even though that sounds a bit cheap, it indeed is a good way to learn about all the available options and things you can configure. In the official docs, you will find the detailed docs for the MongoDB server, which is what we're using right now. And there, most important for you are either the frequently asked questions at the bottom. You find, of course, docs for all the features, but we'll cover them in this course. But you should also check out the installation docs to make sure you got everything set up correctly, We did this in the first course module though, so that should be the case. So then the Mongo shell docs are also interesting because here you can learn more about how to use that Mongo shell and how to configure that. Now, the documentation is one good place, but obviously there also are some important or interesting things that I want to show you right away. So let's do that. And for that, let me open a new terminal. Here, I did open a brand new terminal, or on Windows, you would open the command prompt, and I currently have no MongoDB server up and running. So no MongoDB process is running in any terminal window. Now, you learned that on Mac, you can start a new server with sudo mongod. On Windows, it was just mongod. And you can start a shell and connect to a running server with the mongo command, assuming that you did follow these setup steps in the first course module where we also configured the path variables. So this is how you can start these processes. Now, the mongod command actually can be configured with a couple of flags. We already saw the --port flag, for example, to change the default port. Now, there are more flags, and you can see all flags or options with the help command, --help. This is quite a long list because the server can be configured in various ways, and we'll dive into some of the features like authentication in a separate module of this course. But you can definitely go through this list to get a feeling for what you can generally configure. And now there are a couple of options which I will walk through together with you in the next lectures. So there's a bunch of stuff we can configure. And what exactly can we configure there, or what could be interesting to us? Well, things like quiet allow you to change the way things get logged or output by the server. And if you feel like it's talking too much to you, you can control that with quiet. And obviously check out the official docs for more detailed explanations of all the options. Interesting to us is the logpath and also another setting, the dbpath, which you can find a bit further down towards the end of this list. These two paths allow you to configure where your data gets stored, in the case of dbpath, because MongoDB of course does write your data to real files on your system, so the dbpath is where these files will live. And the log path is essentially where the logs will be written to. And the logs are interesting because in the logs you can then see, for example, warnings of JSON schema validation warnings if you set the validation action to warning, what we did in a previous module. So log path and dbpath can be set. Now, how do we set this? I'm in my MongoDB folder, and there I got that bin folder. Now in this MongoDB folder, I'll create a new path and I'll name it db. And I'll create another new folder and I'll name it logs. You can name these folders however you want. Now these are two new folders and I want to use the db folder for my db files and the logs folder for my logs. The default setting for db is that it will use my root folder and there the data db folder. That is the default setting of MongoDB. And if you start a MongoD instance without any additional setting, it will use that folder. But you can tell it to use another folder. And the same is true for the logs. You can tell it to not output its log messages in the window where you started the MongoD instance, but instead into a separate file. And I want to do these two things. Now, on Mac, I can get the path to my DB folder by clicking on it with a right click and then get info and then copying that path. On Windows in the Explorer, you can of course just copy that URL by clicking into it once so that it becomes a full URL and then copying that. And now if I want to start my MongoDB server with that path being used, I can run sudo mongod, or on Windows it would just be mongod, --dbpath like this, then a blank, and then the path. And now important, I just copied the path to my MongoDB folder. Of course, I should point to the /db folder. On Windows, it's \db. Hit enter, and enter your password if you have to, and this should bring up your MongoD server as it worked in the past, but now you should see that in the DB folder, it created a bunch of files because now it's storing the data here. And therefore, this is now using a totally different database storage than it previously did. It's totally detached from our old database path. We have a brand new database setup now because we're using a different file storage for the database files. Now, logging would also be interesting. So let me quickly clear the window to make it easier to read. Let me quickly rerun sudo mongod here with dbpath, but I'll set an additional flag separated with a blank and then -- logpath. And now I want to use almost the same path, this one. However, it should be /logs and that's important to know, the logs, the log path, needs the path to a log file. So here you could add log.log, for example. If you hit enter, this now starts the server, but you see way less output here, because now if you look into logs, you should have a log.log file. Now all the output gets written into that file. And that of course can be useful, because now this file will get saved and you can always come back to it, check your logs from yesterday, go through it, see any warnings or errors you might have in there, like this warning that access control is not enabled, which is the default right now. We got no authentication. We'll add it later. So this can be useful for, well, persistent error searching, or for simply persistent auditing of your server. So this now is how you can set a custom path for your logs and how you can set a custom path for your database. What else can we do? Well, let's run mongod -help again. We obviously got many settings here. The settings at the bottom, for example, are related to writeTiger, which is our storage engine. And there we can basically use the default settings. You can change some configuration there if you know what you're doing. But in the scope of this course, we'll not dive into configuring our storage engine, but simply go with its default settings. You also got useful commands like repair, which is a great idea to run if you have any issues connecting and see warnings or errors related to database files being corrupted or anything like that. Directory per DB would be a setting you can add to not have a DB folder with your collection files stored all in the root folder, but instead they would be grouped in subfolders with one subfolder per database in your database environment, so to say. So if you have 4 databases, you would have 4 subfolders, and every subfolder would contain its collection and index files. We'll dive into indexes later in the course, by the way. You can also switch the storage engine. The default is writeTiger, and you should really use that. Theoretically, MongoDB supports multiple storage engines, but writeTiger is the default one, is a high-performant one, is a really good storage engine. So unless you really know what you're doing and you got a strong reason to change it, you should not change the storage engine. SSL configuration is something I'll come back to in the security and authentication module, so we can ignore this for now. The same is the case for sharding and replica sets. I'll touch on these options later in the course. And therefore, we're pretty much done. One setting is worth talking about though, and that's the fork setting, or the fork option. What does this do? Let's explore fork. And let me already say that fork only runs on Mac and Linux. And I'll show a solution for Windows too, of course. So let's simply see what fork does. If I run my MongoDB instance with fork, like this, and I can still pass dbpath and all the other options if I want to. But if I run it like this, what happens is that I first of all get an error, because one thing I need to set here is the log path, and you'll see why in a second. So I'll set my log path, copy in the path to logs, and then log.log. And now what happens is, this starts my MongoDB server as a child process. And you can see it's now not blocking this window. I can type other commands here again if I want to. So I can type other commands here, and the server is still running, but now as a background process, you could say, instead of a foreground process which blocks this window. It runs as a service, put in other words, a service in the background. And therefore I can run Mongo to connect to it, because the server is up and running. I can connect to it and I can work with it just as I did before. That is also the reason why I had to pass my log path. Since it runs in the background, it can't log errors or warnings to that front screen. It can't log it here into my terminal. Instead, it will write all the logs for the background server into my log file here. This is simply how it works and how it runs, and how I can run this as a background process if I want to. Now on Windows, the fork command is not available. But on Windows, you can still start it as a service if you checked that install as a service option during the installation, which we did in this course. So with that checked, you can start the MongoDB service. And you first of all need to make sure that you quit all existing processes in all your command prompts. You can start it by right-clicking on the command prompt and running it as administrator. And then you can type net start MongoDB. And this will start up the MongoDB server as a background service. Now the question, of course, is how can you quit such a running service? And on Mac, you can easily do that by connecting to that server with the Mongo shell and then switching to the admin database. And in there, you can run db shutdown server, so this method. And this will shut down the server to which you are connected. The exact same approach will work on Windows. So this is one way of doing that. On Windows, you can also easily stop it by, again, opening a command prompt as administrator and running net stop MongoDB in there, written like this. So this will also stop the service. And this is how you can use such a background service instead of a foreground service. What you use is up to you ultimately, up to your preference. You got exactly the same service in both ways. I just wanted to show the alternatives here. Now that we talked about the different options you can set and you can use to run your MongoDB server, it's also worth mentioning that you can save your settings in a configuration file. If you Google for MongoDB config file, you should find this article from the official docs. And there you can learn that you can create a MongoDB config file, and you might also get one by default after your installation, but I, for example, did not get one on Mac. So you might get one, otherwise you can simply create one, and you can create it anywhere you want. And I will do that too. I will create a config file here in my bin folder, let's say. I actually did already create one. I named it mongodb.cfg. So you can simply create this with a text editor. And here I'll edit it with Visual Studio Code because that is a nice editor for this and makes, reading that file really easy. Now you see, I already have a file where I added some settings. And this is how you do add settings. And you find detailed instructions in that article I just pointed you at. There you also find one example config file. And if you Google for MongoDB example config file, you also find more examples by other users. Now this is a more comprehensive file. I got a very simple file here. In the end, I here only set the path to my database, so where all the database files should be stored, and to my log files. And I also explicitly need to tell MongoDB that this path points at a log file. And that is my MongoDB config file. Now the question just is, how do I use that file when starting a new MongoDB instance? And it's not the case that MongoD would pick up this file automatically, because how would it know that it should, that this file exists, and where it could find this file? Instead, when starting MongoDB, you can use the --config option, or a shortcut for that, -f, and then pass a path to the config file. So in my case, that's in my MongoDB folder /bin/mongodcfg. And you could also name this conf, that doesn't really matter. With that, you can hit enter. And it should now still start your MongoDB server with the settings set up in the configuration file. And this is of course a very useful feature too, because this allows you to basically save a snapshot of your settings, a reusable blueprint of your settings in a separate file, which you can then always, use for starting up your server. And you can find all the information about all the possible options and what they do in this article I pointed you at. So if you want to dive deeper into this, definitely check out this article. With that, and with the settings you saw in the other lectures, you should have a solid tool set of working with the MongoDB server and starting it in the way you want it to start. So over the last lectures, we talked a lot about the MongoDB server and its options. In this lecture, I also want to touch on the Mongo shell. Which options do we have on the Mongo shell? Well, just as you could type MongoD --help, you can type Mongo --help. So now the help options for the Mongo shell. And there, you see, it has way less options because it's just a connecting client in the end, not the server. You can, for example, run it without connecting to a database because the shell is based on JavaScript. So if you just want to execute some JavaScript code, you could do that. You can also run it in quiet mode to output less information. You can define a port and a host for the server to which it should try to connect. By default, it takes localhost 27017. But if you run your MongoDB server on a different host, and we'll do this by the end of the course, I will show you how to create a MongoDB setup in the cloud or on a real server, not on our machine. So if you want to connect to something like this, then you can do this with port and host so that you don't try to connect to the local host. You can set up some SSL settings, which I don't need here. And later, once we add authentication, we also can add our authentication information. And we'll see that later in the course too. So right now, there isn't really an option I would need to execute. But there is also something interesting inside of the shell. So after you started it and connected. In there, you can type help like this. And help will output a short list of some important help information, some important commands you can execute. And you can even dive into detailed help, like for example, what can I do as an admin by typing help admin. And now you see a couple of commands that might be useful when it comes to administrating the database. Now back to just help. You see here are the show DBs and the show collections commands we used before. You also see, how, for example, how you find all objects in a collection. Also not that bad to know. And you can also output help for a given database or a collection in a database. Like here, if I have a look at my databases, I got no database set up here, or no database besides the default databases. Now, if I use my test database and I type db help, I see commands that I can run here on the database. And you see there are a lot of commands you never saw before, a lot of commands you don't really need, but there also are commands like create collection, which we already did use in this course. You see there also are commands for dropping the database, for example, or for getting all kinds of information. Now, these are commands you also find in the official docs if you want to learn more about them. And as I said, a lot of them are commands you will probably never need. But still nice to know these commands. dbrun command is another command we saw earlier, for example. Now we can also get help on the collection level. Let's say I would have a test collection in there. I can run help like this and note the parentheses, which we also had to use on db help. So I can also run help on this. And now I see all the commands I can execute directly on the collection. And these are all the insert or find commands, for example. But you also have some other commands, like the stats for this collection if you're interested in this. So these are a lot of nice to know features. You can definitely play around with them and just execute a couple of these commands, if possible, in a database and collection where it doesn't hurt if you mess up things. But you can play around with that. This is how you can find help. And with that, together with your log files and the official docs, and Google, as always, you should of course be able to get the most out of MongoDB and fix potential issues or find that special feature you were looking for. Thus far, we already worked a bit with our data in MongoDB, and we always work with it from inside the shell. That is also where we will stay in this course, since you're a developer and you'll write code, and we do write code in the shell. But from time to time, you might want to peek into your database in a graphical user interface. And MongoDB Compass is such a graphical user interface which you can use. In this module, I'll show you how to use MongoDB Compass, how to use it to insert data, to update and delete data, and of course, how to view it and get a feeling for your data. Of course, you cannot just use it to insert new data. You could also open a database server where you have a couple of databases with data in there already. That would work too. So let's dive into MongoDB Compass then. You can download MongoDB Compass from the Compass page on the MongoDB page. You can find it on Solutions, and there is simply Compass. Now on that page, you can simply click on Try It Now, and there Compass should be selected. Your operating system should be selected, otherwise you can change it here. And you simply download that, and you'll get an installer through which you can walk. And this should be pretty straightforward. Once this installation process finished, and I already installed it for me, you can start up Compass, and you should start on a page that looks something like this, where you can connect to a host. Now it's important that you have a MongoDB server up and running, and I do. I'm also connected to it in the shell, and you see this is actually an empty server, no databases, no data. I cleared everything before this module by simply deleting everything in the DB folder where the data gets stored. You could, of course, also have some data in there, doesn't matter. And I got a MongoDB instance running. And that is the instance to which we'll connect. Now, the default settings actually already do suffice for connecting. We want to connect to localhost and to this port. So if you didn't change anything here, you can just click connect. And you are connected to your local MongoDB server. Now you see the free default databases. Now here, we can actually create a new database. For example, we could add some contact data with a contacts collection and click Create Database. In the contact data, we now have the contacts collection, and as you see, we can even insert a document here. And there we could insert a name, Max, we could insert an age, 29, and we can change the type of that too. We could say that should be simply int32, for example. We can then add another field, and that could be my location. And for location, I'll actually add an object, which is simply a nested and embedded document. And for the embedded document, I will add a special type of object, which I'll explain a bit deeper later in the geospatial module, where I'll set a type field to point. This is a string, point. And then I'll add coordinates. And coordinates will actually be an array. And here the first value will be a double, and that double, let's say, is 56.12. And then the second element also is a double, and that is, let's say, 43.09. Now let's click Insert here, and this was now inserted. Now you also see other tabs besides your documents. These are all things which will make more sense once we progress through the course. For example, the aggregation framework module will show you how you can aggregate data in the shell, but thereafter, this page will make more sense to you because what you'll learn in the shell later in that module is something you can also replicate in the user interface by then. Explain plan and indexes will make more sense after the indexes module, where you learn what indexes are and why we use them. And here you can explore which indexes are attached to your collection, which kind of index it is. You can also create a new index, and you can understand how your queries are executed. Speaking of queries, you can execute queries here too. Right now, I'm finding all documents, as you can see. Now you can also, on this page, of course, filter for different things. You can write a query, as you'll learn in this course, and as you already saw it a bit. You could, for example, search for age being able to 29. And of course, you would find that same document. If I searched for age 30, though, I'll not find anything. So you can play around with it and explore your data here a bit to get a feeling for what's inside. And of course, you can not just insert data and view data, you can also edit and change it. For example, here I could update Max to be 30 years old. Simply click update here and you're good to go. And if you want to get rid of a user suddenly, you can of course also delete this user and click delete. Now I'll not do that here, but it would be as easy as that. Now that location thing here, that object, this is just showing you that you can add a nested object as well and an array. And this is actually a special type of object, which you'll also learn more about in the geospatial module. So this is Compass, and this is a super short module, obviously. Compass is a nice graphical user interface, which you simply should be aware of. And even though I will not use it for the rest of this course, because this being a developer's course, I'll focus on the code, you can always come back and log into your database server with Compass to explore your data, to easily manipulate it, to try out some queries, and later in the indexes module, also explore indexes and explain tab, and in the aggregations module, play around with this graphical user interface. This is MongoDB Compass. Now there's one other thing to mention, and that is that this is the community edition. If you are using MongoDB Enterprise, MongoDB Compass will have one cool feature, and that is the schema tab, which we don't have here. This allows you to explore the schema of your data in greater detail. So you can see how many documents do have a string for name or a string for age, maybe if you have mixed data. For location data like this one, you would also see a map and you could explore your entries on that map for multiple documents. So with the enterprise version, you get a bit more features, but for basic exploration and editing, the community edition, which comes for free, should suffice. Now that we covered the core basics or fundamentals of MongoDB and what the data you store in looks like and how you work with that data, it's time to dive a bit deeper into these CRUD operations. I already gave you an overview and you saw how you can generally insert, read, update and delete documents, but now it's time for some additional information, starting with the C in CRUD, the create part. So what's inside this module? Now, I'll not bore you by just showing you the two insert methods again. I will show them to you, but I'll also explain a bit more what they do and how you can configure them. So we'll have a look at these document creation methods, and since this is also kind of related to creating documents, we'll also have a look at how you can import an existing set of data into a database, because that also is a common operation, that you don't just have an application that might be inserting new documents, but that you already have a set of data, maybe exported from a different database, doesn't matter where it comes from, and you want to get that into MongoDB. So we'll show that in this module too. So how can we create documents? Well, you already saw that, but we basically have insert_one and insertMany as alternatives. The important thing to recognize here is that insert_one takes a single document with the values you want to insert, and you can but don't have to specify an ID, because if you don't specify one, you'll get one automatically. And insertMany does the same but with an array of documents, so with a list of documents that gets inserted. Now, there also is a third method, insert. It's a bit more flexible because it takes both a single document or an array of documents, but I will not bother diving into that because insert was used in the past. Insert_one and insertMany were introduced on purpose so that you have to be more clear about what you will do. Because with insert, your code, if you're writing an application, could have been a bit harder to understand because it was not instantly obvious if you were to insert one or multiple documents, and it therefore might have also been a bit more error-prone because you could have ended up in a situation where you expected it to insert multiple documents, but you only inserted one. With insert_one and many, due to them being fixed to one syntax, so one document or an array, you'll get an error if you enter something incorrect, and they're also easier to understand if you see them in code. So we will focus on insert_one and insertMany. And then, as I mentioned, also in importing data. For that, we'll have the Mongo import tool. We'll configure it a bit like you see here, and I will explain what these options do and how it works. So with that, let's dive into inserting documents, and let's quickly go over the basics again before I then talk about the a bit more advanced options or extra things you should know. For this, I started my MongoDB server again, and I connected to it again, and I got nothing in there. Now, if you have something in there and you want to get rid of that, you can always use a database and then simply run db drop database to get rid of the database and all the data that is in there. And as you see, you can even run that on databases that don't exist and it will not complain. So then you should be in that same state and have absolutely no data in there except for the default databases which you need. Now, with that, let's insert some persons again. So let's say we have a persons collection. Or let's first of all switch to a database. We could name it contact data. And then there, let's use the persons collection and let's insert one person. Now, you learned this before, but in the end, here you enter one document. A document always is marked by the curly braces that surround it. And then a document is made up of the key value pairs. So you have these fields, like name is the field, the value for this field is max, and then the next field is separated with a comma, like age 30. In this case, this is a number, hence we have no quotation marks around it. And then we might also have some hobbies, which could be an array, sports, and cooking. And if I insert this, we get this auto-generated ID here, which is guaranteed to be unique. and which also has this temporal component. So if you have multiple documents, they are by default ordered after this ID because the ID reflects when they were created. So if I add another document here, let's say manual, and I set the age to 31, and I set the values here to cooking and let's say cars, then I inserted this document too. Okay, so this is insert 1. Now let's insert many. And for this, I'll reach out to the same collection, and there I'll use insertMany like this. And now the important thing here is you don't enter multiple documents separated by a comma because you don't pass them as arguments to this method. InsertMany does indeed have a way where it accepts some data after this comma, so second argument, and I will dive into that second argument in a second. But if you want to insert multiple documents, you just have to pass an array of these documents. So a list of these documents, a comma-separated list. So then we could insert Anna, age 29, and there maybe add some hobbies. And as you learned in the schema module, you don't have to have the same structure on all documents in the same collection. This is totally optional. So it would be totally fine if you inserted Anna without hobbies. But I'll insert Anna with the hobbies of sports and yoga. And as you see, that worked too, even though it was only one person. But of course, the main idea behind insertMany is that you do enter multiple persons or multiple documents, but you don't have to, as you just saw. It's perfectly fine if you use insertMany with one document only. You still need to put it into an array. It does not work otherwise. So if I now enter more persons here real quick, and I'll leave out the hobbies to speed it up for those. So here we also have Maria and we have Chris. Then here you see I insert two documents separated by a comma, also enclosed in square brackets, hence it's an array, and this also worked. And with that, I got all these persons in the database, and these are the insert methods you learned about. Now, as I mentioned, there also would be the insert method. The insert method can still be used, it's just not recommended. Insert works with both a single document, so if we insert Phil here, this does work. And you see the output also is a bit different. We get a different result. Now, this does not mean that Phil didn't get an ID. If we quickly have a look into persons with find and pretty, we see that Phil does have an ID. So this output here just does not tell us the ID, which also is an advantage of insert one and many. They give us a different output, which is a bit more meaningful or helpful because it immediately gives us the ID in case we want to work with it. We don't have to query the database just to get that ID, which, by the way, is a real advantage because if you're building an application where you insert some data into the database, then often you want to get that ID back of that insert operation and immediately use it in your app. Let's say you build a user interface where users also can delete documents or objects they created. Then you need that ID in your UI, in your front-end application, so that if the user clicks the delete button, you already know which ID, so which document with which ID to delete. If you have an insert operation that does not tell you the ID, it basically means that you need to wait for the insert to complete just to then query all documents and find that ID manually so that your front end continues to work. So this is a real thing, this inserted ID. It's not just a nice benefit, it's extremely helpful. So this is also another reason why insert is not that great. But the other thing, of course, is we can use it for both a single person, as you just saw, or for multiple persons by adding an array here. So if I have Sandeep here with an age of 28, and I also have Hans here with the age of 38, then this also works. Now you see it automatically did a bulk write. It gives us a different output here too. It still doesn't tell us the ID, but on the other hand, we get useless results like that it did not remove any elements. Well, I did not expect it to do that on an insert. And therefore, insert one and insert many are definitely more helpful, both from an output perspective, but also from an input, from a readability and error protection perspective. Okay, so in the last lecture, you got a brief overview over the different insert methods we have and how they work. I also briefly want to mention here that there are some other ways of inserting, One important alternative can be seen in the update module, because there we'll have an option to either update a document or insert it if it doesn't exist yet. But this is it from the insert method world for now. Now, the more interesting part is now what you can do with these insert methods. And there you can actually define or specify some additional information. Let's say we have a hobbies collection where we keep track of all the hobbies people could possibly have. And we insert many hobbies here. Now, each hobby is a document with the name of the hobby, like sports. And we can have multiple such names. Cooking, and then here also cars. Obviously, I could hit enter now and it would work. Now, I did mention that we get this auto-generated ID, right? Often you want to use that ID, but it also is the case that you want to use your own ID. Maybe because the data is fetched from some other database where you already had an ID, or maybe because you need a shorter ID. Here, for example, we could say the name of the sport also makes up for a great ID. So we could have _ID sports here, because we know that this will be unique. We will not have sports twice in this collection. So we can absolutely use sports as an ID here. And the same here for cooking. We can, of course, also use cooking. And I just name it all lowercase. You could absolutely use a capital C in there. That would be accepted. So this is not required to be lowercase. But I'll use it like this. And the same for my last document, for the cars. I'll set _ID to cars. Now, important, it has to be _ID. Just ID will not work. It has to be _ID. If I now hit enter, you see these were the inserted IDs. And indeed, when we look into the database, we'll see no other ID, so no object ID. And this is perfectly fine. And this is not bad to do. Absolutely not. Bring your own IDs if you have them. So now I got these 3 entries in there, and I got my own ID. Now let's say I repeat that operation. So I add more hobbies. I add, let's say, yoga here. And then, let's leave the middle one untouched. I also add, let's say, hiking here. Now, the middle one, cooking, is untouched, because let's say the process where we add this, maybe it's user-added data, doesn't guarantee that we check whether this item exists in the database before. So I try to enter data with an ID that already exists in the database. What happens if I now hit enter? Well, if I do this, I get an error. Now let's see what we got. I get an error, a write error at item 1. Arrays start with index 0, so it tells us that the element at index 0, the first element, succeeded, but at index 1, so the second element in the array, it failed. So we failed in that bulk operation, and it gives us some more information. It tells us, again, where it failed, and that it failed because of a duplicate key error collection. It could have also failed due to a different error. Maybe our server went down during our operation. That could have been a thing. Now here it failed due to duplicate key problems. It also tells us the ID, cooking, so it gives us the exact document on which it failed. So this is of course helpful. But you also see here that one element was inserted. And indeed, if I reach out to my hobbies and I find them all and pretty print them, you see sports was added, cooking was added, cars was added. That was my first write. But in the last write, where I got the error, yoga, which was the first document, was added to the collection. So it failed after this element. Now, this is the default behavior of MongoDB. And this is called an ordered insert. An ordered insert simply means that every element you insert is processed standalone, but if one fails, it cancels the entire insert operation, but it does not roll back the elements it already inserted. That's important. But it cancels the operation and does not continue with the next document, which, as we know, would have succeeded. So, this is the default behavior. Often, you want that behavior. Sometimes you don't. And for these cases, you can override the behavior. Now, if I repeat that same operation, it will again fail, but now already on the first document because yoga was inserted in the last step. Now it will of course fail because now it's already in the database. So how can I change this behavior? Well, we can pass a second argument separated with a comma to insertMany. That argument is a document, and this is now not a document that will get inserted. Instead, it is a document that configures this operation. And here we can set some options, and the option that helps us in this case here is the ordered option. The ordered option allows us to specify whether MongoDB should perform an ordered insert, which is the default. You can set this to true, but that is redundant because that is the default setting. So now it will behave in exactly the way we saw it before. But we can also set this to false, and now it will not be an ordered insert. Now if I now hit enter, I still get that error, but you see I now get a list of all the write errors, yoga, and cooking, which already tells us that it continued after failing on yoga. And we also see that one element was inserted. And that has to be hiking, since we tried to insert 3 and 2 of them failed. And indeed, if I now look into my database with find pretty, we see hiking in there. So by setting ordered to false here, we change the default behavior. And it is up to you what you require or what you want in your application. Be aware that it will never roll back the entire operation if something failed. That is something I'll cover towards the end of the course in the transactions module, because we'll need some additional knowledge to work with such transactions. A rollback will not happen here, but you can control whether it continues with the other documents and tries to insert everything which is fine, or if it does not. And being able to set this is very useful, because you might have cases where you can't really control whether the data you're trying to insert already is in the database. And then an unordered insert with ordered false can be your solution, because you don't care about any documents that fail. They already are in the database. That's fine for you. And you can add everything which is not in there yet. So this is how you can use ordered and unordered inserts to fine-tune the way documents get inserted to your needs. We learned about ordered and unordered inserts. Now there is a second option we can specify on insert1 and insertMany, and that is the writeConcern option. Now let me explain what the writeConcern is all about. We have a client and we have our MongoDB server. The client would be the shell or your application using a MongoDB driver. The MongoDB server is what you start with the MongoD executable. Now let's say you want to insert one document in there, and it would also be true for insertMany and for update and so on. So for all the write operations, because it's the writeConcern option we're talking about. So we're trying to insert one document. Now, as you learned in the first module of this course, on the MongoDB server, we have a so-called storage engine. This is the engine being responsible for really writing our data onto the disk and also for managing it in memory. So your write might first end up in memory here. And there it manages the data which it needs to access with high frequency, because that is faster than working with the disk. Of course, your write is also scheduled to then end up on the disk. That is not the thing. So it will also eventually store your data on the disk. Now you can configure a so-called writeConcern on all the write operations like insert1 with an additional argument, the writeConcern argument, which is in turn a document where you can set settings like that. Now what does this mean? The W simply means write, and the number here indicates to how many instances, in case you're using multiple instances on one server. That is also something we'll cover towards the end of the course, so let's ignore it for now. So on how many instances you want this write to be acknowledged. With W1, which is the default, you're basically saying, hey, my MongoDB server should have accepted that write. So the storage engine is aware of it and will eventually write it to the disk. The J stands for the journal. The journal is an additional file which the storage engine manages, which is like a to-do file. The journal can be kept to then, for example, save operations that the storage engine needs to do that have not been completed yet, like the write. Now, it is aware of the write and that it needs to store that data on disk just by the write being acknowledged and being there in memory. It doesn't need to keep a journal for that. The idea of that journal file, which is a real file on the disk, is just that it is aware of this, and if the server should go down for some reason, or anything else happens, that file is still there. And if you restart the server, or if it recovers basically, it can look into that file and see what it needs to do. And that is of course a nice backup because the memory might have been wiped by then. So your write could be lost if it's not written to the journal, if it hasn't been written to the real data files yet. That is the idea of the journal. It's like a backup to-do list. Now the question is, why do we write it in the journal and not directly into the database files? Because writing into the database files simply is more performance heavy. The journal is like a single line which describes the write operation. Writing into the database files is of course a more complex task because there you need to find the right position to insert it. If you have indexes, something we'll cover later in this course, you also need to update these. So it simply takes longer. Adding a to-do in the journal is faster. Still, that also takes longer than not using the journal. And the default is that the journal is not getting used with J undefined. And that does simply mean that the storage engine will eventually handle this write and also write it to the journal, but you don't have that information yet. You don't know if it has been stored in the journal yet, if the write succeeded yet, if the write has been done on the disk. You don't know any of that. You just know that the server is aware of your write. So if the server should go down in that exact moment, it might indeed not have done the write because it hasn't been added to the journal yet, it hasn't been saved to the database files yet. Now you can set a different option and set J to true. What you're now saying is, hey, please only report a success for this write to me after it has been both acknowledged and been saved to the journal. So now I have a greater security that this will happen and succeed even if the server should face issues right now. Now there is also a third option, not directly related to the journal, but it's the W timeout option. Now this simply means which time frame do you give your server to report a success for this write before you cancel it. So if you have some issues with the network connection or anything like that, you might simply time out here. Obviously setting this too low might time out even though it would have perfectly succeeded normally. And therefore you should know what you do when you set this timeout value. Because if you set it to a very low number, you might fail a lot, even though there is no actual problem, just some small latency. So this is the writeConcern and how you can control this. Obviously, enabling the journal confirmation means that your writes will take longer because you don't just tell the server about them, but you also need to wait for the server to store that write operation in the journal, but you get higher security that the write also succeeded. Again, this is a decision you have to make depending on your application needs, what you need. Now let's see this in practice in the next lecture. So let's play around with the writeConcern. And for that, I'll go back to my persons. There we already have a couple of persons in the database, of course, and all these writes succeeded. And they normally will, of course. Now let's insert a new person with insert1, and the writeConcern can also be set on all other write operations like insertMany. I will use insert1 here with a name of Chrissy, age 41. And now I specify a second argument again. Where we previously set ordered, I will now set my writeConcern. I do this by setting the writeConcern named like this. The casing is important. So the writeConcern key, I set it to a value, which again is a document, which has the shape you saw on the slides. W1 is the default. It simply means I need to be sure that the server acknowledged this. You can set this to 0. If you do this, you get back acknowledged false, but if I find everything, you see that Chrissy was inserted. So you get back a different result, also without an object ID, because it can't give you one. The server hasn't really registered this write yet. You just send the request and you immediately return. You don't wait for a response of this request, so to say. So the storage engine had no chance to store it in memory and generate an object ID. And therefore, you get back acknowledged false because, you sent a request, you don't even know if it reached the server. This is, of course, super fast because you don't have to wait for any response here, for any ID generation, but obviously it tells you nothing about whether this succeeded or not. Could still be a valid option for data where it's okay for you if some data does not end up in a database. So if you log some value every second about an application and you don't care if a couple of seconds get lost, you could do that. So that is W0. The default with Alex, who's 36, the default is W1, of course. This gives you the output you saw before, acknowledged true and the inserted ID. Now let's go for Michael. And let's play around with the journal. The journal can be set to true. The default is undefined or false. So if I set it to false, I have the same result as before. Now, if I change it to Michaela, and we set the journal to true now, the output for us does not change. And it also was super fast here because everything runs locally and it's not like the journaling will take for hours. But it will have been a little bit slower because the entry will have been added to the journal and we waited for that journal editing to finish here. So here we have higher security because we can also be sure that it ended up in this to-do list of the storage engine, which will eventually lead to the writes happen to the database files. So now we got this. Now let me add another person, Aliyah, 22. And let me also add a third option, W timeout. If I add this like this, it succeeded. Now, if I repeat it with a very small value, it also succeeded because this is super fast here. But it is an option which you can set in case you got a shaky connection, or speed really matters and your connection is generally good, but you can't rule out that once in a year it's kind of shaky and you then rather have that write fail. And you recognize this in your client application, of course, because you'll get back an error here too. So you'll have that write fail, and therefore you can try again later, but you don't wait unnecessarily long. So this can absolutely be something you are fine with. So now we covered some interesting options for the write or the insert operation. And the writeConcern is also applicable to updates and deletes. Now there's one important concept I want to touch on, and that is the atomicity of any write operation. Let's say we have an insert1 operation, but this could be any write operation again. Now such an operation most of the time will of course succeed, but it can fail. There can be an error. And here I'm talking about errors that happen whilst the document is inserted, so whilst it's written to memory, whilst it's handled by the storage engine. You could imagine that if you have a document with multiple fields, let's say also with a couple of embedded documents, that some of these fields end up in the database, so in the database files also, whilst others are not included because in between, so whilst the document was processed, the server had an issue. So if you added a person with name, age, and hobbies, maybe name and age was saved but not hobbies. MongoDB protects you against this. It guarantees you an atomic transaction, which means the transaction either succeeds as a whole or it fails as a whole. And if it fails during the write, everything is rolled back for this document you inserted. And that is important. It's on a per document level. That document means the top level document, so it includes all embedded documents, all arrays, so that is all included. But if you use insertMany with multiple documents being inserted, then you don't get this. So you only have support on a document level, but if you have multiple documents in one operation, like insertMany, then only each document on its own is guaranteed to either fail or succeed, but not insertMany. So if you have an issue during insertMany, that just means that the documents on which it failed are not added, and then the exact behavior depends on whether you used ordered or unordered inserts. But the documents which already were inserted will not be rolled back, as I explained in the ordered and unordered insert lecture. We are actually able to control this on this bulk insert or bulk update level 2, and that will be related to a concept called transactions, but that is something I will cover towards the end of this course because it requires some additional knowledge about MongoDB and how servers work there that we don't have yet. But on a document level, including all embedded documents, you have this atomic operation guarantee. Now, let's import some data. And for that, you need to exit the shell, which you can do by hitting Ctrl-C, because you need to go back into your normal terminal mode on your operating system. Then you should navigate to a folder where you find the file, the JSON file you want to import. JSON files can be imported, and attached to this video you find a dummy file with which will work. So make sure to download that file into a folder, and then with the cd command, navigate into that folder in your terminal, so in the folder where you stored that attached file. I already am in such a folder. Now in there, you see I got a couple of files. We'll work with the TV shows JSON file, which is the one you found attached. And we can now import it with the Mongo import command. This should be globally available since you added the path to your Mongo binaries to your path variables on your operating system. If you did not do that, you need to navigate into that folder where your binaries are, where MongoD and so on are, where you also find the Mongo import. And then you can execute this. And then the first argument you pass here is the name of the file you want to import. Now, if you're not in that same folder as the file, you'll have to specify a full path on your operating system. Since I am in the same folder, I can just specify the file name. Then we can specify into which database we want to import that data. And here I'll have my movie data database, which should be created on the fly. You specify the database with the -d command. You can also specify, or you should specify, into which collection you want to import your data then. So in the movie data database, I want to import it into the movies collection. And in the movies collection, there all these documents should be added. Now, tvshows.json happens to hold an array of documents, not just one document. So you also should specify --JSON array to make the Mongo import command aware of this, because you could also use it to import just one document, which is the default it looks for. Now with this, we tell it, hey, there are multiple documents in that file. Now, the last thing I'll add is --drop. This simply means if this collection should already exist, it will be dropped and then re-added. Otherwise, it will append the data to the existing collection, and that might also be what you want. But here, I don't have that collection yet, but if I had it, it would delete the old one and re-import the data into the newly created one. With that, if I hit enter, it should connect to your running MongoDB process, so that still needs to be running. It drops movie data movies if that existed, and then you see it imported 240 documents. And now we can fire up that shell again. And there, if I have a look at my databases, we see the movie data. I can then switch to movie data, and there we should see a movies collection. And if we quickly have a look at that with find pretty, you will see a bunch of data in there. Now here we have more than 20 records, which is why I have this output here, and I'll come back to cursors in the next module, by the way. But you see, here we got some movie data for some series, basically, like Supernatural. So series you can watch on TV. Well, we got some data on them here. So this is the data we'll also work with in the next module. And Mongo import, of course, is a helpful tool for getting data you want to start with or you have from an older database or whatever into your database and collection. That's it for this module. We learned quite a bit about inserting documents. There basically is insertOne and insertMany. With these two methods, you can insert either one document at a time or multiple documents together. There also is the insert method like that, but it's not recommended to use that anymore. InsertOne and insertMany are clearer about what they do. And additionally, the insert method gives you no feedback regarding the document IDs that were created, and that can be a useful piece of information in many applications. So insertOne and insertMany are the methods to use. We also learned about ordered inserts. By default, when using insertMany, inserts are ordered. That means that if something goes wrong, if you have some error, let's say a duplicate ID, all the documents that would come after the document that caused an error will not be written to the database. The insert is basically stopped. You can change that by switching to an unordered insert. With that ordered option, you could specify on insertMany. Then your inserting process will continue even if you had an error. In both cases, and that's important, successful inserts will never be rolled back. So even with an ordered insert, if you have an error, all documents that were added before that error will stay in the database. If you need a bulk operation that is rolled back in case of an error, you should later check out the transactions module towards the end of this course, where I will dive into how that would work. Now we also had a look at the writeConcern. There you can control the level of guarantee you have that your write will succeed. Because you have that storage engine handling your write operation, keeping a journal, which is like a to-do list of tasks it needs to do, and you can either wait for that journal being updated or you don't wait for this. And depending on that, your write will be a bit slower, but you have a higher guarantee that it really will happen eventually. Choose the value of that option. So whether you want to wait for journaling, or maybe you don't even want to wait for the server to respond to your write request, choose that on your application requirements. And now last but not least, we also had a look at Mongo import. That should have been pretty self-explanatory. And now you should have a solid tool set for getting data into the database. Time to move on and learn how we can also read the data there and learn about the many options we have for filtering and getting exactly the data we need. Now, we worked with cursors in the last lectures. Now, there is something else we can do with the results this cursor stores or gives us back, to be precise. Now, what can we do there? If I have a look at my movies and I find them all like this, I get a bunch of movies, obviously. And if I print them, I, get them in a nicer form. Now, here, please note, I'm handling the cursor manually. I'll let the shell do that and let the shell fetch the first 20. Now, of course, a common operation would be that you want to sort the results you get back. You can sort by anything. You can take a string and it will be sorted alphabetically, or you can sort by a number and then it will obviously be sorted by that number. Let's say by rating. Now we can sort by adding .sort, if we use pretty before pretty, but always after find. Now sort takes a document where you describe how to sort. Now here we could say we want to sort by the average rating, so rating average. And that already shows us that we can also sort by a field in an embedded document. You could, of course, also sort by a top-level field. So here we can sort by rating.average. Now, the value you specify here describes the direction in which you sort. 1 means ascending, -1 means descending. So if I use -1 here, I actually have the highest ratings first. 8.8, 8.8, and if we scroll up a little bit further ahead, we see 9, and so on. And of course, as I mentioned, we can also sort in the opposite direction, and now we'll have the worst items first. You're also not limited to one sorting criteria. You could say you want to sort by the rating first, and the order does matter, so it will first be sorted by rating, but then within each rating, so to say, you want to sort by runtime. Also, ascending or descending. So let's say descending. Now what we have is, we have our ratings, 6.4, 6.4, but inside of that rating, it will actually sort by runtime. Now here I have the same runtime. Here, however, I have 30 minutes in the 6.3 rating. Here again, I have 6.3 with 60 minutes, and hence 60 minutes comes first before 30, because I'm sorting the runtime in a descending order, so higher values first. So you can combine multiple, as many as you want, sorting criteria here. And sorting, of course, is a pretty common task you do when you work with data, because it allows you to not just narrow down the set of data you want, but then also retrieve it in the right order. Now, sort is available on this cursor. It's not available for findOne for obvious reasons, because findOne only gives you one document. There's nothing to sort. Now, sorting is one thing we can do. We can also skip a certain amount of elements. Now, why would you skip? Let's say in your client application, a website, you implement some pagination. So people can view the results which are distributed across multiple pages, because you don't want to have one page with 100 results, but you want to have 10 on every page. Now, if the user switches to page number 2, you want to skip the first 10 results, which would have been on page number 1. But now you want to display the results for page number 2. And therefore, you can add a skip method here to skip results. So let's say if I add skip 10 here, you will see that the results here are slightly different. We got 6.6 ratings. If you remember, previously in the same amount of documents, we had 6.4 and so on. So it looks like we skipped some documents. And indeed, we did. So skipping does allow us to move through our data set. If I skip 100, then we can see the ratings are much higher because we skipped all the bad ones. The 100 bad ones, we skipped them. Now, skip is also used on a cursor, as you can tell. Now, related to skip somehow is the limit function. Limit allows you to limit the amount of elements the cursor should retrieve at a time. And that also means the amount of documents you can then move through with a cursor. You can limit this to 10, for example. The interesting thing is, if you here add count, you still have 240. But if I now execute pretty here, indeed, the cursor is not fully exhausted, but I only get 10 elements with the help of limit. So limit also allows us to retrieve a certain amount of documents, but only the amount of documents we specify. This also is related to pagination. If you had your website with 10 products per page, it doesn't suffice to skip 10 products because you're on page number 2. You also only want to display 10 products on page number 2, and that is exactly what limit helps you do. It limits the amount of data that is retrieved and returned through the cursor. Now, there is maybe one thing which you thought about. If we have this query where we sort, and I do actually sort twice here, I didn't notice that. As you see, it didn't do any harm, but of course it is redundant. So if we have a query where we sort, and then we skip, and then we limit, does the order matter? In theory, you would say it should matter, right? Because if I skip before I sort, then I skip on the unsorted documents, so I simply skip the first 100 in the collection, and I only sort the remaining ones, which means I don't necessarily skip the badly rated ones, but I simply skipped some random items and I only sort after skipping, which of course is typically not what you want. Now, the good thing is, on a cursor, the order here does not matter. Later in the aggregation framework, this will change and I will talk about it there. But here, you can have skip, sort, and limit in whichever order you want. You can limit first, you can skip first. MongoDB and the cursor will automatically do it in the right order. It will sort first, then skip, and then limit. Now we're almost done with the module. We learned a lot about querying, operators, and also about cursors. Now let's talk about how we can shape the data which we do get back into the form we need it in. Because in the example of our movies, we have all that data for every document we return. That might simply be too much data. Not only is it a lot of redundant data that we transfer over the wire if we don't need it, it also makes it harder for it to work with the data if we have to manually parse all that. Now, with projection, we can control which data is returned. Let's say we are only interested in the name, the genres, the runtime, and the rating. And all the rest does not matter to us. If that is the case, I can write a query here without any criteria. Let's say we fetch all documents in a pretty way. But now I actually need to pass a second argument to find. Now for that, I also need to pass a first one. And if I don't want to specify any criteria, any filter, I just add empty curly braces like this. The second argument to find then allows us to configure how values are projected, so how we actually extract the data fields. And here we have a very simple syntax. If we want to get the name and the genres and the runtime and the rating, then we simply add name and add a 1. That means the name field is something I want to include. The genres, that's also something I want to include, as is the runtime. Now, last but not least, I also want to include the rating. Now, all fields that I don't mention here with a 1, or that I explicitly add with a 0, like, let's say, image, are not included. But I don't need to add image 0 here. It will be excluded by default. So if I hit enter, now I get a reduced version. You'll see that the ID is always included though. And that is one exception. The ID is always included even if you don't specify it with a 1. If you want to exclude the ID, that is possible, but you have to explicitly set _ID to 0. That is not required for any other field, but for the ID, it is. And now we have our data without the ID. So now we return just the fields for every document that we are interested in, which is of course very, very helpful. You can also project on embedded documents, like for rating. You could say, for the rating, I'm only interested in the average field. And then you would simply use the path notation, rating average, and set this to 1. However, this will result in, well, the same result because rating was an embedded document with only the average. So we can use a different example, of course. In our data structure, if I go up a bit, we see that we also have the schedule. And let's say we're only interested in the time. Well, schedule is an embedded document, so we can just get the time by adding schedule.time and set this to 1. And now you will notice the time is included, but schedule also had an array of the days, and that is now not included. So projection can also be used on embedded documents. Now, projection can also work with arrays and help us a bit with array data that we include. Now, let me show you how that works. How can we work with array data? For that, let me quickly find my movies and look into the structure. Now, we got 2 arrays here. One of them is the genre array. Now, let's say we want to find all movies that have a genre of drama. Now, of course, you know how that works. You simply go to your query, and there you check that genres is equal to drama. And this will look for all documents that have a drama in the genres array. Now, if I only want to output that drama genre, then I can add projection. Let me maybe do this in a cleaned up console. So I can add projection, so a second argument here. And here I can use a special syntax and set genres $ to 1. Now what this means is, give me the one genre you found. And therefore, in my genres, I only have drama now. Now, these items will have more genres than just drama. I only just fetch the drama. I only just output that, because that might be the only thing I'm interested. But the items behind the scenes will have more data, just as they have other fields too. They have more genres too, but with this syntax, I only find the first match for my query here. If I had a more complex query for different genres, I would still just find the first match. Let me show this to you. If I have a slightly modified query and I'm looking for genres that have all drama and horror, I now only get back horror here. Now, this might look strange at first. The reason for this is that all works such that it goes through the arrays and checks for the existence of drama and horror. So the first element to meet both is, well, found when horror is confirmed to be in there too. And that is why we output horror, because that technically is the first matching element. Drama alone didn't match anything. The main thing here is that it doesn't return both, but only one. Now, sometimes you could also have the case where you want to pull out some items from an array in your document that are not the items you queried for. So here's an example. For movies, let's find all movies where genres does have a drama. And of course, if I execute it like this, we already know that result. We get the movies with the drama. Now, what I can do is I can add some projection here. So I can add a second argument to project my values and say genres. Well, we know that I can use genres.$ and set this to 1 to include only that, and now only see the result of my query. But what if I actually want to now see only the horror? Well, then here in the projection, I can set genres equal to, and now I can use elemMatch here. And we saw that before, but now it works in the context of projection. It still works in the same way as shown before. So this will find us the first element for which a certain condition is met. And here my condition simply is equality to horror. If I now hit enter, you see, for some documents, I have no genres. So these are documents which will have a drama, because that is what I filter for. But then I try to pull out only the horror part, and that is simply not included. And for others, I do have horror, so these will be items that do have both drama and horror. So I hope this makes sense. This basically gives you more flexibility to control which items of an array are displayed in your result set and which items of an array are important for your filtering. And now these don't have to match. So if you get cases where you want to filter for something in an array or for anything else on your document, doesn't have to be filtering on an array, and you then want to pull out certain values of an array based on some other condition, you can add that condition with elemMatch here on the array you're working on. So I hope this makes sense. This filter here could totally go against something else. We could be filtering for the rating here. So here I could absolutely filter for rating.average being equal or being, let's say, greater than 9, and then output that with projection. And here we see only one element, only one movie or series with a rating greater than 9 seems to have a genre of horror because it's empty for the others. But now filter and this projection are totally unrelated, and that is important to understand here. Now there's one last special projection parameter which I want to show you that is related to arrays, and that is the slice operator, you could say. Now, I'll repeat my query where I look for movies with a rating average greater than 9, but now I'll not use elemMatch here on my genres, but I will still use a special value enclosed in curly braces. I'll look for a slice of the genres array, let's say 2. And what this yields to me, and for that, I will also add some other projections so that I not get everything. I'll also add, let's say, the name and set it to 1. Because now this will give me a list of items where I only have the ID because it's in there by default and I didn't exclude it. Then I have the name of the series, and then I have the genres, but only the first 2 elements. So all these documents can absolutely have more genres assigned to them, but I only see the first 2 because I use slice 2, and that can be any number. You can look for the first 3, the first 5, and you can even use slice in a different way. You can use it in the array form, and then the first element is the amount of elements in the array, so in the genres array, which you skip, let's say 1, and then the second element is the amount of data you want to limit it to, let's say 2. So now we will pull some items from the genres array, but we'll skip the first item, and then, in this case, return the items 2 and 3, so the next 2 items. And now we can see that here we can't directly prove it, but you could, of course, search for this element. Let's maybe do that. Let's search for Firefly by ID. We see science fiction and Western here, but if we quickly use our movies and we look for ID being equal to our object ID, and we print this in a pretty format, or don't need to do that. We can simply project out all the genres. So just set genres to 1. If I now hit enter, I get that one entry, and we see here we pulled out science fiction and Western. Actually, the genres are adventure, science fiction, and Western. So we skipped the first value, and then we output the next 2 values. That is what we did with this syntax, with slice. So now you have a lot of different ways of controlling what you see. For normal fields, it's straightforward with 1 and 0. For arrays, it's hard to do that with 1 and 0, or impossible to be precise. So there you got elemMatch, the $sign, and slice to control which elements of the array end up in your result set. And with that, you got full control over what you fetch with filtering, and then which fields of the found documents you include in your result set. In the last module, we had a detailed look at how you can get data into the database. Now, often that is only useful if you have the means to get data out of the database, and that is exactly what this module is about. It's about reading data that is in your database. Now, we already used find quite a bit in this module, but find, as we used it, always gave us back all the data essentially. You can, of course, filter for specific documents. You're not limited to getting all the data all the time. And you can also transform the documents you get back to some extent. Additionally, we'll talk about that cursor thing again, which I touched on earlier in this course. So in detail, we'll have a look at methods, filters, and operators, what all of that is and how it works together. We'll then have a look at query selectors, so findOne and find, and how we work with filters there, and at projection operators, which will help us with, well, transforming the data we get back, you could say. This is, in a nutshell, what we'll do in this module, and for this module, we'll use the dataset, or at least we'll start with the dataset we imported at the end of last module. So make sure you watch that video to see how that dataset, the movies dataset there, got into the database. We used Mongo import for that, and we did it at the end of the insert module. If you know how to use Mongo import, you find that dataset attached to this video again. You don't need to re-import if you already did it in the last module, but if you skip that module, but you know how to import data, the dataset is attached. So with that, let's dive into reading data. Some theory first. When working with MongoDB, we can basically talk about methods, filters, and operators. Not just for getting data, but in general, but especially for getting data, filters, and so on play an important role. So in the shell, we access the database with the db command. In a MongoDB driver, this will differ slightly, and you'll see it in the from shell to driver module towards the end of the course. But there too, we will get access to the database and then to a collection in the database. The same can be done in the shell. Now then we can execute a method like find. Insert also was a method. Delete was a method. So everything which comes after a dot here and then has parentheses like this one is called a method. A method we execute on the collection in this case. Now we pass some data to this method, the parameters of the method, so to say. In find, the first argument or parameter we can pass is a document describing what we'll look for. It has the format of a field name and then the value for that field name. Now you will learn that the value is quite flexible when finding data, but in the end this is the structure, fields and values. And this is also what documents are all about. Fields or keys, however you want to name it, and values for these names or fields. Now here, this argument for find happens to be a filter because find accepts a filter. It needs or it can use a filter to narrow down the set of documents it returns you. Here we got an equality or a single value filter because we want to find all documents that have an age field where the age is exactly 32. So we're looking for equality here. This is a very simple filter, but also one you'll use quite a lot. Now you can also use more complex filters, where you, for example, see something like this as a value, where you have another document as a value, which in turn has a value, and where the field is then an operator. And you can see or you can recognize operators by the $sign at the beginning. These are all reserved fields, if you want to call them like this, which are understood by MongoDB. And this operation here, as an example, is called a range filter, because it does not just filter for equality. Instead, this will look for all documents that have an age that is greater than, that's what the GT operator does, that is greater than the value, so greater than 30. This is how this works and what we will work with in this module. We'll learn a bunch of different operators and different ways of using them and different ways of filtering, therefore. But in the end, this is always the structure you will recognize. Now, speaking of operators in the last lecture, we got a couple of different operators we can differentiate. We got query and projection operators. Query selectors, basically the different operators like $GT, which you saw in the last lecture, which allow us to narrow down the set of documents we retrieve, and projection operators that allow us to transform or change the data we get back to some extent. These are read-related operators. Now, we'll also learn about update-related operators later, where we can also basically update fields and arrays, and there are different techniques for operating these things, so normal fields or arrays in a document. We'll learn about this in the update module, of course. And we also got query modifiers. Now, this allows us to change the query behavior, and this is deprecated now. So this will not be covered anymore, because what you could do with these can now be done with the normal operators, basically. We also can do some aggregation, which is also reading data from the database, but allows you to do more complex transforms, basically. This is a very interesting concept, where you basically set up a pipeline of stages to funnel your data through, and you got a bunch of operators that allow you to shape the data you get back to the form you needed in your app. And therefore, we got a whole module for this, where this will be covered, the aggregation module. So in this module, we'll focus on the read operators. In the update module, we'll have a look at the update operators. Now, for inserts and deletes, there are no operators. For deletes, there are, but these will be the same as the read operators, because there you just need to find data you want to delete, and that works in the same way you find data to output. But for updating, we got some separate operators, and they will be covered in the update module. Now, how do operators impact our data? That depends on the type. If we got a query operator, like we'll use it in this module, we can use it to locate data. It does not change our data, and an example would be $EQ for equal, or GT, which you saw before. Projection operators, which we'll also see in this module, allow you to modify the data presentation, so the data you get back. This will also not change the data in the database, though, only change the look of it, which you get. Here, $sign is an example. This will become clearer once we use projection operators. So in the end, we just got some tools to control the look of the data we get back. Update operators, which we'll cover in the update module, allow you to modify and add additional data, and this therefore does, of course, change the data. Inc, $inc is an example, which will increment the field by 1 or any amount you specify, and this is also something we'll see in the update module, of course. Now, with that, let's dive into query selectors and projection operators. This is what we'll work with in this module, after all. For query selectors, we got a couple of categories. We got comparison, logical, element, evaluation, array, and comments selectors. And I will talk about these different categories, what's inside there, and how they differ and how we use them in detail in this module, of course. We also got geospatial selectors, which allow us to work with location data and, for example, find out which place is nearest to some coordinates we have. And we'll cover that in a special module, the geospatial module. Now, for projection, we got $elemMatch, so $elemMatch and $meta and $slice. And that is also something we will cover in this module when we talk about projection operators. $meta will not be covered in this module, but in a later module, because this is related to indexes. So this will be covered in the index module. With that, enough of the theory. Let's dive in and let's start querying our data, use these operators, filters, and all these fun things. So I'm back in the shell, and the important thing is we'll work with movies, which we imported in the last course module. So make sure you got that data there. And if I quickly use findOne, that already is our first read method. findOne does what the name suggests. It finds exactly one document. You can pass a filter to it, and we will learn about filters later to define which one document that should be, but then it will always find the first matching document. If you specify nothing, it will look through all documents and simply give you back the first document in your collection. If you specified some filter, like age 30, which will not work here because we have no age field, but if you specify something like this, it would give you the first document where this condition is met. So empty curly braces or no curly braces at all will simply give you back the first document. Please note that this also does not give you back a cursor, but only one document, which it instantly loads. Now, this is the shape of the data in our movies collection. This is data about TV series, and maybe we should have named it series therefore, but now it's movies. And there you see we got a couple of fields, like the name, which type it is, language, some genres, if it's still running or already ended, the runtime, when it premiered, and well, that should be all pretty self-explanatory. There is a bunch of data for us to play around with, and that is exactly what we'll do. So this was findOne. Now let's say we want to find one document, but we want to find one different document. For that, let's first of all have a look at the alternative to findOne, which is find. Now find like this will give us back a cursor, as you learned, and we'll care about cursors later. For now, let's just accept it. Pretty is a method we can change to get a prettier output. Now this theoretically gives us all documents, but since it gives us a cursor in the end, it does not give us all documents to avoid querying the database or the collection for all documents. In the shell, we just get back the first 20 documents. So with find, we see there's a bunch of stuff in there. And for example, there is the last chip series. And why don't we try to find this with either findOne or find? Well, to do this, we will need a filter. And we specify a filter on both findOne and find. It doesn't matter. They work in exactly the same way regarding all these options you'll learn about by passing a document to the method. So that again is the same for findOne and find. It doesn't matter. The only thing that does change, of course, is that findOne will give us back one document that meets that criteria. Find will give us back all documents that meet that criteria. Now here, I want to check for the name. So for the name field to be equal to the last ship. We can do this by specifying the key here, name, so the field where we want to look into, and then the value. And by default, if you specify it like this, so just key value, MongoDB will look for equality. So if I now hit enter, we get all documents where the name is the last ship, which happens to only be one document. We, of course, would get more documents if we used a field where the value would be repeating. So for example, if we used runtime 60, by quickly changing that to runtime, and then that is a number, so 60, then you see these are way more documents. Obviously, it's a wall of text. We could use pretty to make it easier to read, but the main thing is these are multiple documents. Now that also allows me to highlight the difference with findOne. findOne only gives us back one document, the first document that meets that criteria, which is CLI and not the last chip, because that happens to be the first document having the right runtime. So this is findOne and find, and how you pass a filter by passing a document as an argument, and that document describes your query selector, so your filtering criteria, you could say. Here we use equality, but of course, as I already mentioned, there are way more ways of filtering and way more operators. So let's dive into these operators. So I mentioned there are more operators. Now, the best way to learn about them all and to always, have a look at them even if you're done with the course is, of course, to dive into the official documentation. There in the docs, if you check out the MongoDB server, You can learn more about the CRUD operations, which also will be interesting. But if you scroll down to the reference there, you can click on operators. And there, right now in this module, we'll talk about the query and projection operators. And there you got the different categories that exist. Here are the projection operators, the rest are query operators. And for example, you also see them here on the starting page. You see here is $GT, which we saw before. Now there are a bunch of operators, and I will walk through many of them in this module to explain how they work and what you can do with them. So let's start with some comparison operators, because this is of course a group of operators you'll use quite a bit. So let's go back to our database here. And this is the query I ran before, runtime 60. Now let's say we want to search for movies where the runtime is actually lower than 60. We can do this by specifying a document as a value, remember the slide, because this will then tell MongoDB that we're not looking for equality, which is just a default it assumes, but that we now want to use a query operator. Now as a side note, there is a $EQ operator, and if I set this to 60, this query here is exactly equivalent to this query. So if I use runtime 60 like this, or equal 60, does not make a difference. So this is simply a shortcut. The other syntax is just a shortcut to this more verbose mode. Now, where it does make a difference, because there is no equivalent, is if you use something else than EQ. For example, NE for not equal. And again, you find all these operators in the official docs. So now we're using the not equal operator to find all series or movies which are not equal, or where the runtime is not equal to 60 minutes. So if I hit enter here, I get a bunch of data. Let's make it more readable by adding pretty. And let's check one document here. There we have a runtime of 30 indeed. Let's check another document. There we have a runtime of 42. So also not 60. And let's check a third one. There we have a runtime of 30. And you can check them all. There will be no series or no item with a runtime of 60 due to this query we executed. Now this is not equal to. Of course, we might be interested in searching for any series that has a runtime lower than 40 minutes, let's say. So not just not equal, because that would also give us series with 60 minutes, but lower than. So 40 minutes, 42, 60, that will all be out of the game. If we do that, and let's again add pretty for a nicer output, we will see that there is a series with a runtime of 30. And there is another item with a runtime of 30. And there should be another item with a runtime of 30. So you won't find any value above 40 here. And it just happens to be the case that series typically have a runtime of 30, 42, or 60 minutes, so there's little in between by the looks of it. But this is now the lower than operator. So with that, we already covered NE, GT, and lower than. There also is lower than or equal with LTE. So the difference here simply is that if I was looking for, let's say, 42, and there happen to be some items with a runtime of 42, if I use LT, I will not find any runtime equal to 42. But if I repeat that same command with LTE, which means lower than or equal to 42, then if we scroll through, we will find some items with a runtime of 42. Let me quickly search one. Here is one. So that's the difference. Now it should be pretty clear what GT and LTE and GTE therefore do. With GT, we find a series where the runtime is greater than 42. So now we'll only have some items with 60 minutes in there, like this one. And of course, with GTE, we find, well, greater than or equal. So now again, we'll have some 60 minutes series like this one, but we will also find some items with 42 minutes of runtime. Now, you might not find one when scrolling through this set, but keep in mind, because we get back a cursor, we only see the first 20 results of our query, so there might be no 42-minute series in there. You will get back results greater than or equal to 42 with this query. Now, you are also not limited to querying top-level fields. If I quickly find one element so that we see the structure again, you see in this document, we have a lot of embedded documents. Externals, image, the network where you could see this, the rating, which holds one nested field, schedule. So we have a bunch of embedded fields here. We also have arrays, and I'll come back to querying arrays too. Now, you can query such embedded fields as well. And querying them is quite simple. I showed you the syntax earlier already. You can run your find or findOne query by passing a document. And now let's say we want to look for all series or all items here where the rating is greater than 7. So, for example, a GLI should not be included. Now we can do this by specifying the path to the field we're interested in. So in our case, that's the average field inside of the rating embedded document. You specify such a path by using double quotation marks around the path. This is required because otherwise the dot is considered an invalid character. And then you have your field that holds the embedded document. So in my case, that field name is rating, not ratings, rating that holds the embedded document. So rating in my case, dot, and then the name of the field. And if you had multiple levels, let's say there you had the total rating and then you had the average, this would work too. But I just happen to have an average field in there, and that holds the value I want to query. Now we could query for equality, but as I mentioned, I want to find all ratings greater than 7, and that can be done like this. It also doesn't matter if you use 7 or 7.0 here, you can use both. Now if I do that and I pretty print my results, I get back quite a lot of results, but you should not find any item where the rating is below 7. That should not be the case. So there you find an easy way of querying embedded documents. And as I mentioned, that embedding, that path, can be as deep as you need it to be. So you're not limited to one level. You can add as many dots in your path as required to dig into that embedded document. And then you can use all the query selectors, all the operators on that embedded field. You can also query arrays. We got the genres array in our data, which has some keywords for the different genres. Now let's say we want to find all items which have the drama genre. Now to make this work, we'll use a find query again, but the term here, or the query expression, of course, differs. Now, keep in mind, we're looking for the genres field. That is not an embedded document, but an array. The approach I show you would work equally for arrays in embedded documents. Of course, you just would need to use the dot notation to reach that array in there. But then it's just a normal field. So here it's a top-level field named genres. So let's look for genres here. And then let's try this. Let's try looking for drama. The casing here is important, by the way. Drama like this will not give you anything because there is no drama. It always starts with a capital D. If I look for it like this, I do get back results. And all these results will have genres that also include drama. And that's the important thing. Equality here with an array does not mean that drama is the only item in the array. So it's not like genres is equal to just drama. It's just equal to there is drama in the array. So this item does exist. Genres is equal to drama in that drama exists in the array, but there may be more genres. If you want exact equality, you can get that too, of course. If you want exact equality, you can modify your query to not look for genres drama like this, but now you include square brackets around it. That signals MongoDB that you will look for genres being equal to exactly that array. If I now hit enter, I also find some documents, and here, indeed, genres is just drama, just an array with drama in there, no other genres. So this is really important to understand. This is how you can query arrays in its basic form, either for exact equality or for does it include this item. Both can be helpful depending on what you're trying to achieve. Now that we had a brief look at how we can query embedded documents and arrays, let me come back to my comparison selectors here. We had a look at most of them, but we did not look at $in or NIN. Now, what do these two operators do? Now, for that, let's come back to, let's say, the runtime. I'll reach out to my movies again and pretty print the results. And the filter I'll specify here will check the runtime field. And I want to make sure that the runtime is either 30 or 42. Now, we know that in our data set, I could achieve this with lower than or equal to 42 because we just happen to have data with 30, 42, and 60 minutes in there. So this will give us all the items that have a runtime lower than or equal 42, which is all the items with 30 or 42. But of course, that is not the case for every data set, and we might not even know that our data looks like that. So if we know there are two discrete values we want to check for, we can use the $in operator. In takes an array, and now this does not mean it looks for this array, but in this array, we specify all the values that will be accepted as values for this key. So in our case, 30 and 42. So it will find us all documents that have a runtime of 30 or 42, but not of 60. Or if we had 15 minutes, these would also be excluded. So if I now hit enter, we get back a bunch of results, and you should only find runtime equal to 30 in there, or a runtime equal to 42, like for this document. Now, NIN is just the opposite. We could say we want to find everything where the value is not in this range, or this is not a range, but in this set of values. So now we would find all values, all entries, where the runtime is not equal to 30 or 42. So if I now hit enter, in our data set, this will now only include items with a runtime of 60. But again, if you had more values there, like 15 minutes, 20 minutes, these would now also be included in our result set here. So that is in and not in, these two missing comparison operators. And with that, we had a look at all comparison operators. So let's now move on to logical operators in the next module. With comparison operators covered, let's have a look at logical operators, and, not, nor, and or. Now I will say it right away, the operator you'll probably use most often here is $or, and I'll explain why too. So let's dive into our database, or into our data set here again, into our collection, and let's work with these operators. So for that, let's quickly have a look at our structure of one document, and let's say we want to find all documents or all items here, where the rating is either lower than 3 or greater than 9. So the very bad or the very high quality items. Now I'll run each query standalone to begin with. So db movies find pretty, and then let's add the filter. Now I'm looking for rating.average. And then here, let's first of all check if there are any items with a rating lower than 3. And there are not, so let's modify this slightly. 4, nope. 5, okay, so we got items, yeah, more than one, with a rating lower than 5. 2 items to be precise. You can, by the way, find out how many items there are by replacing pretty with count, and you'll just get back the number of items, but more on that later. So we have 2 items. Now let's check how many items, or if we got any items with a value, a rating greater than 9. We got some items. Let me quickly check the amount. 7. So let's maybe narrow this down even more. 9.5, too much. 9.4. 9.3, okay, 2 items. So now let's combine these two. Lower than, there we had 5, and greater than 9.3. Now for that we can use the OR operator. So I can write a new query here, pretty print the results. And in there, you now don't start with the field you're looking for, so not rating average, and then equal to something, but instead you start directly with $or. telling MongoDB that you'll have multiple conditions. You then add an array, and that array will hold all the conditions that MongoDB will check. Now, OR means that it will return results that match any of these conditions. OR means an alternative. So we then specify our filters, which we previously specified directly inside find, like rating.average being lower, $lower than 5. Okay, so this is the expression we previously would add directly inside find, but now it's just one of two expressions or two checks we want to perform, and therefore it goes into this OR array. Now, the second value in OR then is the second expression, and we can have more than two. You can have 3, 5, as many as you want, essentially. So here, rating.average, that is my other check, if it's greater than 9.3. So now I got two checks here, and this should me find all documents with a rating lower than 5 or greater than 9.3, but nothing in between. If I now hit enter, I do find some results. Here we have a very good rating. The next result has a very poor rating, below 5. Then if I scroll up, I got a very good rating again. And there should be one last document, and there is, with a very poor rating. And that's it. These are all the documents that were returned, which makes sense because if you remember, when I ran these queries standalone, we had 2 and 2. Now we have 4. So that is the OR operator. Now, the NOR operator is pretty self-explanatory. If I add NOR here, it simply means return me all documents where neither of the two conditions is met. So in our case, it should give us all documents with a rating that is not lower than 5, so basically higher than 5, but also give me all documents with a rating that is not higher than 9.3. If I execute this, I got quite a lot of documents. And now let's do a quick check to see if that yields us the difference to the last query. For this, first of all, let's find all documents. So we have 240 in the collection. Then let's run our query with OR, so what we previously had, and let's count the results there. Here we got 4. So the NOR query should now essentially give us, if we replace pretty with count, 236, and that is the case. And this kind of shows what NOR does. It's the inverse of this check here. And that gives you a lot of utility, of course, for narrowing down your set to the data you require. So in the last lecture, we had a look at OR. Let's now have a look at AND. For that, again, let's add a find query here. And let's pass a document where we describe our filter. And now let's use $AND. Just as OR, this takes an array of documents. And now let's say we want to find all documents where we have a rating, and we found that on rating.average, remember? A rating that is greater than 9, so $greater 9. So a high quality item, high quality series or movie. And that's the second element in this array. And just as with OR, you can have as many as you want. You're not limited to 2. And let's say we're looking for documents that have a genre of drama. Again, I'm querying that index with this syntax to find all items that must have drama but may have additional genres. So we find high quality dramas here with AND. And if I hit enter, we got some results, and we see the rating is quite good here, and we got drama in the genre. And we got another result with very high rating and drama in the genre. So this is working. Now, actually, there is a shorter way of writing this. We can totally get rid of this. So this is the old syntax, and I'll just count that. We find 3 results to leave it here on the page whilst I write the alternative. The alternative is that we don't use AND, but we just pass a document, one document here, and in there we just start writing our conditions. So rating average should be, and then that's exactly the same condition I have above. So greater than 9, and then just a comma inside of our filter document to add another field to that filter document. Genres drama. If I count that, you will see I get back 3 items as well. So these 2 ways of getting the data are exactly equal, because by default, MongoDB ANDs all key fields you add to that filter document, and is the default concatenation mechanism of MongoDB. That of course leaves one question. Why is there a $and operator if this does exactly the same? There is a $and operator because you might have multiple conditions on the same field. Let's say on genres. If I want to find the count of items, and I'm just using count to not put all the data on the screen immediately, on genres, where the genre is drama, but where the genre also is horror. This does work here, but this will actually not work in all drivers, because in JavaScript, having repeat names in the same object is not permitted. It is for cases like this that you then can use AND. So even though it works here, does not have to work in all drivers. So then you can simply wrap these queries into separate documents which you pass to that AND array, and now you will have an approach that will work fine. Now you will also notice that the number of results returned is different. And the reason for that is simple. Let me repeat that approach where I mentioned it will not work everywhere, and let's look into the data. Now in these 23 results, we got drama and horror, drama, crime and horror, drama, horror again, drama, fantasy and horror. But then if you scroll up, also an entry with just horror. Now why is that? Because, and that is what I meant, even though we don't get an error here, it essentially, the second genres of horror will essentially just replace that key, because in JSON documents, you can't have the same key more than once. And if you do specify it more than once, the second one will just overwrite the first one. So actually, the query like this, which gives us back 23 results, is equivalent to this query, where we get back 23 results. So if you want to look for both genres, we have to use the AND operator. And this is why there is an AND operator, even though queries are ANDed by default. If you look for values on the same field, you need $AND. Now we're almost done with the logical operators. There's one last operator, and that's the $not operator. Now, as you see here, it inverts the effect of a query expression. So what we could do here is we could look for movies that do not have a runtime of 60 minutes. Now I can use not to, for example, find all items, or let's do a count here to output less, to find all items where the runtime is not equal to 60. Now not does not work by putting it first. Instead, you specify the field you want to look for, like runtime, and then we can say not, and then the query which we don't want to run. So here I could say not equal, and now I need that equal operator. Here it is helpful because we got no other way of expressing this with not equal to 60. If I hit enter, I find 70 movies where the runtime is not equal to 60. Now of course, not will not be used that often because this complex query is essentially just equal to NE 60, right? That also gives us back the 70 movies where the runtime is not equal to 60. And for OR, you would have NOR. So there are a lot of other ways of querying for the inverse. But if you need it, if there is some query where you just can't inverse it in another way, then there is the not operator, which you can use to look for the opposite. Now with logical operators done, let's have a look at element operators. And there we got 2, exists and type. Now what do these do? Now to show what these operators do, I'll switch to a new database which I'll name user, which does not exist yet. And there I'll have my users collection where I'll insert many users. So some quick insertion training here. Let's insert some users with the name Max. Now I'll add some hobbies here, which actually is an array where I have embedded documents in the array. So not just text, but there I have hobbies with a title, let's say sports, and then also with a frequency, let's say 3 times a week, whatever. And then I got another hobby here, let's say title cooking, and I do that 6 times a week, let's say. So this is one user. Now I'll also add another field for that user. That's the phone number, not my real number, by the way, which might be this number. Again, this is not my real number. Now let's add another user, name manual. Hobbies is also an array here with title cooking, frequency 5, let's say. I'm not sure if that's the correct one. And then we got another hobby, cars, with a frequency of, well, hard to measure that. Let's say he's looking for new cars twice a week. I don't know. So let's say that is this data. Now we also add a phone number, and here it is some text. So also a number, but stored as text. Also not his real number. Now additionally here, we also got an age field of 30. So now I added 2 new documents. We can have a quick look at them with find pretty. Here's the data for manual, and here's my data. Now I deliberately have different types for phone, and I deliberately added this extra field because that will help us with exists and type. You might already be able to guess what these operators do. Let's say in our huge collection which we have here with 2 elements, we want to find all persons who have an age field. Now we can do that. Users is the collection name, and we can pretty print the result by finding all documents where age, and then we pass a document to configure our value for age, where age exists is true. We could also check for false, and we would find all documents where no age field exists. With true, we find all documents where it does exist. And if I now hit enter, we should find manual, who does have an age field. Now, of course, we can also use that together with other arguments. So we could also say age should exist and should be greater than 30. If we do that, we find no element because manual's field does exist. He does have an age, but he's not greater than 30. Greater than or equal, of course, would work and would return manual again. So this is exists. Now, exists is pretty straightforward. Now, let me add one more user to my database here with insert one. So to my collection, to my users collection. Name is Anna. Let's add some hobbies here. Title is sports. Frequency, let's say, is 2. And here we have another title, yoga. Frequency is 3, let's say. Now, for Anna, I will also add a phone number. Let's say it's also text and also not the real one. And then I also add an age here, but I'll set it to null. So it's not disclosed, you could say. Now, technically, that makes a difference, because if I now find all elements real quick, we see that for Anna, there is an age field. The value just is null, which is a special value, which is, well, just means there is no value there, but the field exists. Now, if I repeat my query from before, where I just check for the age field existing, I do find Anna too, because the field exists. It just happens to be null. Now, sometimes you want to find all users where it exists and where there is a valid value in there, though. Now, we could check false. Maybe it's included there, but no. With exists false, you only find Max, who doesn't have an age field. So if you want to make sure that age exists, but also that there is a value in there, you have to check that it also is not equal to null. So now I check for all documents where the age field exists, and that should of course be true and not age. So where the age field exists and where the age field is not equal to null. And now this will return manual again. So this is how you can use exists, and especially this combination with not equal null is quite helpful for making sure you really only have documents where there is a value in that field. Now that was the exists operator. What is type all about? Let's go back to our users and find them all. And of course, I did not by accident add phone numbers, which for 2 users are strings, and for Max, it's a number. Now that gives us an opportunity to work with the type operator. So let's, on the users collection, let's find all users where the type of the phone number is a number, let's say. And for that, I'll look for the phone number, and then I can use type and then specify the type it should be. Now, the types available can be seen in the official docs. If you check out the type here, you will find the available types. And these are the types I also touched on in my document schema module. So here you see we got string, we got doubles, which are floating point numbers, but we also got like the big integer decimal 128, which I'll also come back to in the numbers module in this course, numeric data module, I should say. So these are the different types of data you could have and you can check for. Also things like object or array or object ID. So these are the types you can check for. Now here, it's pretty simple. I want to find all phone numbers, all documents with phone numbers where the phone number is a number. Now number is an alias that basically sums up floats and integers. So this does work. If I would look for a double, it would also work though. Even though I have no decimal places here, by default, since the shell is based on JavaScript, a number I insert into my database will be stored as a floating point number, as a double, because JavaScript, again, which drives the shell, doesn't know integers and doubles, it only knows doubles. So it takes that and stores it as a double, even if we have no decimal places. This is why I can find this for double too. You can also use type a bit differently, and you can specify multiple types that would be okay. You then simply pass an array to type. And here you can say it's okay if it's a double, or let's say if it's a string. And therefore now I find all documents because they all either have a double, so a number, or a string. You can of course also filter for just strings. So this is the type operator and how you can use it to make sure you only work with the right type of data when returning some documents. Let's now come to the evaluation operators. Now, JSON schema is something I covered in the document schema module. You could also use it in a query to find elements that have a certain document schema. So you set up a schema there as a value just as shown for validation. Mod is the modulus operator. So here you could basically divide a field value with a certain number and then check if the result is okay for you. Text is something I'll come back to later in the indexes module. Where is deprecated and basically replaced with expression. So in the next lectures, we'll have a look at expression and regex. And let's start with regex. Regex allows you to search for text. And for that, I'll switch back to my movie data database and run some query on my movies. Remember, if we quickly find one, there we also have a summary field. Now let's say we want to search for a text snippet in there. We want to search for a musical, just because I see it here. Now what we could of course think that it will work is that we access our movies and then we find all movies where summary, that was the field name, is equal to musical. But if I do it like this, I find no entries, because this looks for full equality. So it would find all documents where summary is exactly equal to musical, written like this. Well, musical is just one word in there, though, and not the complete entry. So this does not work. Now, for finding text snippets, the most efficient way of doing it is to use a text index, something you will learn about in the indexing module. But if you don't have such an index, you can't use one, or you only have very short text snippets, which summary is already a bit above, to be honest, but let's still use it, then you can use regex query. But be aware that it will not be super performant. So what you could do here is you can specify $regex. And regex stands for regular expression, which is a way of searching text for certain patterns. Now you can dive deeper into regex. Setting up these patterns can be quite complex. We'll keep it simple here. A pattern is always surrounded by forward slashes, and in between you define your pattern. The simplest pattern possible is that you just type a word. And now this will not look for full equality, but it will look for this word in all summaries and return all documents where in the summary this word can be found. So if I now hit enter, now we find this item here where we see musical here. And note that it's a different item than we saw before, because if I scroll up, then here we have the musical comedy we saw earlier. So this is regex, nice for searching text, but not the most efficient way of doing that. Hence, definitely have a look at the text index in the indexes module. Now that was regex. Now what does expression do? Expression is useful if you want to compare two fields inside of one document and then find all documents where this comparison returns a certain result. Too abstract? Let's see what it does. Let's say we have a financial data database, and there I'll quickly prepare a collection, sales, and I'll insert many sales. Whoops, with square brackets. Now the first item has, let's say, a volume of 100 and a target of 120. The next item has a volume of 89 and a target of 80. And I have another item where the volume is 200 and a target of 177. So now I inserted 3 entries here. We can quickly check them out with find and then printing. So these are the 3 entries. Now let's say we want to find all entries, all items in this collection where the volume is above the target. This is a typical use case where expression can help us. Now how do we use that? We use it as such. We access our sales collection, and now in there I specify my filtered document, and I first of all use expr, which is this expression operator. Now expr takes a document describing the expression. You can then use a couple of comparison operators like GT. Now, by the way, check out the official docs to learn more about valid expressions and which operators you can use there. So GT is one. Now here I pass an array, and it will basically compare all these fields. Now, the interesting thing here is I won't enter values manually to find out which one is the greater item, because that's pretty redundant. Instead, here we now reference names of fields in our data. Now, in our data, remember, we have volume and target as fields. Now, you don't enter volume and target like this. This would be invalid. Instead, you wrap them in quotation marks. You wrap the data in quotation marks like this, volume and target. So now it would compare volume and target and only find documents where volume is greater than target. However, this would still not work, because right now it would still treat this as a hard input from your side. So basically as a string, and it would compare if volume is greater than target, and it would return everything, because from an alphabetic perspective, this is true. And that's probably also nice to know that greater than does work here too. If we want to refer to the field names, we have to add a $sign at the beginning. This tells MongoDB, hey, please look at the volume field and use the value of that in this expression. And you can't use that in every place in your queries. It does work on the expression query though. And later in the aggregation framework module, you'll find more places where you can use that. So now we're referring to the field names. And if I now hit enter, I only find 2 documents where the volume indeed is higher than the target. The first document, where that was not the case, is not included in the results subset. And that is of course super useful, because with this dynamic approach, we have an easy time of fetching the data where some condition within the document is met. So where 2 kind of related fields have a certain kind of relation that we check here. Now there also is a more complex form of expression. Let's say we don't just want to compare whether volume is greater than target, but let's say if the volume is above 190, the difference to target has to be at least 10. So we should still find this document. The difference is only 9 here, but it's also not greater than 190. For this, however, we should also still find it because it will be greater than 190, and the difference will then be greater than 10 to target. But how will we write this? For this, you have to adjust the part inside your greater than, or whatever your condition here is. The first value will now be a document, and there you use a special $cont operator, which is related to expression. So this cont is related to this expression. So both can work in tandem. The condition allows you to specify a document that describes a conditional value which it will derive here. So remember, we're still looking for a value we can use as a first element in our greater than array, and we just want to calculate that value dynamically. For that, in that cont document, we first of all specify a condition with if, and that has to be named if. If is then another comparison operator. So here we can check for, let's say, greater than or equal. Again, we have 2 values in here, and we want to check whether volume is greater than or equal to 190. Now, if this is met, then make sure to place the comma correctly after a closing square bracket and curly brace. Then we have a certain value we want to use. So this indeed is named then. And we can either hard code a value here, or we calculate it dynamically. Now here we can calculate it dynamically by passing another document and use subtract, which is an operator you can use to subtract 2 values. You specify an array, and you could hard code values to subtract these 2 values from each other. And by the way, subtract and so on, these are all aggregation pipeline operators. So no worries if that is a lot right now. In the aggregation framework module, this will all become a bit clearer and also easier. So subtract will subtract the second element we specify in this array from the first element. Now what I want to do here is essentially, I want to subtract 10 from volume so that the volume I use for a comparison is reduced by 10. So here, I will use volume as a first element, and then I subtract 10, hard-coded in there. Okay, so I subtract 10 from the value that is stored in the volume for all the items where the volume is greater than 190. Now that is one case. Now let's add an else case, because what is the case for items where the volume is not greater than or equal to 190? Well, there, I'll simply just use the volume without any changes, like this. So now we finished our condition, and that is the first value in our array here. So the first value is now simply either the volume, or if the volume is greater than or equal to 190, it's the volume minus 10. So for our volume of 200, we'll compare one of 190. Now the value we compare it to, and now I'm in the array related to the greater than operator, the value I will compare it to still is target here. Now if I hit enter, I do find the same set of data as before. But this will change if I switch the 10 which I subtract from my volume to, let's say, 20, that I require a difference between volume to 30, that I require a difference of volume to target of 30 if the volume is 190 or higher. Now I only get back this element with a volume of 89. because it's not as high. It's not making it into this comparison here. And therefore, I take the volume unchanged to compare it to the target value. But for this document, the volume is 200. Hence, it makes it into this condition and into this then block. Therefore, the volume I take for comparison is reduced by 30. And that is then not greater than the target of 177 anymore, because 200 minus 30 is, of course, 107. Now, this is a quite complex case here. And this is also not a query you might be running all the time, but it can be very helpful. Now, for all the comparison and change operators which we used in there, again, this is something you'll also see in the aggregation framework module, and it is something where you can dive into the official docs to see all possible values there. This is a quite powerful command and therefore definitely worth playing around with. But for now, I just wanted to explain how it generally works and how you have to think about it. Let's now dive into querying arrays a bit deeper, because there are multiple things we can do when it comes to querying arrays. And there are special operators that help us with querying arrays too. Now, first of all, I'm back in the same database I was before. And please note that I will also work with the data we used in the assignment. So if you skip the assignment, at least download the attached data and import it as described in the first, or as requested in the first assignment task. You don't need to complete the rest, but you need to have that data in your database. So, first of all, I will, however, switch to my user database here. And in there, remember, we had a couple of users. Let me print them. We had 3 users here. Now, the users had hobbies. Now, let's say we want to find all users who have a hobby of sports. Now, one problem we have is, of course, with that structure, where hobbies are embedded documents and not just strings, that it won't work if I search and print for hobbies being equal to sports. Because there will be sports in the hobbies, but that's just the value of a field of an embedded document in the array. So if I hit enter, I don't find any documents. How can I now find all hobbies that are sports? Well, of course, we could search for exact equality and pass a document here and search hobbies for nested documents, embedded documents, where the title is sports. But if I hit enter there, I also find nothing because we have no hobby documents in the hobbies array that look like this. Our documents also have a frequency. So yes, I could, of course, add the frequency here. And I could look for a frequency of 2. And now I would find Anna. But I don't find Max, because for Max, the frequency is 3. So this does not really get us anywhere. We can't really use this way of searching for sports. But what if I really just want to find all documents that have an embedded sports document, no matter what the frequency is? Well, this is also pretty simple to do in MongoDB. We just need to change our query a little bit. Instead of just looking for hobbies and then looking for an equal document, we can use a path here, wrapping it in double quotation marks with dot notation. And I can look for hobbies.title being equal to sports. Now, the interesting thing here is title is, of course, something we can see on the documents that are inside the hobbies array. So we can act as if hobbies would hold just an embedded document and dig into properties of that embedded document, even though here we got multiple embedded documents in an array. But MongoDB understands this syntax, and what it will do for this query is it will essentially go through all the elements in hobbies, and for each element, it will dig into the document and compare title to our query value, so to sports. And therefore, if I now hit enter, I do find Anna and Max. And this is a super useful syntax for querying array data that you absolutely should keep in mind. That you can use this path embedded approach not only on directly embedded documents, so if you have one embedded document in a field, but also if you have an array of embedded documents. And then you can use the same query world with greater than and everything you want as before. You don't just have to look for equality. You could have a document with greater than, lower than, with an expression, whatever you needed. So that is possible here too. So after this useful piece of advice, let's now have a look at some dedicated array query selectors that can help us find the right query. Let's start with size. Size is pretty straightforward. Now here in our collection, if we have a look at all our users, we can see that they all have the same amount of hobbies. They all have 2 hobbies. Now let's therefore add a new user with insert1, and that user will generally follow the scheme and have a name. Oops, we don't need to wrap that, but we could. The name is Chris, let's say, and we can specify an age and the other parts. That doesn't really matter. Let's specify the hobbies. That matters. And we can even use a different approach here and say sports, cooking, and hiking, like this. So here I don't have embedded documents. I could add them. It really doesn't matter. To save time and space, I'll just use strings. So now I have one new user in the database, Chris. And now I want to find all users who have 3 hobbies, which should be just Chris, because the other users have 2. And it doesn't matter whether a hobby is an embedded document or just a string. It's just the amount of items in the hobbies array that matters. To find all users with exactly 3 hobbies, I can look into my users with find. And now the value for find is that I use hobbies, and I'm looking for a size of 3, written like this. If I hit enter, I only find Chris. Now what's important to understand about this command, by the way, is that this has to be an exact number. You can't say, give me anything with more than 2 items. If you need something like this, you'll have to retrieve your data differently. This is something MongoDB does not support yet. You can only look for exact matches here. With size out of the way, let's now have a look at all. For that, I will use the data I also used in the assignment. So for me, that is stored in the box office database. So let's use box office. And there, if I have a look at all collections, we see there is the movie starts collection. So I'll work with that movie starts collection, movie starts. Let's quickly have a look into it without any filter to see what's in there. We got 3 movies. And now let's say I want to find movies that have a genre of exactly thriller and action. But I don't care about the order because I got 2 movies, this one, and they both only got thriller and action. The problem I will have is if I use my movie starts here and I find my movies by the genre and I say it has to be exactly equal to action and thriller, then I will only find 1 document because only this document is exactly equal to action being the first element and thriller being the second element, which is what I specified here. But what if I don't care about the order? Well, then the all operator can help me. For this, I simply wrap my array in a document where I use $all as an operator, and that operator receives my array then. And we also need to close that extra curly brace. What this will do is it will now search genre for these keywords, and it will make sure that these items do have to exist in genre. And these items could be numbers, could be embedded documents, could be other arrays even, doesn't matter. But it ensures that these 2 elements exist in genre, but it doesn't care about the order. And therefore now I find both documents, even though the order is different within genre. So all is really useful if you don't care about the order, you just want to make sure that all fields are included, but the order does not matter for you. Let's now jump back to the user database. And in there, just a quick reminder, we got that user data. Now, let's say we want to find all users who have a hobby of sports, and the frequency should be equal to 2. So the frequency of the sports hobby. Let's try this. Let's reach out to our users, and we want to find all users where this is true. Now, how could this query look like? Well, we could use the AND keyword, and then we have multiple conditions. And the first condition is that for hobbies.title, we're looking for sports, right? This was the first part. It should be sports. The second condition could be that hobbies.frequency should be equal to 2. And that also has to be wrapped in curly braces. Or let's say it should actually be greater than or equal to 2. If I hit enter, yeah, I find Anna, makes sense. She has sports and frequency 2. And I find the whole document, of course, because find always gives me the whole document. Even if I'm just digging in some array or embedded document, it doesn't return the embedded document, but always the full document which contains the embedded document. So I find Anna because she has sports, title 2, frequency 2. I also find Max because there I got sports, frequency 3. Now let's say I repeat that query and modify it slightly. And now I'm looking for a frequency greater than or equal to 3. Now, what's that? I still find Anna, even though for her sports hobby, the frequency is 2. But our query was that the frequency should be greater than or equal to 3. So what's going wrong here? The thing is, with this query, we're basically saying find me all documents where in hobbies there is a document, at least one document, with the title sports and a document with the frequency greater than or equal to 3. It does not have to be the same document. That is our issue here. And indeed, for Anna, yoga has a frequency greater than or equal to 3. She has a sports element, so the first part is satisfied, and the second part is satisfied with that other element. Now, of course, it's not that uncommon that you want to ensure that one and the same element should match your conditions. And for that, you have the elemMatch operator. So this query, and I'll just count it so that we have it still on page, this query can be replaced with another query that should do what we want. Instead of AND, we specify our array, hobbies, and then a value, which is a document, where we use $elemMatch. That then again takes a document as a value, and here we then describe how to match our element. Now, if hobbies were just an array of numbers, let's say, you could immediately start typing greater than 30, but lower than 50, for example. So that would be the case if hobbies would really just be an array of numbers, not of embedded documents. However, here we have embedded documents. And in this case, elemMatch is a document where you now describe what to look for inside of the embedded document. So here we're saying title should be sports, and the frequency should be, and now here we can still write our old condition, GTE 3. So this is how we can now use elemMatch on an array with embedded documents. We essentially, you could say, describe how a single document should look like to match our query. And if it finds at least one document in the hobbies array that has a title of sports and a frequency greater than or equal than 3, it will include the overall document that contains that hobbies array in the result set. If we got multiple elements in the hobbies array fulfilling this criteria, that would also be fine. And if I now hit enter, I only find Max and not Anna anymore, because Max is the only user who has a hobby with a title of sports and a frequency of 3. Now this is actually it for the query selectors and operators. Let's now briefly come back to that cursor thing, which I already touched on earlier in this course. The find method, unlike the findOne method, yields us a cursor, if you remember. Now, why is that important and why does it do that? Well, if we have our client communicate with the MongoDB server, we potentially get back thousands or even millions of documents with find, especially if we have no condition in there. But even with a condition, you easily have a condition that still meets like 1,000 documents or more, depending on the scale of your app. So you get back all these results. And that is very inefficient because all these results have to be fetched from the database. They have to be sent over the wire, and then they have to be loaded into memory in your client application. So these are three things that are not optimal because chances are you will not need all 1,000 documents at the same time. And therefore, find gives you a cursor. A cursor is basically a pointer which has the query you wrote stored and which can therefore quickly go to the database and say, hey, give me the next batch, give me the next batch. And indeed, you work with batches of data then. You fetch the data one by one, so one document by a time. And it really is only transferred over the wire when you request the next one. Now in the shell, we get 20 by default because the shell automatically basically takes the cursor and gets us the first 20 documents before we can get more. If you write an application with a MongoDB driver, and we'll see that in the from driver to shell module at the end of the course, then you have to control that cursor manually and make sure you get back your results. And that cursor approach is great because it saves resources. If you have a query that meets 1,000 documents, but let's say you have a website where you only display 10 items, let's say 10 products you fetched at a time anyways, then there is no need to load all 1,000 results that matched your query right at the start. Instead, you would only fetch the first 10, display them on the screen, and then go ahead and fetch the next 10 when the user navigated to the next page or anything like that. This is the idea behind a cursor. Now, we'll find out how to work with a cursor later, as I mentioned, when I talk about how you use the MongoDB driver in a real application, but I can already show you some things in this module. So in the next lectures, we'll play around with the cursor a bit. To play around with cursors, I'll use my movie data database. And there, remember, we had movies where, if I counted, we have 240 documents. By the way, count is already one method. We can chain on a cursor because find gives us a cursor. So whatever we call here is called on the cursor. And count simply has a look at the cursor and determines how many elements can I get from the cursor. So that's important. How does this work technically? Well, on the database side, the query will already have ran, and therefore information like this is already loaded into memory and ready to be delivered to us. So it's not like that if we now cycle through all the elements, we have to manually read them from a file. They have been loaded efficiently into memory there already. So now, with this, we can of course execute find with the pretty command, and the pretty command is really just a utility command. We could also output it like this and get a bunch of documents. To be precise, 20. That is just something the shell does for us, and the shell also gives us this shortcut to type IT to get the next 20. And we can do this until this is exhausted. The IT command will not be available to you when working with a driver, and there you will indeed work differently with the cursor. So on find, then in most drivers you will have some next method you can call. Now, if I call next here, I get back exactly one document. Hence, you also see no type IT to see more at the bottom. I get back exactly one document because next gives me the next document. The cool thing is, now that I called next, I got back glee with the ID 8. If I call it again, I get back the next document in line. However, this again is glee because this query is now basically executed from scratch. This is different if I store my data cursor, however you want to name it, could name it just cursor, in a variable or constant. And since the shell uses JavaScript, I can use JavaScript syntax to create such a variable here. So here I can use dbMovies find without any condition to find all. And now I can use my data cursor here with next to get the first element, which again is glee with the ID 8. And if I now use that same cursor again with next, I get a different element with the ID 7, homeland. And if I type this again, I get yet another document, ID 5, true detective. So this is the cursor doing his work. The cursor also has other methods. So that was our data cursor here. If I execute it like this, it gives me 20 documents again. But if I use that data cursor, I also can specify a for each method. Now again, this will vary on the driver you're using. For JavaScript, you can use it like this. For each takes a function that will be executed for every element that can be loaded through the cursor. And now in there, we therefore get the document. Now this is just a special function syntax provided by JavaScript with that arrow here. Here is the input to the function, which is given to us by the for each method. And here is then our function body, where we write what we want to do. And then we got print JSON, which is a method provided by the shell to output the document. And what this would do now is it would cycle through all the documents that are in the cursor. And that, by the way, are only documents we didn't look at yet. So the 2 we fetched via next and the 20 we fetched via just typing the cursor name will be excluded. And now we will cycle through the remaining documents which we haven't fetched yet. And it will fetch them from the database and output them here, as you see. And that is why you see no type it to see more at the bottom, because we did now fetch all documents in the database simply with for each. So this is another way of using the cursor to go through all the documents. And of course, inside of the function you execute on every document, you could also have some condition, a if check, to, for example, see if you want to output that document. Though, just be aware, if you use a if check to filter out a document, it would be more efficient to filter that already as a filter in the find method and not fetch it from the database. Because here, you're only filtering on the client side. That, of course, is not as efficient as filtering on the MongoDB server side. But you can run any code you want on all the documents, or as I mentioned, use next to only fetch one at a time. By the way, if I execute next now, I get an error because the cursor has been exhausted. You can check for that manually with the has next field here. Function, has next function. This is false, and this indicates there is no data to be fetched. If I recreate my cursor by again reassigning it, and this was a constant, so I'm not allowed to do that. So let's create a new one, just named cursor. So now I'm creating a new cursor based on the same query, but the shell doesn't know that. So I got a new cursor. Now on that cursor, if I call has next, I get true. And hence I can safely execute next. Now with cursors, you can do a couple of other things too. There are other methods you can execute. And again, this is something which you can always, of course, find in the official docs. There, under MongoDB CRUD operations, query documents, you want to have a look at iterate a cursor in the Mongo shell to learn more about using that cursor and different ways of iterating through it. And we'll also have a look at how to use a cursor in the environment of our MongoDB drivers. It is important for you to understand what a cursor is and why it exists, though, and I hope this became clearer.